Good afternoon, everyone. So, who is here? Let me check. Sanidhya, yes, Sanidhya, 5 minutes are over, right? Ishan, Arnab, yes, good afternoon, Sanidhya. So, today we will be starting a new chapter. Okay. So, we had finished 2 chapters earlier, and today we will be starting with a new chapter. And that name of the chapter is Elements, Compounds, and Mixture. Yes, good afternoon, Arnab. Good afternoon, Srijani. So let's start. Good afternoon, Vaishani. So shall we start? It's almost 2. Yes? Okay. So today we are learning about elements, compounds, and mixtures. So this is your chapter which has been divided into 5 lessons. So today we will be basically talking about what atoms and molecules and how these elements are formed. Today we will be talking about all that. So this is what about it. So everything that you see around us, atom, everything that we have in the matter class, we also talk about a lot of states of matter, right? Everything that occupies space and time, all of this is composed of atoms. Okay, so can anyone tell me what exactly is an atom? Are you all familiar with what is an atom? So Arnab is saying atoms is the smallest particle of matter. Anyone else? Smallest particle of a chemical element that can exist. Okay. So they have all the properties. Okay. So basically you are saying that the smallest particle in our universe is an atom, right? That is what people are saying. It is the smallest particle in our universe, right? So do you all agree when I say that the atom is the smallest particle in our universe? No. Smallest particle is an element. Sanidhya is saying an atom is the smallest particle and millions of atoms can form a single atom. Yes, yes. Ishan is saying no. Then what is the smallest particle? Srijani is saying yes. Ishan is saying yes. Whoever has said no, what do you think is the smallest particle? Quarks. And what exactly are quarks, Ishan? Very good. So we came across another term today called quarks. What are quarks? Any idea? Elementary particles of an atom when we break protons and electrons, right? So let's come to all of this. Okay, so basically what happens is that in all our universe we start with very small things. We start with very small electron, protons, and as we grow we can finish really big. So for example, if we start with small particles of matter, like you people are saying, quarks, proton, electrons, all of these, then we form atoms together. All of these form atoms, and then comes molecules, macromolecules, cell organelles, cells, tissues, organs, systems, then organism, then a total population, ecosystems, then we compose the entire biome, then planets, systems. So we see that we start with really small particles and we end up with really big things like the universe. Okay, and not just one universe, there may be multiple universes out there. So we finish with really big things. Okay, so for example, in our chapters today, in elements, molecules, and compounds, you will be learning about all of this, all of these, and how elements and particles and compounds are actually made. But before we start with all of the elements and compounds, we have to know what is an atom and how approximately what is the size of an atom. So, for example, if you have an apple, okay, everyone has seen an apple, and if you have an apple which is magnified to the size of the earth, so if you magnify this apple to the size of the earth, then in an apple would be the size of an original apple. Okay, so for example, if this apple is magnified to the size of the earth, then every small atoms which is present within the apple will actually be the size of an apple. So can you understand the relative mass of it? How big an earth is, and basically on the earth, basically an atom is one apple. It is the size of one apple. Okay, so it is this big. So what do you think are the rest of it? What is there in the rest of it? So what is present in the rest of it? Would anyone like to answer? Yes. So as I was saying, Sambhav, that imagine you have one apple, and if you magnify it to the size of the earth, okay, you have magnified this apple to the size of the earth, then each atom, the size of an atom will be basically the size of an apple. So, for example, if we are talking about one element, so if the element has the entire size of an earth, then one small apple is basically the size of an apple. So we are talking about the sizes. Okay. So one apple which is present on the earth is basically one atom. It is relative to the size of one atom. The rest of the area is, yes, so the rest of the area, the rest of the everything else around the atoms would be space. Okay, so that is empty space. And when we come to atomic structure, I think you have atomic structure in your next classes. So when you go and study about the atomic structure, you will understand that what these spaces are. So for example, an atom is composed of particles called the protons, electrons, and neutrons. Okay. So this is how an atom exactly looks like. I'm sure all of you have seen an atom. So this is exactly what an atom looks like. So you have the electrons, which is revolving around the center. And the center of the atom consists of protons and neutrons. So these yellow balls are the protons and the blue balls are the neutrons. So this is the nucleus of the atom, whereas the electrons, they travel around. So every atom has three basic parts. You all know about this, right? So for this matter, you cannot create or destroy it. You cannot divide an atom, you cannot destroy it. You can just change it, as we learned in our states of the matter class. So protons, neutrons, and electrons. What happens next? So each of these have a different charge. So neutron is a large mass with zero charge. So basically it's called neutral charge. Okay, so it has a zero charge, whereas protons have positive charge and electrons are the smallest of all these three. Electrons are the smallest and they have the negative charge. So every particle in an atom has different charges. So is this part clear? Which has what charge? So the neutrons and protons, they make the nucleus together and they have. So what is the total charge of the nucleus? Will it be positive charge? Ujan, we have just started with elements, compounds, and mixture. Okay, you haven't missed anything. So we are just learning about atoms and the different elements of components of atoms. What is space composed of? Space is also composed of atoms and molecules and elements, all of this. Arnab is saying positive charge. Right. So what is the charge of the nucleus? Arnab has answered positive. No, Sambhav. Listen to my question very carefully. I'm saying what is the charge of the nucleus of an atom? The nucleus, does it contain an electron, Sambhav? Yes, Rijoni is saying positive, right? Sanidhya is saying 0. Sambhav is saying no, I think. Ishan is saying positive. Ishan is saying positive. Yes, so the correct answer is positive. The nucleus contains only the neutrons and protons. So the nucleus have only the neutrons and protons, and if you have 0 and plus, obviously the entire charge will be plus, whereas the electrons have negative charge. They have minus charge. All right. So this is exactly what happens. So an atom, as Sambhav was saying, is, yes, absolutely right, Aishan. Neutron is 0, then only positive charge of the protons. So what is here? See, this nucleus is in the middle. So in the middle, you have a proton which is positively charged and a neutron which is 0 charged, and the electrons are moving around its orbit, having negative charge. So basically, in all atoms, what we have is that we have it as an electrically neutral atom. What does it mean? Electrically neutral? Electrically neutral money. It means that there is no charge present on it. And can someone tell me why is there no charge present on it? Are electrons orbit due to gravity and mass of the nucleus? Yes, electrons do orbit because of this charge, not because of gravity, but because of the charge. Okay. So who can tell me why, how is an atom electrically neutral? Sambhav, which is very what Sambhav was saying a bit earlier. Why is an atom electrically neutral? How can an atom be electrically neutral? Zero কখন হবে? সব মিলিয়ে zero হতে হবে. Electrically neutral মানে no charge, zero. You have a positive charge and you have a negative charge. You have protons and you have electrons. How will it be zero? No, Arnav. Yes, Sambhav is right. When the amount of electrons and the amount of protons are equal. Absolutely correct. So for example, if you have 4 plus charge and 4 minus charge, what will be the total charge? Plus 4 minus 4? Yes, absolutely. Yes, Sanidhya, Adrita, right? Absolutely right, Sambhav.
My name is Adrito.
Okay, so Adrito, thank you for correcting me. This is going to be 0, right? So is this part clear why an atom is electrically neutral? Good. Okay. So what do we study next? So as you all were saying, you were saying something about quarks, right? So yes, quarks are something which you get when you break apart these protons and neutrons. So basically, as we were learning about the states of matter, this is nothing but a representation of that. How one small elementary particle, they change it into a matter. So you have quarks which make up protons and neutrons, and these protons and neutrons, they make up the nucleus. Yes, as Arnab is saying, bosons and leptons are also there. We have lots of elementary particles, right? But for the sake of this class, even quarks are not included, but just for the sake of what makes up a matter. Okay, so you have quarks, boson, leptons, yes, whatever. So quarks, they make up protons and neutrons, which makes up the nucleus of an atom. Now, nucleus with electrons, you have electrons surrounding the nucleus, which make up one entire atom. And when all of these atoms, they come together, yes, as I think Ujan or Ishan was telling me about this. So as all of these electrons, they come together, they form a matter, kind of like a solar system. Absolutely, Ishan. So we go from very small to very big, right? So this is what we were learning about. We go from small to big. So till here, does anyone have any questions regarding atoms and whatever we learned? Okay, good. This is very easy. I think you all studied about this previously. Now, now we will, what's the smallest thing? The smallest thing right now is a quark. Okay, so it happens when you break apart a proton and a neutron. So you get quarks. So what happens with an ion? How do we generate ions? Electrically charged gas molecule is an ion. Yes, electrically charged gas molecule is not exactly an ion, but they are made of ions. Okay, so in any charged molecules, any charged compounds or molecules are made up of ions. What is the smallest quark? Quarks are the smallest thing. There's no smallest quarks. Okay. So how do you generate an ion? How exactly do you generate an ion? So these blue balls, they are getting shifted from one atom to other. Yes, yes, as Aishani is saying, an atom or a molecule with a net gain, with a net electric charge due to the loss of gain of more electrons. Anything smaller than quarks. Right now, there's lots of experiments happening to find out what exactly is the smallest matter. So right now, we know published data says it is quarks, but maybe there are other different types. Yes, there are lots of other types of quarks as well, Isha. Lots of different types of elementary particles are coming up, but for now, yes, as Arnab is saying, right. So all of you are right here. So what is happening is that these electrons, they are being shifted from one atom to the other. Okay, so these electrons, when they are being shifted from one atom to the other, we are generating an ion. So when these electrons, they are getting shifted, does this atom, what does this become? So this atom is giving up a lot of negative energy. So what is the net energy of this atom? Who can tell me? No, they do not take any activation. No, sir. No, not heat. So remember, this was electrically neutral. So that this atom was zero. The charge of this atom was zero. Now we are not talking about heat or energy. We are talking about charge, plus, minus, zero. Okay. So this atom was zero. So this atom, it is now giving up a lot of electrons to the next. So what happens to this atom? Can anyone tell me? What happens to this atom? Arnab is saying positive. Sanadhya is saying positive. Jan is saying negative. Okay. Aishani is also saying positive. It lacks electron. Yes, Sanadhya, it becomes positive as Ishan is saying. Okay. Yes, we will be coming to that. Yes, Adrito is also saying positive. So for now, even if it is becoming positive or negative, we will come to that later. But one thing is for sure, it is not zero anymore, right? It is not neutral. It is either becoming positive or negative. It is not neutral, right? We are clear till this part. That when this atom is giving up a lot of electrons, it can never be neutral. So what exactly is happening? Yes, as you all were saying, that atom would have become positive. Cano positive because obviously it is giving up it is giving up its negative electrons, right? So electrons are negative. So what is happening? As soon as this atom was giving up its electron to the next one, right? It is giving up. So ultimately, what is happening to this previous atom? Initially, it had 3 electrons. Now it had 2. So net charge. What is the net charge of this molecule? What is the net charge of this molecule? So it is plus 3 minus 2. What is the net charge? Positive. How much positive? Yes, absolutely right. Adrito, Arnab, Sanidhya, right. So this is plus 1. So this becomes a positively charged atom, which we call as an ion. Now, what do we call a positively charged ion? We call it a cation. Okay, we call it a cation. So any ion which has positive charge, we call it a cation. Similarly, if we talk about the reverse, so this gave up one electron and this received one electron. So what is happening? Initially it had 3 electrons and now it has another one. 4. Yes, negative. Absolutely right, somehow. Negative -1. So when an atom has a negative charge, right, Aishan is absolutely right as well. So when we have a negative charged atom, we call those an anion. So is this clear? Cation and what is an anion? But ma'am, why do we call a negative electrode as a cathode? Very good question, Ishan. Cathode. Cathode comes from the word, it is similar to the word cation, right? Cathode, it is similar to the word cation. But as Ishan is saying, cathode is negatively charged. Who do you think will go to the negatively charged electron or negatively charged electrode? Which of this? Cation will go or anion will? Remember, cathode is negatively charged. Who do you think will go? Positive charge. Cation will go, right, Ishan? Cations will go. So since cations go to that electrode, we have named that electrode as cathode. Yes, absolutely. Yes or no? Positive plus negative attractive. Clear? Cano, why is it called cathode now? Very simple logic, like a magnet. Absolutely right. Very, very simple logic. So this is cations and anions. Any questions so far regarding cations and anions? Everyone understand what is a cation, what is an anion? Good. Now we come to something very, very interesting. We were talking about giving up of electrons. Now, how exactly is this electrons are given up? What happens? So, for example, you have two puppies here, the yellow puppy and the purple puppy. Okay. So, let us consider these puppies as atoms. Okay. So, these two puppies are two atoms. Now, what is this bone? This bone is an electron. Okay. This bone is an electron. What is happening in this picture? One of them, this purple puppy, had one bone. So this purple puppy gave his bone to the yellow puppy. Okay. So he actually gave his bone to the yellow puppy. So when one atom donates an electron completely to the other atom that you see here, what is that sort of bonding called? That is called an ionic bond. Okay. That is, so this puppy gave his bone completely to the other puppy. Okay, so when you completely donate or take a bond, when one atom completely either donates an electron or one atom takes an electron, so here we call it an ionic bond. So they have an ionic bond. Okay, what about the next scenario? So again, these two puppies had two bones. Okay, these bones, you know, they represent the electrons. Okay, so one atom had one electron, another atom had one electron. Now these both puppies, they are sharing these two bones, right? What if they give incomplete, as Arnab is saying? So this is an incomplete separation, right? They have not given each other, they are sharing the bone, they are sharing their bones among one another. So what has happened there? This is called a covalent bond. Ishan is saying, are ionic bonds stronger or covalent? What do you think? In ionic bonds, you know that they are completely giving the electrons. Whereas in a covalent bond, they are sharing it. Sanidhya is saying ionic, Arnab is saying covalent. So what do you think will be, where is the more strength? If you are divided or if you are united together in a class? So for example, if all of your friends are united together, are you more strong or are you less? Yes, absolutely. Yes. So when you are united together, you are stronger, right? So what do you think will be more strong, covalent or ionic? In covalent bond, you see that the two atoms, the two puppies, they are joined together. Whereas in an ionic bond, they are not joined together at all. So what do you think? Yes, yes, the answer is covalent. Yes, Adrito, Ujjan, Sanidhya, right. Any questions regarding covalent and ionic? Do we now understand what is the difference between covalent and ionic? Sanidhya is asking a question. One atom has 3 and he has shared 1/5. 1/5. I don't understand your question clearly, Sanidhya. Anyway, okay. So let's move to the. So now I have a question. So for example, there are two people here. So this is scenario 1. So Emily is here and Sarah is here. Okay. And Emily is very hot. Emily is sweating. So Emily does not want this blanket, but Sarah is cold. Okay. So Sarah wants a blanket. So Emily gives her blanket to Sarah. So what bond is this? Sambhav, Ishan, Sanidhya, Ujan is saying covalent. Arnav is saying ionic. Srijoni is saying ionic. Adrito is also saying ionic. Yes, Ujan. Why is this covalent? Why do you think this is covalent? What did we learn about in covalent? Ujan is saying it is covalent because both are using it. Well, Ujan, both are not. No. Both are not having the. It is not about having an advantage. Okay. Right now, we are not talking about having an advantage. We are talking about one person is sharing or giving up the blanket to the other. Okay. Yes, as Sambhav is saying, the blanket was given away. They are not sharing. Okay, Ujan, I understand. Okay, now I understand why you said it is covalent, because she gave it up, but do not think of it in terms of advantage. Okay. Think of it in terms of whether the blanket was shared or was it given up. So now what do you think is the answer? Does everyone agree now that this is an ionic bond? Yes, yes, Anitya. Everyone agrees? Good. Now we go to the next one. So in this case, both Emily and Sarah are feeling cold. Okay. And now they have shared a blanket together. Yes, Sambhav, Sanidhya, both are saying covalent. Anyone else? Ujan, covalent? Aishani is also right. Yes, absolutely. Adrito, Srijoni. Any doubts? Anyone has any doubts so far regarding ionic and covalent? Good, very good. Okay. So now when we come to it in terms of elements, okay, what is happening here? So sodium, okay, so sodium has this one electron, whereas chlorine has 7 electrons. So now this is another that we will come into in our next classes. This is called valency. Okay. So what happens is that in an electron, you will learn about this when you learn about atomic structure. So they have these orbits, and in an orbit, most of the electrons, they want to have 8, most of the atoms, they want to have 8 electrons on the outside. Okay. It is either 0, 2 or 8. Okay. Right now, you do not need to understand this. You will learn about this when you learn about the shells and orbitals, all of this. It will be a little difficult for you to understand right now. But for now, just look at this example. It is an example of an ionic bond. Why? Because Na is completely donating its electron to the chlorine. Yes, yes, absolutely right. They're combining to balance one another. Very good, very good. Very good. Yes, Sanidhya, Sambhav, right. Very good. Okay, so you all have the basic idea of balancing. Good. Right. So Na is donating an electron and chlorine is accepting one electron. Right. So they are together forming NaCl, sodium or table salt. Right. The common salt that we have, that is NaCl. Now this is an example of an ionic bond. Why is this an ionic bond? Because sodium is completely donating its electron there. Yes, sodium chloride. Absolutely right, son. Any doubts? Now do you understand? They were both sad because they were incomplete. So Na had one extra electron, whereas chlorine had one less electron. And now that they have given up, they have together formed NaCl. What is the name of this ion? Na plus, cation na anion. Na plus ki korche. What is the name of this? Yes, very good. Very good. Cation. And Cl minus is the anionic form. Right. Absolutely. Very, very good. Next, we come to a covalent bond. What is happening now? You all know covalent bond key. Obviously, the chlorine had 7 electrons in its end. Right. So chlorine had 7 electrons and chlorine wants 8 electrons. But both the chlorines have 7 electrons. So if one chlorine gave up 1 electron, one would have 8, yes, but the other would have 6. Right. So instead of giving up 1 electron, these chlorines, they have decided to share 2 electrons among themselves. Okay. So in turn, what had happened? What has happened? Both the chlorines have become complete. They have 8 electrons and they have become complete. So both of them are happy. Yes, absolutely right. So they are sharing 2 electrons and in turn they have become Cl2. Yes, chlorine, right? Yes, absolutely right, Sampha. So they have become this chlorine Cl2, like, right? Yes, yes, right. Yes, Sampha, it is called chloride. Okay. So it has become Cl2. Now what do you understand? What does this, what has this become now? Cl2 is now 2 atoms of chlorine, right? For example, NaCl was 1 atom of sodium and 1 atoms of chloride, whereas Cl2 is 2 atoms of chlorine. Yes, absolutely right. They are sharing. See, they are sharing here. Both of them are sharing here. No, they do not become any anion. Are they giving up any electrons? Have they giving up any electrons? No. As long as they are not giving up any electrons, they are not giving up any charge. Right? They are not taking any charge. They are not giving up any charge. Your friend has one red pen and you have a blue pen. So you are saying you keep the red pen. I will use the red pen when I want it. And your friend has said, okay, I will use the blue pen when I want it. Okay. But you people have not actually given your pens to one another. So that is why there is no charge separation. So this is another very important question. Charged ions happen only in case of ionic bond. Ionic namtai ashe from the word ions, right? Because in ionic bond, you must have ions. Someone has to give up something and someone has to take something, right? So that is why it is called an ionic bond, because it is made up of ions. Whereas in a covalent bond, there is no concept of ions here. You are not having any ions. How do the negative and positive charge interact with one another? In case of a atom, is this what you're asking? So they are attracted towards one another. All of these, all of the ionic bond, covalent bond, any bonding is basically like an attraction, like a magnet is exactly like a magnet. Yes, it works like a magnet. So you know, opposite charge, they attract one another, like opposite magnetic pole. So opposite charges, they also attract one another. So it is basically a love between two atoms. So this is how you form chemical bonds. So molecules form when two or more atoms, they form chemical bonds with one another. For example, you all saw chlorine, chloride, Cl2, right? So when you have Cl2, what is happening? Two atoms are joining together to form one molecule. Okay. So for example, hydrogen, H2, nitrogen, you have N2, oxygen, chlorine, iodine, bromine, chlorine. So all of these are molecules. They are all molecules. Okay, we will come to what compounds are. For example, H2O, N2, O3, CaO, glucose, table salt. Okay, we will come to the differentiation between compounds and molecules. But right now, have you understood this? Why these atoms are coming close together? Because they're sharing chemicals. Yes, absolutely right. So compounds are made of elements mixed in a fixed ratio. Right, right. We will be coming to compounds. So why does this happen? Why do they come together? How do they come together? They come together by the means of chemical bonds. So for example, when you have two atoms joining together, we call these diatomic. Di means two atoms. You all know what atoms are right now. So diatomic means that they are composed of two atoms. All of these are made up of two atoms, right? Chlorine, bromine, iodine, fluorine. Okay. All of these are made up of two atoms. Two atoms, they are called diatomic. Okay. What if it was one made with one atom? What would we call these? One atom. Monoatomic. Absolutely right. Sambhav, Arnav, very good. It is called monoatomic. Mono means one. Okay. So for example, the different types of molecules, what are these? You have monoatomic molecules, right? So monoatomic molecules are molecules with only one atom. For example, helium, neon, krypton, all of these, they are also known as inert gases. We will be coming to inert gases in our next lectures. All right. We will be talking a lot about periodic table. So these for now know that these are known as inert gases. Inert cano bole because they do not react with one another. They have all their electrons. Yes, absolutely right. They don't chemically react. They have all their electrons. So they do not need to give or share anything. I have both my red pen and a blue pen. I do not need any help from anyone else. So I do not need to chemically react with anyone else. Okay. So in these cases, we call them monoatomic molecules. Basically, they are inert gases. For example, helium, neon, krypton. Whereas diatomic molecules are not made with one atom. They are made with two atoms. For example, hydrogen, carbon monoxide, chlorine gas. All right. So all of these are made with two atoms. So we call them diatomic. Polyatomic poly means more than two. Poly means more than two. So when you have two, when you have more than two, three, four, anything, we call those molecules as polyatomic molecules. For example, water and phosphorus. Four, right? Phosphorus is made with four, whereas water has three atoms, two of hydrogen, one of oxygen. So together they made a polyatomic molecule. Is this part clear to everyone? Till now, anyone has any questions? Any questions? Anything you did not understand? Triatomic is absolutely also correct. So triatomic, tetraatomic, এগুলো সব পড়ে under the classification of polyatomic. Tri means three, tetra means four. All of this come under the classification of polyatomic. Okay, poly means more than two. So all triatomic, tetraatomic. So for example, phosphorus is tetraatomic. Tetra means four. Tri means three. So water is a triatomic. It is also called triatomic. If you say it's a triatomic molecule, that is absolutely correct. But for the broader classification, we call it a polyatomic. Good. Now we come to the last concept of today's class, which is atomicity. Now, what is the largest molecule? I will look that up, Isha. I'm not sure about what is the largest one. Right now, I don't. So I will look it up and I will tell you all. Okay. So now we come to atomicity. So atomicity is determined by adding the number of atoms present in a molecule. So what is the atomicity of one compound or one element? Not an element of a compound or a molecule. It is the number of atoms which is present in an element or a compound. For example, hydrogen had two atoms. So H2, oxygen had also two atoms. So the atomicity of hydrogen and oxygen is 2. Okay, so what is atomicity? Atomicity is the total number of atoms which is present. Now, can someone tell me what are the atomicities of these? A, let's start with HCl, hydrogen chloride. HCl. What is the atomicity? Arnab is saying 2. Sanidhya is saying 3. Why is it 3, Sanidhya? Adrito, Srijoni, Ishan, all of you are saying 2. Why is it 3? Justify your answer. Why is it 2? Why is it 3? Okay. No, Sanidhya, I'm talking about the first one. A, only this. What is the atomicity of this compound? Yes, 2. Right. So H1, Cl1. So 1 plus 1 is 2. Very good. What about H2O? What about H2O? 3. Right? Why 3? Hydrogen, 2 hydrogens and 1 oxygen. 3. What about carbon dioxide? Carbon dioxide is also 3, right? So 2 oxygen and 1 carbon dioxide. So total is 3. So that is the atomicity of all of these. So is atomicity clear to everyone? Good. Okay, very good. Right. So in the next class, we will be talking about compounds as well. So these are molecules of the elements that we have: hydrogen, oxygen, molecules of chlorine. So these are the molecules of the elements, and these are molecules of the compounds. So what is the basic difference between an element and a compound? An element can exist naturally in the universe. Okay. So this is one, it is made with only one type of atom. Right. So like here you see hydrogen, you see oxygen. So these are made with only one type of atoms. Whereas in case of compounds, you have a mixture, more than one type of atom. Absolutely right, Sandhya. Absolutely correct. So compounds that have more than one type of atom. Okay. So that gives us a molecule of a compound. So these are molecules, and what exactly is a molecule? Molecules are when you have atoms which are linked together by a chemical bond. Yes, yes, absolutely, Srijul. Molecules are made of atoms. So what is the basic difference between an atom, a molecule, and a compound and an element? Who can tell me the difference? Differences between an atom and a molecule. First, let's start with the difference between an atom and a molecule. What is the basic difference between an atom and molecule? Molecules are made of atoms, right? And how are they made? What is the specific thing that is happening between what? How are these atoms interacting together? Bonds. Correct. So when the atoms interact together with the help of a chemical bond, they form a molecule. Okay. So atoms, they are interacting with each other. Yes, absolutely correct, Srijoni. When atoms bond, very short, very crisply written, but absolutely spot on. When atoms bond, they form molecules. So chemical bonding is the basic thing that is happening between and atoms. And what are these chemical bonds that we learned about in today's class? What are the two chemical bonds that we learned about? Ionic and covalent. Yes, right, Isha. Very good. Atoms, they form molecules when they have a covalent, when they have a chemical bond between them. And what are the types of chemical bond? Yes, as Adrito Arnab was saying, it is ionic and covalent. Good, good. Right now we learned about ionic and covalent. Now we come to elements and compounds. What are elements? Who can answer what are elements? Just a brief idea from this picture only. One type of atom. Right, very good. So this, from this picture, what do you understand? That they have only one type of atom, same kind of atom. Very good, Arnav. Very good. Right, absolutely correct, Isha. So same kind of atom. They are similar atom, identical atom. Whereas in case of compounds, what are these? Compounds are they same type of atom, or do you have different sort of atoms? Different types of atoms, right? Right, very good. Ujjan, Arnab, Sambhav, good. Yes, absolutely right, Isha. Right, Srijan. All of you are correct. So they are not different matter. No, Srijani. Matter, they are not made of different matter. They are made up of different atoms. Okay. Clear? So is this, yes, two or more types of atoms. Right. Very good, Adil. Good. So, okay, good, Srijan. So this, for our recap today, what did we learn about? We learned about atoms. We learned about ions, cations and anions. We learned about bonding, covalent and ionic bonds. We learned how molecules are made, and we learned about the different types of molecules: monoatomic, diatomic, polyatomic. ঠিক আছে, diatomic এ কটা atom থাকে? How many atoms are present in a diatomic? Good, 2. How about in a polyatomic? How many atoms in a polyatomic? 3 or more. More than 2. Good, very good. Great. And we learned about atomicity. What is atomicity? What is atomicity? Number of atoms in a compound. Right, Arnav, Sambhav, good. Good. Number of atoms in a compound. Great. So any questions so far? Anyone has any question? Yes, Sujan. This is the elements, compounds and mixture chapter. Because from the next class we will be talking a lot about what are the properties of these elements, how these elements are formed, what do they do, their reactivity. And in order to understand a lot of these concepts, you have to be very clear about the bondings. You have to be very clear about cations, anions, and how they react. If you do not understand today's class, it will be very difficult for you to understand whatever is happening in the next few classes. Okay, so your school is also teaching this chapter? So is this chapter finished in your school? No? Good, good. So I think you all, if your school is teaching this, then you all know, right? You all have a lot of idea about this chapter. Right. So maybe from next class, since you all know, you all already have an idea. So should I give you a lot of questions? So do you want quiz or questions, or do you want me to separation? Okay. Okay, quiz. You people want a lot of quizzes. Okay. Okay, let's see. Okay, now let's start with our quiz. Okay, everyone ready? Okay. Okay, I hope everyone is ready. So let's start. Okay, so this is your 10 questions from this chapter. Very, very easy questions. Very easy questions. I was thinking that maybe this is the first class, you might not know a lot of things. So that is why I gave a very easy questions. But quickly, everyone do these very, very quickly and then we will discuss it. Why do I always give easy questions? Okay, so should I give harder questions? Okay. I thought doing easy questions is nice. I thought you people will be happy doing easy questions. Okay. Okay. From next class, I will be giving you a bit tougher questions. But okay. Yes. So since this is the first class, I thought let's give you all easy questions. Let's see. From next class onward, maybe I will give you some tough questions to solve. But what I want to know is that whether your concepts are clear, whether you people have understood the concept. These questions are just here to test whether you people have understood or not. Ishan is afraid of hard questions. Arnab is saying distill water clear. Anyone else? Okay, good. So see, Aishani, as long as your concepts are clear, my job is done. Just to teach you all about science, not to scare people into tough quiz. I'm not your school teacher. I just want you all to be excited about science. So the more you learn about these concepts, the better you'll understand. For example, you people were talking about quarks, right? Do you know that quarks are the basic foundation of string theory? So if you take up physics in your higher classes, you will learn that there is something called the string theory of how the universe was made. And quarks is the basic foundation of string theory. Teach you all about string theory. Are you all interested in knowing about string theory? Ishan is eager to learn. Okay, let's see. Let's see. Yes, they can show equations in Google, but equations won't tell you a lot of things. Right now, if I show you equations, you will not be able to understand. You have to start visualizing science, right? You have to see these in front of your eyes. You have to first understand. Equations are something which happens a lot later. You will not be able to learn about string theory from Google right now, Ishan. It is going to be very difficult. But let's see if I can give you a little introduction. So what is your favorite subject? All of you, physics, chemistry, maths, biology, what is it? Which class are you enjoying the most right now? Sambhav is saying astronomy. Ujan is saying chemistry, all science and maths, physics and chemistry, science, mathematics, history and geography. Very good, Aishan. Very good. This sort of balance we need. Ujan loves chemistry. Okay. Good. So are you all enjoying this chemistry class? And even the last two chapters, did you all understand everything? You all enjoy? Good. Yes. So basically, if you do not enjoy your classes, you will not be able to understand. Good. I'm glad you people are all enjoying. Ishan has, who else has finished? Wait, let me check your scores and then we will give the answers. Arnav has also finished. Good. Bolo. Yes, Sambhav. Sambhav got full marks. Should I check or should I uh, start discussing? You all said the questions were very easy, right? You all should have received full marks. Anyone left or should we start discussing? Quickly, 1 more minute and then I'm discussing the answers. Who is left? Aishani Arnav. Arnav has already given the test. 1 more minute. Done. Okay. So who will give me the answer to the first question? Question 1. What kind of bond is formed when atoms share electrons? Quickly. Covalent. Right? Yes. When they share electrons, they form covalent. Right. Question 2. When they give or take electrons, ionic. Very good. Yes. Sambhav, Aishani, Arnab, right? Yes. Question 3 is answer. Correct answer is molecule. Very good. The answer is B. Good. Question 4. What is it? What is it called when two atoms from different elements they join together? Compound. Very good. Very good. Question 5. What holds molecules and compounds together? Chemical bond. Right. Sambhav, Arnav. Good. Good answers. Question 6. What particles are used to form bonds? Electrons. Right. Good. What is the atom when it gains an electron? When it gains an electron, what is it called? Anion. Very good, Ujan. Right. NaCl. What does NaCl form? An ionic bond or a covalent bond? Question 8. Ionic bond. Right. What is the atomicity of CaCO3? Correct. Absolutely right. 5. What is the atomicity of NaOH? 3. Absolutely. See, you people have already understood everything. So these are the answers to your 10 questions. Anyone has any more doubts? Is it crystal clear now? Okay, good, Oishan. Good, good. Very good. Crystal plus diamond clear. Very good. Right. So that's it. Now, Rajiv sir is also here. So bye bye, everyone. Yes. Over to you, sir. Yes. Thank you, everyone. Bye bye.
Good afternoon, everyone. All right. So can you all turn on your videos once, all of you? So who all can I see? I can see Sambhav, Arnab, Oishani, Ishan, Srijani, Ar, Ujjan, Adrita, Sanidhya. Okay. So you all are okay. So you all are what, school is going on normally, all of you? You all can speak out, don't worry. Are you all able to unmute yourself? 1 second. Now you all can unmute. So how is school going on?
Fine, sir.
Fine. Are you
Yeah,
all,
our exam is going on.
who is that? Adrita?
Sir, no, Adrito.
শুনতে পাচ্ছি না, বুঝতে পারছি না।
Sir, my name is Adrito.
ও আদ্রিত, আচ্ছা 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 Ad- okay, so I called you as a okay Adrito. See, it's very confusing because Adrita is also a name and Adrito is the same.
Yes, sir.
uh, so that is why you should turn on your video so that I can see you, and then I can understand whether you are a boy or a girl like that. Otherwise, uh, okay. What about Ishani? How is school going?
So like normal online.
Normal online.
Hmm.
So are you enjoying the classes in school?
Yes, sir.
Yes,
It's
sir.
a lie. It's a lie.
Sorry?
Fine is a lie. We are enjoying it. It's a lie.
It's a lie. Oh, it's
Who
okay.
who feels good to just sit idly in front of a digital thing and just listen to it?
Mm,
It's too much boring.
mm. So when you have classes in school, then do you have the chance to speak to your teacher, or are you allowed to unmute?
Sir,
Yes,
sometimes.
sir. Yes, sir. But some teachers don't actually. There are some teachers in their classes, students go like, what violent? They start yelling and shouting so much that some teachers don't allow us to unmute.
Mm. And you have 40 students in each class, right?
More than that, we have
We
60.
have classes with two sections combined,
Oh,
but the total number of the two sections is only 40 attending.
attending the class.
And in our class, there are 60 students, 61 actually.
Okay. And how many hours of classes do you all have every day?
From how much will it be? From yeah, 11:30 to 1:30, and then again 2:30 to 2:30 to 3:50.
8:30
Oh,
to 12
3:40.
p.m.
It has
8:30
changed.
to 12 p.m.
Oh,
This is every day. Every day you all have.
yes,
Yes.
except Saturday. We don't have in Saturdays.
Okay. And how are the exams conducted?
Online means PDF format. Some are questions will be given
Online.
in groups, and then we have to write it and make a PDF and send it to
Google
Gmail.
Form. We have Google Form exams, not a live exams, Google Form.
Okay. বুঝতে পারছি। ঠিক है। When do you think your schools might start?
Maybe 1 year later,
No idea.
after everyone gets vaccinated, maybe after that.
So maybe next year.
Okay.
Actually, it is told that this after 1 month or 2 month vaccination will be starting from 12 to 18. From September or November it is told. So I think that after the students and teachers mainly are vaccinated, maybe the school can open.
Long road ahead in terms of normalizing the normal, school, the way in which you all have been used to attending school. So let's hope for the best. I mean, obviously, there is a different flavor of attending and teaching in classes live in the classroom, and it is quite different as compared to teaching in the online environment. Both have their pros and cons. I think the biggest advantage of for us, especially doing the online classes, is that we can teach students from anywhere across the country. So that is one of the best things about it, because previously when we would teach in classes, in physical classes, then we would be restricted to only one geography or location. But now we have students attending from all over the country. So that is a good thing. Of course, to how to make the classes more and more interesting, interactive, uh, and easier to give punishment in normal classroom. So I really never have believed in the idea of punishments and all of that, because I think I think if students are not doing the main thing they are supposed to do in the classroom, which is, interact with the teacher, then there is something, then the problem is with the teacher, not with the student. So that is what I feel. So I think the teacher must be punished and scolded and not the student. So that is how I believe. So uh, anyway, oh, so done classes by traveling in a train. No, I haven't done classes by traveling in a train. um, but yeah, I mean, of course I would ideally want, and in the next few months we are also planning on bringing some hands-on learning activities for you all, so that you can also do some experiments at your home, and everything is not limited to the digital world. Okay, so and also we will be sending your study material in the coming week. In this week you will get your study material. So you have to just go to your we will give you all one location. So all those who are in St. Xavier's, Panihati, you can we will be, giving the study material near the school at a given time and place, so you can come and collect it. And for students who are in other schools, we will essentially be going to the school and giving you the material there. So you we can start off with that. And let's see in the coming days how we can make online more and more interactive, interesting, and more activity driven, because I like doing a lot of experiments. So it's only when you do experiments can you truly understand the science part of it. So we will do that. We will do that. Today, the CBSE batch has its had its first Kurukshetra exam, and I think you all will have your Kurukshetra exam. Today is which week? Sixth week, right? For all of you, today is the sixth week. We had two classes of yes, we had two classes of physical quantities, and then this is our fourth lecture of Newton's. I mean, this force and pressure. So today is the sixth week. After 3 more weeks, you will have your Kurukshetra exam, and then we will bring a lot of changes to the more innovations to the structure. Okay. So today is our last interaction on force and pressure, and you are going to be exposed to something which is which is related to vectors, called resolution of vectors. Okay, and then we will do some problems of forces like what we had done in the last class, right? We had done some blocks and arrows and all of that, right? So we will teach, I will teach you that. And before that, I will also teach you basic trigonometry. Okay, so which is very simple. I don't think you all have been taught trigo till now, right? You all don't know trigonometry, right? So I will give you an idea of trigonometry. It is very simple. So today we have a lot of new things to cover. So let me get started now. Okay, and for this session, this will be our last interaction on force and pressure. So so let's like try to make the most of it. Okay, so I hope my screen is visible. Yeah, I mean, Ishan, I will not teach you trigonometry. I will teach you enough trigonometry so that you can easily understand the resolution of vectors part, which is essentially breaking of vectors along x and y axis. So let me start off. So what did we discuss in the last class? In the last class, we discussed about application of pressure. You remember all the questions that we had taken, aeroplane and scuba diving and all those things. Then we talked about frame of reference, that there is nothing called absolute rest or motion. Everything is dependent on the frame of reference from where you are looking at. And frame of references are of two types: inertial and non-inertial, right? Inertial are those which are at rest or are moving with constant velocity, and non-inertial are those which are moving with some acceleration. And then we did this interesting thing, the elevator problem. And through that, what happened was we applied the concept of pseudo force or false force, and we made Newton happy. We could apply Newton's laws um, from every frame of reference. And then after that, we had done some block arrows, right? Block diagrams and arrows. arrows basically represented the vectors, right? You all can recollect all of these points that we did in the last class. Great. So frame of reference was this, depends on where you are looking at things from. And I'm absolutely sure that all of you are able to relate to what I'm showing here. Is there any doubt with respect to this? This is absolutely clear. You can explain it to your small brother, sister, or friend, or whosoever, cousin or somebody, this concept of pseudo force, why we apply this false force when you are looking at things from a non-inertial frame of reference, just so that you can get the same equation perfect from an inertial frame of reference. Great. So fine. So now that this is clear to you, and that Newton is happy with the whole application of pseudo force. So we did these problems, right, where we saw this. We saw that the length of the arrow was equal to the magnitude of the vector, and the arrow head represented the direction, right? So what we did was we had done various problems like this, right? We had changed the arrow, and I was asking you in which direction will the block move, depending on the length of the arrow and the direction of the arrow, right? We had done some of these problems in the last class. And you remember these problems, right? We had talked about some of these problems. No, Ishan, I got it from the internet. I was searching and I got it from the internet. So I did not make that photo. So so what about this block? In which direction will it move? If all the arrows are of the same, yes, it will move up, north, absolutely. Perfect. Then what about this? In which direction will this block move? This block, in which direction will it move? Northeast. Okay. So the English you will write as rightish, or along the northeast, or somewhere between X and Y axis, like this, right? Yes. Ishan is saying east north. Actually, north dike beshi, more towards north and less towards east, because the value of the arrows or the vectors is more along the north direction as compared to the east direction. So it will be northish. Yes. Right? Northish east. Right? Very, very weird to say this like this. And similarly, in the next case, what we had also seen was we had made the length of this arrow, the arrow towards the east, much greater than the sum of the lengths of the arrows. Yeah. So this would be east north, eastish, right? Now this is not how science is supposed to be. This is where I had left you all in the last class. This is not how science is supposed to be. Science is not abstract. Science is not abstract. Science is exact. So what we do when we take any vector, this is called the x-axis and this is called the y-axis. The green arrow is called the y-axis. The blue arrow is called the x-axis. It's like the east and the north. Okay. And what you do is, if there is any arrow or vector given to you, so suppose this is the vector, what you simply do is you take this vector A and you take it and put its tail at the origin. What did I say? You take this vector, you don't change anything about it. You simply translate this vector and put its tail. This is the tail, this is the head. You put its tail at the origin. And this vector has not changed because the direction of the vector is the same and the magnitude of the vector is also the same. So this red arrow and this red arrow represent the same vector A. Is this clear to all of you? What have I done? I've just picked up the vector from wherever it is and put its tail at the origin. Is this clear? Okay. What about the rest? Nothing. I have not done anything. All I have done is taken this vector A and I've put its tail at the origin. And then I'm saying that this vector red arrow is equal to the same as this red arrow here, whose tail is at the origin of the coordinate axis. This is called coordinate axis system, X and Y axis. This is called coordinate axis. So all I've done is taken this vector and picked it up and put its tail at the origin. So what I'm asking is this vector the same as this vector? The answer is yes, because the length of this arrow is the same as the length of this arrow. And the direction is also, they are both pointing in the same direction. Essentially, they are parallel. Therefore, the vector is the same. Now I will just tell you one thing and then I will get into trigonometry after that. Is what you do is, in this way, you can be given any vector anywhere. You simply pick up that vector and put its tail at the origin. And then you break this vector along the x-axis and along the y-axis. So the word resolution means, for a vector, means breaking up the vector along the x and y-axis. Note it down. The word resolution of a vector means you break that vector along the x-axis and along the y-axis. Something like this. If this angle that the vector A makes with the x-axis is theta, then this is its component, or the vector's component. This is the A vector's component along the x-axis. This is called A cos theta. And this is the vector's component along the y-axis. This is called A sin theta. Is this clear? This is a new concept. It will take you time to understand this. I would highly encourage you to unmute yourself and ask any question at this point in time. We will again come back to this. But is this somewhat clear? Because this is a concept of class 11 and 12, and I'm teaching this to you right now. You can unmute and ask any question at this point in time. Are the rectangle sides? Yes. So this is the x-axis. This is basically equal to this. This blue arrow is equal to this red arrow. Similarly, this blue arrow is equal to this. Now, why I have drawn these two light blue arrows is because this is a right angle triangle. If you look at this triangle, this is a right angle triangle. If I drop a perpendicular from this to this is a right angle triangle at this point. Aschi, sine ko se aschi. Is this so far understood? Is this, Acha, can you tell me something? Is the length of this arrow less than or equal to or greater than this arrow? Acha, Sambhav is saying the length of this arrow is equal to the length of this arrow. Na, ऐसे go for infinity cano. So rays, they are not rays. These are arrows. These are vectors with a specific magnitude. Not everything is a ray. Acha, tell me something. Is the length of this arrow equal to the length of this arrow? If you look carefully, Acha, do you know this? That in a triangle, in a right angle triangle, the length of the hypotenuse is greater than the length of the individual sides? Do you know that in this right angle triangle, the length of the hypotenuse is greater than this side as well as greater than this side individually. So then now tell me, in this right angle triangle, is the length of the base greater than the length of the hypotenuse? Bolo, use chat. You can use the audio. Why are you not speaking? You can speak. Pythagoras theorem. I will also teach you that. I will teach that to you today. Yeah. हाँ ठीक আছে, two rays form an angle. These are not rays, because rays you will extend to infinity. The length, this is a vector. A vector's length is equals its magnitude. No, so when you are saying it is a ray, it means the length of every vector is infinity. That doesn't make any sense. বুঝতে পারছো? This is not a light ray. This is a vector. A vector's length of the arrow indicates its magnitude. Yes, like force arrows, correct. Not every force ka magnitude is infinity, right? If these arrows were to be represented like a ray tending towards infinity, then every force's magnitude will be infinite newtons. Cool. Okay. Now before, I am not going deeper into this now. First, let me teach you some trigonometry and some Pythagoras theorem, and then we will come back to this diagram again. Okay, have you all just understood what I said right now, even if you don't know what is cos theta and sin theta? যা কিছু এখানে কিছু কিছু বললাম, did you understand some of that? Okay, now this is a table that you are most likely required to remember in trigonometry. So there are six such names or identities, as we call it, trigonometric identities or ratios. And these six trigonometric ratios are basically, these are the six trigonometric ratios: sin theta, where theta is an angle; cos theta, tan theta; cot theta is 1 by tan theta; sec theta is 1 by cos theta; and cosec theta is 1 by sin theta. That means cot is the reciprocal of tan, sec is the reciprocal of cos, and cosec is the reciprocal of sin. Act minute. पहले तुम भी ट्रिगो पढ़ लो, sin theta, cos theta, tan theta. ठीक है, पढ़ लिया? Okay. Can you guys, have you guys made a note of this? Okay, okay. Quickly make a note of this. This is a table which I will soon show you the logic behind some of these values. So don't worry, it's not at all complicated. Things look complicated at the beginning, but they are not. Things are very simple. That is the job of science, to simplify and give you the logic. These are just 6 names. All you have to remember is that there is some ratio called sine, some ratio called cos, tan, cot, sec, and cosec. And these are some values of angles, standard angles, 0 degrees, 30 degrees, 45, 60, and 90. Noted? Now these ratios and these angles are applicable for what kind of triangle? Can you write it in the chat, or can you use your audio to tell me for which kind of triangle is this applicable? No, not acute. Yes. Adrito is right. It's right angled. All of you are correct now. Right angle triangle. That means one of the angles is 90 degrees and the other angle is one of these angles. Understood? Okay. So now let me quickly take you, as somebody was mentioning, 2 line segments or 2 rays with a common point form an angle. So you have one ray like this, you have another ray like this, and this is called an angle between them. This is known to all of you. You have studied this in class 5, 6 or something like that. Right? Chat use karo, tumra bolo kichu, awaj karo. Are you all able to unmute yourself? Are you all able to unmute yourself? Okay, so this is the value of an angle. And I hope all of you are aware of these, the 6 types of angles. The 6 types of angles. So you have an acute angle. You have a right angle triangle. Acute angle is less than 90 degrees. Right angle triangle is 90 degrees. Obtuse angle is between 90 degrees and 180 degrees. A straight angle is equal to 180 degrees. A reflex angle is between 180 and 360 degrees. And a full angle is equal to 360 degrees. ঠিক আছে? And zero angle ঠিক আছে. Zero angle is 0. That means it's not an angle. Both the line segments are on top of each other. ठीक है? Clear? This is known to all of you. Now there is one more thing that I want you to remember. It is a poem, and the poem says, some people have curly brown hair turning permanently black, or some people have curly brown hair. আচ্ছা ওটাতে আসছি আমি, ঠিক আছে? আগে the angle between the difference between 0 is that, wait, I'll show you, is that when 2 arrows are there, 2 line segments are there, and these 2 line segments are just lying on top of one another. That means there is no angle between them. This is called 0. Okay? Now if I take this and I rotate it by one full 360 degrees, and this all still comes over here, this looks like the initial configuration. But this time these 2 arrows have arrived at this position by doing one full circle. So that is called 360 degrees. That is called full angle. Okay? But when you started, then they were at 0. But when you rotated it by one full circle, then that is called full circle. Okay? Even though they might be on top of each other, it's the same. I mean, that's the difference basically. So this gentleman here is Pythagoras, and he's famous for this very famous equation in a right angle triangle, which he saw the pyramids and the length of the shadow, and from there he was able to figure it out. Does this mean that 0 and 360 degrees in one point mean the same straight line? Both the straight lines are on top of one another. There is no angle between them. Yeah. So this is the Pythagoras theorem. Length of the hypotenuse, the square of that is equal to square of the base plus square of the height. So height square plus base square equal to hypotenuse square, or a square equal to b square plus c square. And now let me quickly help you with a very basic derivation of this. I want you all to have a look at this diagram here, and then one of you is going to explain what is happening here. This is one of the proofs. I have got two proofs here to show to you. This is the first proof. This is more of a mathematical proof. Take 30 seconds to look at this diagram, and then one of you should explain this over voice, through voice. You all know that the area of a right angle triangle is half into base into height. And you all know that area of a square is length of the side into length of the side, which is side square. Who wants to explain? Very simple. Who wants to explain this? Okay, so who wants to explain this? Quickly, very simple. None of you are responding. Is my voice audible? Am I visible? Is the screen visible? Okay, take your time.
Sir,
Follow.
sir, I think the red portion are parts for if you join the red portions together, it will form the blue portion or C square portion. I am not sure. I just thought that.
No, not quite. So what is happening here is that if you look at this big square, if you look at this big square A, B, C, D, then what is the area of this big square? ABCD. What is the length of each side of this big square? A plus B. So what is the area of this big square? A plus B whole square. Correct. And if you now look at this big square, it is composed of 4 right angle triangles, which is AFE, FDG, GCH, and HBE. Plus, it is composed of this square, which is EFGH. So what is the area of each right angle triangle? Half into base into height, which is half into AB. So how many such right angle triangles are there? There are 4 right angle triangles. Each of whose area is half into AB. Therefore, what is the area of these 4 right angle triangles? 2AB. And what is the area of this square? Area of this square is C square if the length of this hypotenuse is C. In these right angle triangles, A is the length of one side, B is the length of the other side, and C is the length of the third side. So what is the area of this square? C square. So can I write area of ABCD is equal to area of EFGH plus the 4 right angle triangles, which is A plus B whole square equal to C square plus 2AB. All I am now doing is expanding A plus B whole square. 2AB, 2AB cancel. So what do I get? A square plus B square equal to C square. That means in a right angle triangle, length of the base plus length of the height is equal to length, square of the length of the base plus square of the length of the height is equal to square of the length of the hypotenuse. Is this clear? Simple area. Khali area calculation korlam. Ekta bodo square I have got inside a big square, I have got 4 right angle triangles and 1 smaller square. Question mark kya hota hai? Ask the question na on audio. Why are you putting a question mark on the chat? Is this clear to everyone? You can use the chat. I mean the audio. क्या confusing है बोलो तो. Tell me what is confusing. You are just doing a proof of Pythagoras theorem that in a right angle triangle, the square of the length of the hypotenuse is equal to the sum of the square of the other two sides. हाँ, EFGH is equal to C square. ठीक ही तो अच्छा है. It shows all the hypotenuse. माने? है तो if I have a right angle triangle whose two sides are A and B, then the third side will be C. For similarly for the other triangles also it will be if length of two sides is A and B, then the length of the third side will be equal to C. If one angle is 90 degrees. তাই তো তাহলে তো ঠিকই আছে. Half into AB is the area of each right angle triangle. Half into AB, half into base into height. So ask on the chat, ask on the over voice. It is not very complicated. It is good you are having confusions and doubts. A square plus A square क्यों? A square plus B square ना? ठीक है. अच्छा, tell me if you can understand this or not. Tell me if you all can understand this or not. This one, the second diagram. Look at the left hand side diagram, look at the right hand side diagram. Tell me if you understand this or not. What I am doing is I am calculating the area of the white space. I'm calculating the area of the white space in both the diagrams, left hand side and the right hand side. And I'm showing that the area of the white space on the left hand side is equal to area of the white space on the right hand side. This is just reorganization of the blocks in the diagram. This is a different approach of proving. Why is that A square? Which one? This one? Because it's a square of length A and this is a square of length B. Is this clear? Is this clear? Or right now, do you just want to remember? I tried to give you two ways of or two derivations of Pythagoras theorem. What is C square and A square and B square? These are the area of these squares. C square is the area of the square, white square whose length of side is C. B square is the area of the square of this square whose length of the side is B. And A square is the area of this white square whose length of the side is A. What is the area of a square? Area of a square is side into side, right? Yes. Figure 1 is showing the area of C length square and figure 2 is showing the area of square of A and B. Essentially, yes, but what if you look at the color, the white color on the left hand side is equal to the area of the white color on the right hand side. I have just reorganized the square, these triangles around it. I have not done anything. The area of the white square is equal to the area of the white square here. This is one big square, this is two smaller squares. And from here I am showing you Pythagoras theorem. That in a right angle triangle, A square plus B square equal to C square. Is this clear? Is derivation of Pythagoras theorem clear to all of you? If not, then I would urge you all to, yeah, some of you have understood. I can see that. And yes. And some of you are having some confusion. I would say that you go and, go through the derivations and then come back with some more doubts. But it is okay if it is not fully clear. But means C square means the big square which is formed due to addition of the two smaller squares. Yes. As all the triangles are equal. Yes, because you're not changing the triangles. Yes. A and B will have 90 degrees. Yes. And C is the hypotenuse because it is opposite to the 90 degrees. Yes. Yes, now you all are getting the hang of it. Yes, Ishan, you're correct. Cool. Good, good, good. I'm happy. Now, let's come to this right angle triangle. ঠিক আছে, ঠিক আছে। প্রথমবার কোনো জিনিস দেখলে it might be a little confusing, but now you have understood this, which is good. Now I want you all to look at this. Some people have curly brown hair tightly pulled back or turning permanently black, whichever you want to use. As I said, sine, cos, and tan, these are ratios. These are ratios of the length of the sides of a right angle triangle. Dhyan se suno. What are sine, cos, tan? Sine, cos, tan are ratios. You know what is a ratio? Two ratio is a number, is a fraction which is two numbers, right? A is to B, correct? So sine, tan, cos are ratios of the length of the sides of a right angle triangle. So what is sine? Sine is perpendicular by hypotenuse. Some people have. So if you all can look at this right angle triangle, then the side opposite to the right angle triangle is called the hypotenuse. The side which is at the bottom is called the base, and the side perpendicular to that is called perpendicular. Okay, because it is the one which is standing upright. So sine theta or sine q, if this angle is q, I forgot to mark this as q. If this angle is q or theta, then sine theta will be equal to perpendicular by hypotenuse. Okay. I think spelling mistake होएगा. It's hypotenuse, okay? Hypotenuse. हाँ. Spelling mistake हो गई. Okay. So what? So sine theta, some people have. So sine theta is equal to perpendicular by hypotenuse. Okay. Similarly, curly brown hair, cos theta is equal to base by hypotenuse. And finally, tan theta is tightly pulled back or turning permanently black. Tan theta is perpendicular by base. Hypotenuse is the length of the largest side in a right angle triangle which is opposite to the right angle. Is this clear? Yes, these are the ratios. So sine is the ratio of perpendicular by hypotenuse, cos is the ratio of base by hypotenuse, and tan is the ratio of perpendicular by base. If you have understood this, then if you understood a lot of trigonometry today. Now let me give you, now let us try to derive some of the values. Let us try to derive some of the values. Now you will apply, you know what is Pythagoras theorem? You know what is Pythagoras theorem? So in this right angle triangle, what will be Pythagoras theorem? C square, taito? C square equal to A square plus B square in this right angle triangle. You can also write C is equal to root over of A square plus B square, which is fine. ठीक है? Clear, students? So now look at this diagram. Now look at this diagram very carefully. Now we are deriving the trigonometric ratios. I showed you that table at the beginning. Now we are deriving the trigonometric ratios. Listen to me carefully and you will very quickly get the hang of it. If the length of the base of a right angle triangle is 1, which is this red arrow or red line, if the length of the perpendicular is 1, then what will be the length of the hypotenuse? Length of the hypotenuse will be root over of 1 square plus 1 square, because C square is equal to A square plus B square. What is A square? 1 square. What is B square? 1 square. So what will be 1 square plus 1 square? 2. So what will be the length of this side, the hypotenuse? Root 2. Is this understood? Is this understood, everyone, in this right angle triangle? Come on, come on. Tell me. मैम बना दिया सानिध्य ने. ठीक है. ठीक है. Okay. So now if you look at this right angle triangle and you apply some people have, so what will sine theta be? Sine theta will be equal to perpendicular by hypotenuse. What is the length of the perpendicular? 1. What is the length of the hypotenuse? Root 2. So what will be sine 45 degrees? If this, acha, by the way, tell me something. Why is this angle 45 degrees? Why is this angle 45 degrees? Because this is a right angled isosceles triangle. Because length of these two sides is the same. If this angle is 90 degrees, then what will this angle be? 45. What will this angle be? 45. समझ में आ रहा है अब? Half of 90, half of 90. So can I say sine 45 degrees is equal to 1 by root 2? Because length of the perpendicular is 1 and length of the hypotenuse is root 2. Similarly, what is cos 45? 1 by root 2, base is 1 and hypotenuse is 1. And what is tan 45? Perpendicular by base, which is 1 by 1, which is 1. If you now match the value of sine theta equal to 45 degrees or sine 45, cos 45 and tan 45 in the table that you had just written down some time back, can you see that these values match? 1 by root 2, 1 by root 2 and 1. Everyone, I want an understanding of this from everyone. Srijani, Arnav, Ishan. Can you speak over the audio, Sambhav? The chat is like couldn't read.
Sir, I am saying you have written root of 2 there. The hypotenuse is 90 degrees and theta is 45 degrees. So the other side is also 45 degrees. Is this because it is the root of 2 and 90 is meant to be 2 here?
No. Values of the length of the sides are not equal to the angles. This angle is 90 degrees. So
Yes.
if this is an isosceles triangle, then this angle will be 45, this angle will be 45.
Yes, sir, because root of 90 is 45 degrees.
Root of 90 is 45 के बोल लो. Root of 90 के बोल लो 45.
Oh, sorry. I mean the half of 90. Sorry. I don't understand. Half.
ठीक है. Okay. Is this clear to everyone? सानिध्य ऑडियो में बोलो सुनाई मतलब चैट नहीं पढ़ पा रहे. Oishani is not responding at all. Why? Oishani normally responds. বাকি সবাই তো রেসপন্ড করেছে. উজ্জান, সম্ভব, সানিধ্য, অর্ণব, ঈশান, আদৃত্য and Srijani. Srijani is also not responding. Okay, okay. अरे chat में can you speak on the audio सानिध्य भाई? Audio te bolo. Your question is not clear. Tell me if anyone has any doubt in this part. Use the audio. Use the audio to explain your question. Okay, okay. Okay, okay. Now, tell me something. If I were to make this angle 0, then what would happen? If I were to make this angle 0, what would happen? This side will coincide with this side, right? And this angle would become 0. That means what would happen to the length of the perpendicular? The length of the perpendicular would become 0. Do you all agree? A length, what has happened to the length of the perpendicular? It has become 0, and the length of the hypotenuse has become equal to the length of the base. This was my right angle triangle. This was my right angle triangle. This is my right angle triangle. Okay? Can you all see this? This was my right angle triangle. If I have to make this angle 0, then what would happen? This side will come and rotate and coincide with this side. So the length of the hypotenuse, which is this side, the length will become equal to the length of the base. And what will happen to the length of the perpendicular? It will become 0. So now, since the length of the perpendicular has become 0, so what will be sine theta or sine 0? Perpendicular by hypotenuse, which is 0 by 1, which is 0. What will be the length of, what will be cos theta? Base by hypotenuse. The length of the base and the hypotenuse are both 1. So what will be cos 90? Cos 0. Cos 0 will be 1. Sine 0 will be 0. And what will be tan theta? Tan 0 will be perpendicular by base. Perpendicular is 0 and base is 1. So what will be the value of tan 0? 0. Can you now match this with the table? Sine 0, cos 0 and tan 0. What are their values? 0, 1 and 0. Is this clear? I will show you what is trigonometry used for. It is essentially used for a lot of mathematical calculations. Without trigonometry, you could not do a lot of calculations. Now let's come to the last. What will happen when theta is equal to 90 degrees? This is my right angle triangle. This is my right angle triangle, suppose. This is my right angle triangle. When theta will be equal to 90 degrees, then what will happen? The hypotenuse will come closer to the perpendicular. Correct? What will happen? The base will get removed. This is the angle increasing. Angle is increasing. Now that hypotenuse has now coincided with the perpendicular, and what will happen to the base? The base will become 0. this is my right angle triangle. Okay. If this is my angle, this is my right angle triangle. If this angle has to become 90 degrees, what will happen? It will keep coming closer. The hypotenuse will keep coming closer to the perpendicular and it will merge with it. Then this angle is 90 degrees. So what has happened to the base? The base has become 0. It has become 180 degrees. You are calculating the angle with respect to what? If this is your angle, acute angle, then what is this angle? This angle is 90 degrees, right? So this is your hypotenuse. The hypotenuse is becoming like this. Then it is 90 degrees, right? Why would this be 180 degrees? 180 degrees would be this. This angle. Yeah, na? This is theta. Theta equal to 60, theta equal to 90. This is your hypotenuse. And this is the base. So can you all now understand that this time the base has become 0 at theta equal to 90 degrees? Yes, yes, absolutely. So what will happen now? Sine theta is, some people have this time perpendicular and hypotenuse are the same. So 1 by 1. So at sine 90 is 1 by 1, which is 1. Cos 90, the base is 0. Base curly brown hair. Base 0 and hypotenuse 1. So cos 90 is 0. And tan 90 will be perpendicular by base. Perpendicular is 1, but the base is 0. So what will this be? Undefined. Now if you tally this with the table, then you will find that this is what we have just derived right now for 0 degrees, 45 degrees and 90 degrees. কিছু বোঝা গেছে? Okay. ठीक है, I think I obviously have some complex things to teach you, but I think I will not do that in class 7 because तुम लोग के लिए थोड़ा सा overwhelming हो जा रहा है. एक तो overwhelming हो जाता है. I can see that. How many of you want to understand this resolution of vector part? And then I will decide according to that. Okay. Ishan wants to do it. Adritu also. Okay. Sanidhya doesn't. Who else? Ujjan is asking what is the name of the chapter? This is force and pressure. And we are learning how to, after you would have learned, because force is a vector quantity. So once we would have understood the resolution of vector, which is very simple. It is basically in a right angle triangle. This is your right angle triangle where A is the vector, which is the hypotenuse. Then what will be the length of the base? Simply cos theta is equal to base by hypotenuse. So the base will be equal to what? Hypotenuse into cos theta. So a cos theta, this is the hypotenuse. And what will be the length of this? The perpendicular. The length of the perpendicular will be a sine theta, which is just now what you saw. So essentially any vector can be broken into two components or into two parts. One along the x-axis. No, Sanidhya, one thing, let me make it very clear. Just because you are finding it difficult, it does not mean that others are finding it difficult. So don't use the word we have thought. You should say that I thought that it would be very easy, but it is very difficult to understand. Because I know there are students in the class who are able to understand this. And thoda sa apply karoge, if you apply yourself a little bit, then you will also be able to understand it. So essentially what would have then happened is that you can represent any vector along the x-axis or along the east-west direction as I, and any vector along the north-south direction as j. This is your normal convention. So let me just quickly, because Shautadipa ma'am is here. So if you wanted to represent this diagram, it's very simple. It might seem complicated, but it's actually very, very simple. If you wanted to represent this diagram, then what is happening is, if you see this, then the net force along the x-axis, if you look at the vector along the x-axis, then what is the net force along the x-axis? 20 minus 10. So you will write this, yeah. And what is the net force along the y-axis? Net force along the y-axis is 20. So what will you represent this as? You will represent the net final resultant vector on this block as 10i plus 20j. 10i represents 10 along the x-axis and 20 represents 20 along the y-axis. Now for Sambhav, as you're saying, more north than east. So now if you wanted to calculate the tan theta, then this is a right angle triangle whose perpendicular or the y-axis is 20 and whose base or the x-axis is 10. So what will be the value of tan theta? Tan theta will be perpendicular by base. So tan theta will be 20 by 10. Is this clear? Or tan theta will be equal to 2. So you can now easily calculate the theta of this vector. In which direction, what exactly is the angle it makes with the east or the x-axis, you can find out. Let me give you one more example and then it will become clear. How will you represent the final vector along the x and y axis for this question? Write it in the chat. So how will you represent it as 20i plus 20j? Will you represent this as 20i plus 20j? 20 along the x-axis, which is I, and 20 along the y-axis, which is j. Is this okay? So what angle? So the resultant will be along the northeast. And what exactly will be the angle of this green arrow or the green line is the resultant. The resultant means the final vector, which is the sum of these two vectors. So what will be tan theta in this diagram? Tan theta will be what? This angle, tan theta, will be perpendicular by base. What is perpendicular? Y-axis is 20. What is base? X-axis is 20. So what will be tan theta? Tan theta will be equal to 20 by 20, which is 1. So what is theta? 45 degrees. When is tan theta equal to 1? When theta equal to 45 degrees. अब समझ में आ रहा है? Tan theta finds the angle. Tan theta finds the angle which this resultant vector makes with. So you no longer have to say rightish or eastish. You have to say, you will simply say that the resultant vector, which is a combination of x and y axis, makes an angle of 45 degrees with the x axis, because this is my resultant vector. Now is it clear? Clearer? Okay, Sanidhya, message to everyone. So Sanidhya is clear, Adrito is clear, Ornab is clear, Ishan is clear, Sambhav is having some issues. Let us do some questions and it will become 100% clear to you, I can guarantee that. So now this is the class quiz part of it. So you can write your answers on a piece of paper and then you can open the app and submit your answers on the app. Okay. So I am now showing you some very simple questions. You try to solve it. Very easy questions. Only the last couple of questions are a little complicated. Shotadipa ma'am, is it okay if I take some more time?
Yes, sir, no problem.
Okay. Because this is slightly conceptual and a little high standard for them. If I don't complete this, they will not understand.
Sir, no problem.
Okay. Thank you. So, so let us do some of these questions. This is the first question, students. Give me your answer. I is x-axis and j is y-axis. So the solution is very simple. Because these two forces will cancel each other out. 10, this is 10i and this is minus 10i. So these two will cancel each other. Sambhav 20j hobe. Yes, this is class quiz. And this was 10j and this is 10j. So positive y-axis is plus j, negative y-axis is minus j. Positive x-axis is plus I. Sambhav, obviously the x-axis is I. X-axis is going up now. X-axis is east-west. And y-axis is north-south. So here the net resultant was what? The green arrow and the yellow arrow both combine along the j-axis, along the y-axis. So it will be 10 plus 10, 20j. 20j is the answer. Okay? Cool, everyone? Clear, Eta? How will you represent the resultant vector on this block? Now, what will be the angle? What will be the angle that this block makes with the x-axis? What will be the angle that the resultant force on the block makes with the x-axis? Option. This is the option. Okay. Now, this is the second question. What will be the angle that the resultant force on the block makes with the x-axis? So what was your what was your resultant force? Your resultant force was 20J. 20J. Yes, Ujjan, you are correct. You are not correct, Ujjan. Ektu bhabo aro. The net force is along which axis? No, no, no. Students, look carefully. The net force is along which axis? Y-axis. So what angle does the y-axis make with the x-axis? 90. Yes. Yes. So if you look at the resultant force, if you look at the answer, send comments to everyone in the chat, not just to me. When you look at the resultant force is 0I plus 20J, right? So there is no component along the x-axis. So when a right angle triangle's base becomes 0 and perpendicular has got a value of 20, this is J and this is I. So the resultant force, the value is 20 along J, along the y-axis, and 0 along the x-axis. So what will be tan theta? Tan theta will be 20 by 0, which is undefined. And when is tan theta undefined? When theta is 90 degrees. Or you could have simply said that the resultant force is along the y-axis, and y-axis makes an angle of 90 degrees with the x-axis. So Ujjan, when the hypotenuse has to become 90 degrees, that means this angle, when will this be 90 degrees? When will this angle be 90 degrees? When this green line will be upright, like this. When this green line will be upright, that means when will this green line be upright? When this point will coincide with this point. That means the length of the base will become 0. Did you follow? Okay. Next question. Correct. Absolutely correct. Ujjan, send messages to everyone. Again, this is very simple. What is the net force along the x-axis? 20 minus 10. What is the net force along the y-axis? 20 minus 10. So 10I plus 10J. And what will be the resultant force? What angle will it make with the x-axis? ठीक है करो आज के practice करो. Don't worry. If you understand some of this, then it will be a big achievement. Students of class 7 can do vectorial problems. Yes, very good, Sambhav. Excellent. Very good, Srijani. See, if I have to solve this question, then what will happen? The net force along the x-axis is what? 10, because 20 minus 10. These two vectors are in the opposite direction. 20 minus 10. So this is net is 10 in the along the x-axis. Similarly, along the y-axis, what will happen? It will be 10 along the y-axis. So you will simply write this as 10I plus 10J. Now, if you have to draw a right angle triangle, the length of the perpendicular is 10 and the length of the base is 10. Taito? The length of the perpendicular is 10 because the 10j. And what is the length of the base? 10i. So what will be tan theta? Tan theta will be 10 by 10, which is equal to 1. And when is tan theta equal to 1? Look at the table. Tan theta is 1 when theta equal to 45 degrees. अब कितने लोग को समझ में आ रहा है? ओके, सानिध्य, ईशान, उज्जान, Srijoni, Sambhav, Arnav. Now all of you can understand this. Good, good, good. আর কোথায়? Oishani is the only one who has not responded. Adrito, have you responded? Adrito? Adrit. Where are Oishani and Adrit? Acha, Oishani got disconnected. Acha, ठीक আছে. So now are you ready to move to the next question? We have 3 or 4 more minutes. Okay, next question. Easy question. Last 2 questions are a little tricky. We'll see. ঠিক আছে করো. This is question number 5, students. Sambhav, देखे करो. Yes, Ishan, correct. Very simple. And what will be the angle that the resultant force makes with the x-axis this time? Yes. না Sambhav, 90 কেন রে বাবা? x-axis এ আছে তো. X-axis makes what angle with x-axis? 0 degrees. তাই না? Yes, very good. So how will you solve this question? 20, yes, 20 minus 10 is 10 along the x-axis, and 10 and 10 along the y-axis cancel each other out. So the net force on this block is 10i along the x-axis. And since there is no force along the y-axis, what is the length of the perpendicular? 0. What is the length of the base? 10. So what will be tan theta? 0 by 10, which is 0. When is tan theta 0? When theta is 0. And you can always say that since the net force is along the x-axis makes an angle of 0 degrees with x-axis, because x-axis is x-axis. Is this clear now? Is this absolutely clear? Let's move on. This is a symmetrical question. Yeah, I can see your chat now. Yes, Ishan, very good. Yes, Ujjan, excellent. Question 6 ये है. ठीक है? And this is, yes, Oishani, you are right. Absolutely, C and 0. And the angle, what angle will this resultant make? The resultant is, there is 0 resultant, so actually it should be undefined, but ekhane answer you can write it as 0. তাই তো? Because there is no force. So how would you solve this question? Okay, I'm just showing you the typical method of solving such questions. এটা তো symmetrical case হয়ে গেল, angle is 45 degrees everywhere they make with the x axis. খালি এই মেথডটা একবার দেখে নাও সবাই, ঠিক আছে? If you understand this, then it will be great. What I do is I remove the block. I bring all the forces to the origin. Yes. I bring all the forces to the origin. You remember origin, the x and y axis intersect at this point. All these angles are theta equal to 45 degrees. So now what I do is, I now break these vectors along the x and y axis. Along the x and y axis, I break these vectors. So what will I do? I will break the orange vector along the x and y axis. So what will be its x component? 10 cos theta. What will be its y component? 10 cos theta. 10 cos theta and 10 sin theta. This one, I've not written theta here because theta is the same. Okay. Similarly, I will break the blue vector and I will write it along the x and y axis. So this will be 10 cos theta and this will be 10 sin theta. Similarly, I will break the green vector and I will break it along the x and y axis. So x, it will be 10 cos theta and y will be 10 sin theta. And finally, I will similarly do the yellow. I will break it along the x axis and the y axis, which is 10 cos theta and 10 sin theta. Now I will equate all the forces along the x axis and all the forces along the y axis. As you can see that the orange and the yellow are pointing in the same direction and blue and green are pointing in the opposite direction in the x axis. Similarly, the blue and the orange are pointing in the same direction of the y axis and the yellow and the green are pointing in the opposite direction. So this is plus j, this is minus j, this is plus I, this is minus I. So what is the net force acting along the x and y axis? 10 cos theta plus 10 sin, these two, this is the x axis. Similarly, this is the y axis. And since the value of theta is the same, all of these will cancel each other. So the net force is 0. And the angle is also 0, which is what you all said. But this is the way how we solve these questions. Now, if the angles were different, then you would simply put the value of theta 1, theta 2, theta 3, theta 4, and you can get the net component along the x and y axis. Is this clear? Ektu clear holo ei part ta? It is okay if you have understood. Yes, it is exciting because it is very fundamental. And why are we resolving the vectors? So if you were to ask me, why did we learn all of this today? Because vectors can be in any direction. Now, if you have to solve questions with vectors, you need to resolve them along two standard directions, which is the x-axis and the y-axis. Once you're able to break them along these standard directions, your job is done. And what helps you to break the vectors along the x and y axis is trigonometry, which is what we also learned today. Is this clear? আচ্ছা, ঠিক আছে। আমি লাস্ট কোয়েশ্চেনটা তোমাদেরকে আনসার বলে দিচ্ছি, তোমরা এটা পরে সলভ করে নিও বাড়িতে, কেন কি এখন আর টাইম নেই। সো why don't you all just note down these two questions and you can right now submit the answers. I can quickly because we are really running way beyond our time today. Just make a note of this question very quickly. My objective is been achieved, so that is why now I don't want you all to solve, because these are very lengthy questions. Solve करने में बहुत time लगेगा, तो इसको घर पे solve करना. Noted this question. You can simply take a screenshot if you want to. Okay. And the next question is simply what angle will the resultant force which will be in which direction. Okay. Okay. So the answer for the first question, for the ninth question is Again, you will break down the vectors along the x and y axis. You will calculate the total force along the x and y axis, and that will be 10 cos 60 minus 10 cos 30. And along the y axis will be 10 sin 60 plus 10 sin 30. And from there, you will be able to get the values as minus 3.66 I plus 13.66 J. Okay. So this is the answer for the 9th question, minus 3.66 I plus 13.66 J. And the 10th question was, in which direction will the resultant be? So the answer to the 9th question is A, and answer to the 10th question will be, since the vectors will be in the northwest direction. As you can see, the net resultant vector will be in the northwest direction. Okay, this direction. Because the green vector and the red vector, these are the resultant vectors. So the net vector will be in the northwest. Clear? I'm just rushing a bit. So this is what we have studied in the last 4 lectures of force and pressure. We have done the definition, types and examples of forces, right? We have done the definition, examples, pressure exerted by liquids, their different properties, pressure exerted by atmosphere, and all the other examples of, pressure. I will give you all the answers, wait. And then we also talked about Newton's laws of motion. What are the 3 laws? Where are they applicable? Where are they not applicable? Force of frame of reference, pseudo force, and we understood vectors because force is a vector. We understood trigonometry, and in the last 2 classes, including today's, we have done, yes, answer for 10 is B. We have done block problems. Okay. Great. So I can give you all quickly the answers to the, answers গুলো দিয়ে দিচ্ছি তোমাদেরকে. Wait. These are the answers for today's class quiz. Cool. If you have done it, then do submit it on the app. So one last time, did you all understand all the concepts that we have discussed in the last 4 classes of force and pressure? And you understood vectors today, and resolution of vectors, and trigonometry, and Pythagoras theorem. We learned a lot of new things today. Okay. So I will now hand it over to Shotadipa ma'am. Good. Okay, this was the best. আচ্ছা ঠিক আছে. Okay, so thank you. Since you liked this class, I thought this was a difficult class to understand. তুমি একটা মেল করে দাও সম্ভব, ওটা টেক টিম দেখে নেবে, করে দাও, মেল করে দাও. Okay, thank you. Bye-bye. So Shotadipa ma'am, you are the host now. Sorry for having, taken so much of your time.
No, sir. Today I have a short class.
Okay.
Short topic.
Okay, good. Thank you. Bye.
Good evening, everyone. Very good evening. Today you have done a long class of physics. So do you have interest of finishing the last part of the tissue? Okay. Very good. So today we are finishing our last session of tissue. So we have done all the plant tissue and animal tissue. The two main animal tissue we have already completed, and the two remaining part is muscle tissue and the nerve tissue, right? Okay. So in epithelial tissue and the connective tissue, do you have any doubt? You will tell me the okay, sorry, Oishani, I have forgot because that day we are too much late. Okay, so now I am telling this. What is the features of the epithelial tissue? The epithelial tissue is our no problem. Today I will think that we will done a recap class where we will discuss all about the plant tissue and also the animal tissue part. So after finishing the muscular tissue and the nervous tissue, yes, Shambhav, I will again repeat the entire tissue part, including plant tissue and the animal tissue. Then I think we will complete entire part. Okay, so let's start. Okay, no problem, Oishani. Yesterday I also forget about that I cannot complete it. Okay, now let's continue. So the muscular tissue or the muscle tissue. So muscle tissue is actually the main tissue that helps us in our movement and locomotion. If we don't have this muscle tissue, then we are unable to move. And if any problem happens in this muscle tissue or some muscular tissue becomes damaged, then we becomes paralyzed also, right? It is a yes, it is a contractile tissue. And why it gets its contractility, I will show the picture and the reason of their contractility, why they are able to contract but other tissue are not able to contract. Do you know what are the main component that provides them this contractility power, but the other group of tissue doesn't contain it? So you can think, or if you don't know, voluntary muscle, Adri, so I think you are talking about the type of tissue, but instead of the voluntary muscle, involuntary muscle also can contract. Okay, so no, Shambhav, skeleton is contractile. Skeleton becomes which group of tissue? Skeleton belongs to which group of tissue? Skeleton, bones, no, skeleton or skeleton. Okay, you are talking about, yes, it is a connective tissue. Okay, no problem. I will tell why. Yes, it is a connective tissue part, and I will tell how it gets its contractility power. So all the body muscles in our body is actually made up of this muscle tissue, and it is the only tissue so it can contract. Okay, it has flesh, so it can contract. No, the main reasons of this muscle tissue contractility due to two protein. Actually, two protein takes the major role for their contractility. So now can you remind which are the two protein who provides them this contract? Yes, very good, Ishan. It is actin. Number one is actin, and its friend always come together, myosin. Okay, no problem, Ishan. Actin and the myosin. So in our body, all the muscle tissue is actually muscle is made up of the muscle tissue, and they are only able to contract and relax due to the presence of two protein called the actin and myosin. Okay, Shambhav, calcium is actually the mineral. Okay, so during this contractility, calcium plays the major role. Calcium helps in this contractility, but the two structural protein, actin and myosin, control this contraction, and the calcium actually stimulate this contractility. If the calcium doesn't perform its functionality, then those actin myosin are unable to contract. So all the muscle tissue actually, the as it is a tissue, then what is its unit? So the cell, what is the cell of the muscle tissue? It is known as the muscular fiber. So can you see this picture? This is actually the muscular fiber cell. Okay, when all these muscular fiber cell join together or arranged in a side by side arrangement, it will form this muscle tissue, and different, and when a group of muscle tissue ultimately form this muscle. So this is a complete muscle that is present in our hand, in our present in our limb, surrounding the surrounding our internal organ, in whatever part. This is the complete muscle. Okay, and when the group of muscle tissue complete this muscle, and this is a single muscle fiber. Muscle fiber means single muscle cell. So these single muscle join together to form this muscular tissue, and each single muscle fiber is actually made up of this sarcomere, or also known as sarcomere is actually the unit of the muscle fiber, and this sarcomere is actually made up of actin. This blue color structure is actin, and this red color structure is myosin. Orange one is M band. Yes, if you are talking about the bands, it becomes too much complex. Okay, if only now for your class you can say it as a thick filament and the thin filament. So this myosin or orange band forming this thick filament. Thick, it is structurally slightly thick, and this actin filament is the thin filament. When these thick and thin filaments slide past each other, so how this contractility comes? These two filaments actually slide past each other, just like this. Due to the sliding of this thick filament and thin filament, these muscle cells can able to contract. Yes, how do they slide? It is a very complex process where calcium plays a major role. Okay, when the it takes some time. Okay, it takes some time. So if we can we complete the entire slide, then we can talking about Isha, because we have to finish our topic, then we can go for this, how this muscular contraction will occur. Okay, but due to number one, nervous system or nerve impulse stimulate the muscle cell, then the calcium ion enters, takes a major role between this actin and myosin filament, and then this actin myosin filament starts to contract or starts to slide past each other, and thus the way the contractility happen. Okay, this is just a very base level explanation, but it involves a two more kind of protein and several more complex process. But so the all the muscle tissue is made up of the muscle fiber cell. It is the unit of the muscle tissue, and the contractility is coming from the actin, which is known as the thin muscle filament, and the myosin, which is the thick muscle filament. And when these two thick and thin muscle filaments slide past each other due to the stimulation from the nervous system, then the muscle can contract. Okay, now it is very easy question. What are the three types of the muscle tissue? Everybody knows it. I know everybody knew it. Three types of muscle tissue. Am I audible? Okay. So the three types of muscle tissue, that is, yes, the smooth muscle tissue, cardiac muscle tissue, striated, or the skeletal muscle. Very good, Adrita and Shambhav. So there are mainly three types of muscle tissue. The striated muscle can be also known as the skeletal muscle, the smooth muscle, and the cardiac muscle. Now we will talking about the different structure of the skeletal muscle, smooth muscle, cardiac muscle, and how or the way of their functioning. So the first one, that is the skeletal muscle or the striated muscle. So according to the name, striation or the striated. Why it is called striated? Due to the presence of this light and dark band. Everybody can see this picture, this banding. So due to the presence of this band-like structure, it is considered as the light and dark band-like structure. It is called as the striated muscle. And And this banding is actually coming from those thick filament and the thin myosin filament. Due to this banding is actually happened due to the presence of the particular arrangement of the thick myosin filament and the thin actin filament. Due to the particular arrangement, as Ishan is talking about M band, there are different types of band: M band, Z band, A band, H band. Due to the different type of arrangement of this thin and thick myosin filament, this banding is happened. Okay. And the another important thing is that these are the elongated cell, like it is a long pipe like cells. It is elongated narrow cell. Ishan, this A band, H band is little bit of confusing. Okay, it is actually the part of the sarcomere of the muscle. It is too much complex for your standard. If you want to know this, you ask me on the discussion forum. I will answer it, and also showing you the picture also. You asked me on the discussion forum, okay, on the ELC app. I will show you the picture also and the different function of this A band and H band. Okay, Ishan? Acha. Now, these skeletal muscle cell, yes, very good. The cytoplasm of the muscle cells is called the sarcoplasm, and also the endoplasmic reticulum, mainly the smooth endoplasmic reticulum of the muscle cell called the sarcoplasmic reticulum. Okay, so this is a very special type of tissue or special type of cell that have some type of modification. That's why it is different from the other group of cell. But according to up to your class, what are the different types and what are the different function is essential for you. Okay, so now let's talking about the skeletal muscle. As there is the light and dark banding is there, that's why it is considered as the striated muscle. Number 2, these are the cylindrical like structure. It has the long narrow pipe like structure. Number 3, most important point, it is multinucleated. You can see under the microscope how many nucleus is seen. It is more than one nucleus is present. It is multinucleated. Okay, having more than one nucleus, and it is unbranched like a pipe. It is not branched, it is unbranched. It is cylindrical, it is multinucleated and having light and dark banding. That's why it is called as the striated muscle or the skeletal muscle. Why it is called skeletal? Because it is attached with our bone, with our skeletal system. And the skeletal muscle actually forming the 50% of our total body weight. Okay, this is another important part. Whatever weight we are carrying due to this muscle, mainly the skeletal muscle and the skeletal system or the bones. And now see why it is called the skeletal muscle. As I have already said, it is joined with our bones, arms, limbs, face, neck. Entire skeletal system is, yes, bicep, tricep is associated with this with this skeletal muscle is associated with this bicep and tricep. And you can see those are here also you can see the striation is shows. That's why it is considered as the striated muscle. And the most important thing is that it is voluntary muscle. That means we can control our contraction and relaxation of the skeletal muscle according to our wish, because it is associated with the somatic nervous system. Somatic nervous system means the nervous system that we can control. So if we need to move our hand, we can able to move it due to the contraction of this hand muscle cells. So this is the voluntary muscle, and it is this skeletal muscle is actually the only voluntary muscle that is present in the organism, because both the smooth muscle and the cardiac muscle is uncontrollable. That means we can't control the contraction and the relaxation of the smooth muscle and the cardiac muscle. So only the skeletal muscle is under the control of us. So here it is also the picture under the microscope. It is much more clear picture, and you can see how prominent the banding is, and you can see the different more than one nucleus is present, and It is the cylindrical in structure. It is cylindrical in structure. Okay, this is up to the skeletal muscle. Now the next group of muscle is the unstriated smooth muscle. It is the main point that smooth muscle is spindle shaped. You can see this picture. It is fusiform in structure or spindle shaped. That means both the end is tapering and the middle portion is broad. But in case of skeletal muscle as well as the cardiac muscle, this kind of structure is not present. Only the smooth muscle cell is actually the spindle shaped in structure. And the another important point, it is uninucleated, means it contains only one. Yes, it is lining the stomach intestine. Very good. How they contract? Ishan, they also contain the thick filament and the thin filament, but they are not 6 number slide. Yes, Shambhav, it is involuntary muscle. It is involuntary muscle. This is the 6 number slide, Ujal. Do you have any doubt, Ujal, in this slide? Should I repeat or do you have any doubt, Ujal? In this slide, I am talking about the skeletal. Okay. So done. I am moving to the next slide. Blood vessels contain, yes, Ishan, I am showing the picture how the blood vessels are surrounded by the smooth muscle. So you have asked another question, then how they can able to contract. These smooth muscle also contain the thick myosin filament and the thin myosin filament, but those arrangement is different. They are not forming such a banding like structure, right? Those thick filament and the thin filament এখানে কিন্তু কোনো ব্যান্ডের মতো স্ট্রাকচার ফর্ম করে না, they are uniformly separated. That's why we can't see such kind of striation. ওই striation গুলো আমরা দেখতে পাচ্ছি না because this kind of banding like structure is not formed. Only it is found in the skeletal muscle and also in the cardiac muscle. That's why they are striated. But in smooth muscle, those kind of banding, those kind of particular arrangement of the thick filament and thin filament doesn't happen. They are uniformly scattered, and it is uninucleated muscle and it is spindle shaped in structure. Okay, and they are slightly smaller in length. The skeletal muscles much more longer in shape, but in this case it is smaller in shape. And as you have already said, these are the involuntary muscle and they can line the stomach lining, the blood vessel lining, also urinary bladder lining, and different other internal organs are actually lined by this smooth muscle cell. So this is the part of our digestive system or alimentary canal. So here it is lined by this smooth muscle cell, and you look and you can see there is no such striation, but those spindle shaped muscle are completely associated. They are compactly arranged with each other, right? And there is no such striation. That's why unstriated muscle and involuntary, because they are controlled by their own. Their contraction and relaxation completely depends on their own, rather it is controlled by the autonomous nervous system. In your next class or in your, depending on your chapter, you can understand what is autonomous nervous system, what is somatic nervous system in the nervous system chapter. But autonomous nervous system, that we are not able to control, it is internally controlled. So this involuntary muscle is controlled by the autonomous nervous system, but the skeletal muscle is controlled by the somatic nervous system. Okay, we can't control the function of this involuntary muscle. Number 3, that you have already said, it is how it lines the blood vessel, how it lines the intestinal lining. So it simply surround the wall of the alimentary canal or the blood vessel, also present in the urinary bladder. It surround our respiratory tract, means the trachea. Those tracheal pipe is surrounded by this smooth muscle. Can you tell me which cell this is? This is the blood vessel. Okay, this is the picture of the blood vessel. Through the blood vessel, through the pipe of the blood vessel, blood is moving. And this is one epithelial layer, has a particular name. And just surrounding this epithelial layer, this spindle-shaped smooth muscle lining is there. Depending on the contraction and relaxation of this smooth muscle, the blood vessel diameter either increases, a huge number of or the greater number of blood can pass through it, and if the diameter decreases due to the contraction of the smooth muscle, a lower amount of blood can able to pass through it. Okay, now everybody understand how the smooth muscle lining control the squeezing and the relaxing of the smooth of this blood vessel lining and the intestinal pipeline. Okay, I am asking one question. Can you recognize this cell? This is a epithelial cell. Epithelial cell. Epithelial cell. I am not taking the particular term. Epithelial internal lining of the blood vessel. This particular group of cell. What is this? Other students? Oishani, Ishan, Adrito, Arnob, Ujan. Anybody? Epithelial tube? No, no. It has a particular term. Srijoni? Okay, Srijoni, do you understand up to this? Do you have any doubt? Yes, Ishan, it is endothelial cell. Why there is the question mark? Why? It is endothelial cell forming the inner lining of the blood vessel, right? It is the squamous epithelial cell that forming the inner lining of the blood vessel. It is endothelial cell. Why there is the question mark, Ishan? Okay, you have to understand, you have to remind this because this is a very important short question that what is endothelial, what is adipose tissue is a connective tissue, and adipose tissue is actually present in the different organ, not present in the blood vessels. Okay, so this is the endothelium cell, and just surrounding the periphery of the blood vessel, these smooth muscle cells are present. Depending on the contraction and relaxation, the diameter of the blood vessel can be increased and decreased. And the peristalsis movement, that is the movement of the food bolus that pass through the alimentary canal through the esophagus, is also controlled by the smooth muscle cell. Okay, so the peristalsis movement, the movement of the blood is also controlled by the smooth muscle. Now, so we have done the skeletal muscle and the smooth muscle. Now this is the cardiac muscle. This cardiac muscle is actually the fusion of both skeletal muscle and the smooth muscle. Why there is the fusion? Number one, it is involuntary like the smooth muscle, but it is striated like the skeletal muscle. Okay, that's why you can consider is a fusion of the these two group of muscle. In heart, yes, cardio, always the cardio term related to our heart. So always this cardiac muscle present in the heart. Yellow band, the basement membrane in this slide 9. Okay, this one. This is the basement membrane. Very good. This banding is called the basement membrane, over which the endothelial cell is firmly attached, and there is the peripheral lining before after the peripheral lining or the peripheral lining of the blood vessel. This is the smooth muscles. Yes, cardiologist is cardiac muscle. Cardiologist means who deals with entire our heart, not only particularly to the cardiac muscle. It can be the any heart related problem like heart blockage, angioplasty, angiogram, these kind of things is these cardiac muscle always act continuously. They never tired. This is the amazing creation of the nature, that a muscle is continuously relaxed and continuously contract and relax without getting tired. And it is the functional 24/7. If it becomes non-functional, we will die. So it is a great creation of nature, or it can be the god. So cardiac muscle is actually short in structure. It is not so much long like skeletal muscle. It is cylindrical, like pipe-like structure. It is branched. It is another important. It is branched. In this case, will it stop working if we stop or hold our breath? I think no. Uh, if we holding our breath, then we are dealing with our respiratory tract, not dealing with our heart muscle, right? If we try to stop our breathing, we are dealing with controlling our respiratory tract functioning, not with our heart muscle. Okay. Acha. Now this cardiac muscle is actually very much branched, and it is striated like skeletal muscle. That means it shows the banding of the thick filament and the thin myelin filament. It is uninucleated, means it also contain a single nucleus like the smooth muscle cells. And this is the function or the different structural features of the cardiac muscle. And this cardiac muscle is involuntary in nature. That means we can't control the contraction and relaxation of this muscle, and it is working 24/7. That means it cannot get tired, and it contract and relax in a rhythmic manner. Name of the special muscle which conducts the nerve impulse through the cardiac muscle. What is the special muscle which conducts the muscle? Number one thing, muscle cannot conduct the nerve impulse. Okay. Nerve impulse is always conducted through the nerves, but the nerve is actually at the last point, or the motor neuron transmit their final nerve impulse to the muscle. So I think you are asking about which means how the nerve impulse transmitted to the cardiac muscle. In this case, also the autonomous nervous system control the contraction or sending the nerve impulse to the cardiac muscle. Autonomous nervous system. Okay, Ishan? Autonomous nervous system. Only the skeletal muscle functioning is controlled by the somatic nervous system. Both the smooth muscle and the cardiac muscle contraction relaxation is controlled by the autonomous nervous system. Okay, so these are the different group of or the three types of muscle cells. Neuron, yes, we will talking about the neuron. So what is neuron? Shambhav, I will discuss it in upcoming slide. We are talking about the neuron. So do you have any doubt about the muscle tissue নিয়ে কোনো problem আছে, doubt আছে? No. Okay, very good. Now this is our last group of tissue. The blue muscle is okay. Then I will check which muscle transferred the nerve impulse to the cardiac muscle. Actually, I don't know also. I think blue muscle. You are talking about the blue muscle. Okay, I will check it. Neuron isn't muscle. No, Shambhav. Neuron is completely different group of cell. Neuron belongs to the nervous system. Neuron is actually the structural and the functional unit of the nervous system. So muscle cell, in case of muscle, the unit is muscle fiber. Okay, Ishan, very okay. Okay, you can send me, or you can post it on the discussion forum also. Then I can see it. Okay. Acha. So the nervous tissue, the structural and the functional unit of the nervous system is this neuron, which is also known as the nerve cell. It is an elongated structure. It is so much elongated that in human, most of the neuron is actually 1 meter in length. That means it is too long, and the brain, spinal cord, and all the nerves is actually made up of this neuron cell. So the nervous system is actually controlled by this neuron. Okay. Now, so our entire nervous system that include the brain, neuron has two main part. Yes, dendrites and axon. Very good. And yes, Shambhav, the neuron has two main type and also the three. Yes, the cell body is the, you have missed. The cell body is also known as the cyton or perichiron. So this is the entire neuron. Okay, it is highly elongated structure and you cannot find any similarity of this neuron with any epithelial cell or any any connective tissue cell or even the muscular cell, because muscular cell is also cylindrical, but it is a cylindrical like structure, but it is not so much branched like the neuron. The neuron is only shows the maximum branching, because in case of cardiac muscle also some kind of branching is shown, but it is branched like a root hair, like a root. So can you tell me what is the importance of this branching of this neuron? Why it is so much branched? What is the importance of having so much branch? Anybody? Or you can, what do you think? Shambhav, Ishan, Adrito, Srijoni, Oishani, anybody helps us to navigate using brain. Okay, controlling much better. Or no, yes, or no, transmitting message. I think the particular term can be making much more connection, because we are transmitting the signal. If the branching is much more, the connection is much more. So we can easily transmit the signal. Myelin sheath helps in, yes, I am talking about, I will talk about this myelin sheath part. Wait, Ishan. So this branching is actually increasing the connection between the cells. Yes, in the form of electrical signal. So if it is lesser in branch, then it is able to transmit the signal only few group of neighboring cell. But if you think there is two branch, then it only send the impulse only the two group of cell. But if there is the 5 branch, then it is easily transmitting 5 group of cell. So the branching is increasing the connection between the remaining neighboring cell, right? So branching increasing the connection. That's why it is so much branch rather than other group of cell. Everybody understand this? If there is 2 branch, then there is little connection. But 5 branching increases the connection rate much more. And these few short branches are called the dendrites. And this is the cell body. Okay, cell body contains the nucleus. It also contains the ribosome. It also contains the other cellular organelles except centrosome. Centrosome থাকে না. Neuron doesn't contain centrosome. That's why they are unable to divide. Okay, this is one another important short question, that the neuron doesn't contain centrosome. That's why it is not able to divide, but it can contain other group of cell organelles. And from the long single branch that is coming help in making impulse pressure lighter. Impulse pressure, there is impulse signal or the voltage. Okay, actually the term is actually the voltage. Here no such pressure like function doesn't happen. Actually these I am talking about the two minerals, sodium and the potassium. Sodium and potassium plays the major role in transmitting this electrical impulse. So in normal case, the outer layer of the neuron is actually the negative. When a particular signal activates this neuron, this negative ion changed, or the negative impulse changed into the positive impulse. Okay, so if the impulse getting changed from negative to positive, then it transmit the signal to the next group of neuron. And that is the main, here the pressure doesn't occur. here the changing of the electrical impulse plays the major role. And as you are talking about what is the importance of this myelin sheath, okay, so this is actually the swan shell. This is you can see the transparent cell, it is the swan cell, and this swan cell making this myelin sheath, and this myelin sheath actually acts like a insulator. Insulator means unable to unable to divide. Then how they are replaced? They are not actually replaced, they are elongated, they are getting elongated, and up to the adult age, up to our adult age, it can able to elongate, but it is unable to divide. And so in a small baby, the number of neuron is similar to an adult person. Okay, neuron number will not change, but their length can be elongated. Okay, and that's why in our brain, when our nerve cell, if our neuron getting degenerate, we are suffering from Parkinson's disease, we are suffering from several neurological disorder, Alzheimer, Parkinson's. Why? Because our nerve cell, neuron cell getting damaged. How they are created then? During the during our birth or during our development, this neuron cell actually developed from the neural ectoderm. This is too much complicated thing. Neural ectoderm থেকে এই neuron cell গুলো তৈরি হচ্ছে, আর ওটা at a time all the neuron cells are originated. After that it only elongates. Okay, but if sometime any damage happens in this neuron, then there is the one group of cell, neuroglial cell, that can replace it. Okay, there is some group of cell, neuroglial cell, that present within this nervous system, that they can replace the function of the neuron cell. So now what I am talking about, this is the myelin sheath. Swan cell forming this myelin sheath, it acts as a insulator, so that it unable to only this part, the nerve impulse or electrical impulse unable to transfer. That's why electric impulse actually jumped from this Ranvier node. So between these two myelin sheath, those particular area is called the node of Ranvier. Through this node of Ranvier, this electrical impulse simply jump, so that our nerve impulse can easily transmitted from one neuron to another neuron, simply jumping of the impulse. Okay, is it boring? Do you understand if it is too complex? Okay, so this is the main part, that the okay, no problem. So the neuron have main three parts. One is the cell body called cyton or perichiron. Then there is another part, dendrite, that is actually getting the signal from the previous neuron. Okay, Srijani, why they are unable to divide? Because the cell body, within this cell, there is one organelle called centrosome. Centrosome is essential for the cell division process, because it actually helps to form the spindle fiber or help in segregation of the two cells. But as here the centrosome is not present, so they are not able to divide. That's why the neuron cell are unable to divide, due to the lack of centrosome cell organelle. Okay, and then there is a very long single branch called the axon, and this axon is covered by the myelin sheath, which is a part of the swan cell. And between these two myelin sheath, there is a very short area of the axon, which is called the node of Ranvier. And between these and this myelin sheath and the node of Ranvier actually helps in transmitting the signal, transmitting the electrical impulse very rapidly from one neuron to the another neuron. And the last part, that I have said how neuron actually transmit the signal. Either neuron transmit the signal from one neuron to the next neuron, and this junction between the two neurons is called the synapse, or the last neuron, the last motor neuron, transmit the signal to the muscle. So the nerve impulse can be either transmitted from one neuron to the next neuron or from one neuron to the muscle. And when the impulse is ultimately enter into the muscle, we can function accordingly. Okay, so if we touch any, যদি আমরা কোনো গরম জিনিস টাচ করি, নার্ভ ইম্পালস গেল, our sensory receptor সেন্স করলো too hot signal, নার্ভ ইম্পালস গেল, আমাদের ব্রেন প্রসেস করলো, মোটর নিউরন ফাইনালি মাসেলকে ইনপুট দিল হাত সরাও, তো আমরা হাতটা সরিয়ে নিলাম। So this is the ultimate way of functioning of the neuron and the muscle. And in this particular junction is called the neuromuscular junction, where the calcium plays a huge essential role. Okay, so through the nerve impulse, in transmitting the nerve impulse, sodium and potassium ion plays a great important role. And in this neuromuscular junction, calcium plays a very important role, where the calcium, when the ultimate signal activate the muscle cell, some gate open through which the calcium can enters into the muscle, and it controls the thick filament and the thin filament. It instruct those calcium muscle instruct those thick filament myosin and the thin filament actin to slide. When they start to slide, we can contract our muscle. Okay, everybody understand this, how neuron transmit the electrical impulse? Stimulus gives. Okay, wait. Shambhav is saying. Acha, spinal cord bias. Yes, yes, Shambhav. That is the way through which the entire nervous system actually performs. Neuron does the neuron transmit message? Yes, it can transmit a message within a millisecond. Can you imagine, within a millisecond the transmitting of the signal is happened, within a millisecond, fraction of a second. And when the impulse is so the impulse can be transmitted from the neuron to another neuron. All this is done in a very less time. Yes, Shambhav, within a millisecond, within a fraction of a second, this transmission of the impulse is changed, and ultimately when it reach to the, or ultimate function is achieved when the neuron transmit its ultimate signal to the muscle cell and stimulate the muscle to contract and relax, then we can contract it. As the spinal cord does contain some of the tissue which is contained in the brain. Yes, cerebrospinal fluid. Yes, cerebrospinal fluid is another essential fluid that is present within the brain, but in this case the neurotransmitter actually plays the important role. Is there any type of nerve cell? Nerve cell, the neuron and the neuroglial cell are the two important nerve cells. The neuron plays the major role in nerve transmission, and the neuroglial cell is actually supporting, giving the nourishment to the neuron cell. Gray matter, I will tell about this gray matter and white matter part in the nervous system. It is not belong to this, it is a part of our brain. Okay, it is a part of our brain. And I can say there is one neurotransmitter is generated called the acetylcholine. Okay, this acetylcholine neurotransmitter plays an important role to signal, to stimulate the next neuron or stimulate the muscle cell. So this neurotransmitter is another. What is dopamine? Dopamine I forget, but dopamine is related to the nicotine, dopamine. This kind of thing is actually the neuromodulator or the neurohormone. Okay, this in brain gray matter is also. Okay, I will tell about this brain gray matter and white matter in another class of the brain or the nervous system. And dopamine, nicotine, these are the different neuromodulators that can either enhance the power of the nervous system or inhibit the nerve impulse transmission through the neuron. Okay, so Do you have any doubt? Then I will start to do a quick recap. Then I will show the class quiz. So do you have any doubt about skeletal muscle and the do you have any doubt? Okay, so let's have a very quick recap that the plant tissue and the animal tissue, mainly we covered the in plant there are two group of tissue, dividing tissue or the non-dividing tissue. Here the meristematic tissue is only the dividing group of tissue, and the non-dividing group of tissue is generally termed as the permanent tissue because it doesn't show any kind of division, any kind of growth. But in this simple permanent tissue, when all the cells are similar type, parenchyma, collenchyma, sclerenchyma, all cell look similar. Yes, it is Shambhav, it is our last chapter. That's why we are doing a complete recap. It is just a very complete recap. Okay, Shambhav. Now, so what happens in parenchyma and collenchyma was the living group of cell, but the sclerenchyma is the dead group of cell, and they doesn't shows any kind of growth. And the complex permanent tissue, this is made up of the phloem and the xylem. Here the phloem is belongs to the living group of tissue and the xylem belongs to the dead group of tissue, and the xylem helps in water mineral transport in unidirection way, but the phloem takes part the transportation of the foods in both direction. And the what are the water conductive cells in the xylem? What are the water conductive cell? There are 4 type of cell. Only the 2 able to transport water. Similar happens in case of the phloem also. Yes, very good, Arnav. Only the trachea and the xylem vessel takes part in the water conduction. And the trachea is present both the lower group of plant include the higher group of plant. But in xylem vessel only present in the higher group of plant. Very good, Shambhav and Oishani. The similar thing in case of phloem, there are 4 group of tissue, but only 2 take part in the food transport. What are those? What are those? Number 1, companion cell. Yes, the companion cell, and companion cell is actually helping the other cell. But the sieve cell, okay, the sieve cell, phloem, no, phloem, yes, Arnav is right, companion cell and the sieve cell, but the sieve tube plays the major role in transmitting the water, and the companion cell helps the sieve cell. Okay, now, so these are the different important plant tissue. Next, that is the animal tissue. And what is this animal tissue's importance? Animal tissue mainly includes 4 group of tissue, and all are the dividing except the neuron tissue or the neuron. Only the nervous tissue are unable to divide, but the all other group of tissue can able to divide. And the epithelial cell, actually I am telling what is the features of this epithelial cell. Epithelial cell is able to, it is the protecting layer. It is attached with firmly attached with the basement membrane. It can able to absorb, secrete, and give protection. And it helps in the transportation of the respiratory gases. And the connective tissue makes the connection. It can be liquid, it can be solid, or very hard. And today we will discuss the skeletal tissue and nervous tissue. Okay, so everybody understand this? Do you have any doubt? Then I will show the class piece. Okay, very good. Then I will show the class piece. Now you can start. Question number 1, 2, 3. Okay, very good, Oishani. Very good. Now, question number 4, 5. Acha, 3, 4, 5. Very good, Ujan. Very good. 4, 5 done. Completed 4, 5. Question number 6, 7, 8. Okay, Advita, I will repeat. No problem. I will repeat question number 3. Ishan, I will repeat the question number 5. 5 and 3 I will repeat. Now you will do the 6, 7, 8. Again, I will repeat those two. Okay, 6, 7, 8 done. 8, 9, 10, and I will repeat the question number 3 and 5. Okay, 6, 7, 8. Done. Very good, Oishani. If you have done, you can submit. Very good, Shambhav. You can submit. And Ishan and Adrito, this is question number 3 and 5. 3 and 5. Very good, all no. You get 40 out of 40. Very good. Okay. So, question number 3 and 5. Very good, Ujan. You can submit your answer. Very good, Oishani. You also got 40 out of 40. Shambhav, Ujan. Srijoni, do you have any doubt? Question number 9 and 10. Yes. Yes, Oishani, it was easy. And in weekly quiz, you can get the question from the entire topic. You will get the question from entire topic. Okay, very good, Srijoni. Okay, so done. I am quickly showing the answer because already class 9 students started to enter. Okay, I am just repeating it. I'm showing the answer. Which tissue helps in movement, locomotion? Muscle. Actin myosin present in the muscle cell. Then the skeletal muscle is elongated, unbranched, multinucleated. Smooth muscles is spindle shaped in structure. Very good, Ishan. And the smooth muscle is found surrounding the blood vessel and and the alimentary canal. Then 6, the which muscle tissue? Okay, we have to submit a admit. Then this is the last 2 question. Oishani, which one? From 1. Okay, class 9 students already entered. Okay, from 1. This is the question number 1. Question number 1. Oishani and Srijoni. Okay, Oishani, you can take a screenshot also. So this is the question, which tissue helps in movement and locomotion? Muscle tissue. And the contractile protein. 4, 5, 6. Yes, I will show the question 4, 5, 6. This is the contractile protein of the muscle cell, actin myosin. Which muscle tissue is elongated, unbranched, multinucleated, skeletal muscle? This is question number 4. Spindle shaped muscle, uninucleated muscle means the smooth muscle. 5. Smooth muscle surrounding the blood vessel and alimentary canal. Then which muscle tissue is striated but involuntary in function? Striated and involuntary. Cardiac muscle is only one, that muscle. Then 7th, involuntary muscle tissue, where we can find both the skeletal muscle and the smooth muscle are involuntary muscle. Nervous system tissue is the neuron, axon, dendron, cyton, all are the 3 parts. And the last function. Okay, very good, Oishani, very good. So Oishani, your doubt is clear about the epithelial tissue. I didn't complete it so much, but just okay. So done. Class 7 done. Do you have any doubt? Then you can leave the class because the class 9 student already come here, already joined with us. Okay, very good. Thank you, class. Bye bye. Bye bye. So Somudro and bye bye, class. Good evening, Somudro and Mihika. Good evening. So today our first class we have completed with the cell, right? Good evening, Somudro. Good evening, Mihika. Okay, so I think we should start our class. And those students who will join later, they can join with us. Okay, so what is tissue? According to you, what can be tissue? Hello, am I audible? So, hello, am I audible? Somudro, Mihika, am I audible? Okay, so no problem, no problem. So in our last class, we have done what is cell and what are the different cellular organelles and what is the function of the cell. So from that our learning, we can say that all the living organisms are made up of cell. Okay, because cell is the smallest functional and the structural unit of the life. So all the living organism is made up of cell. Yes, Mihika, tissue is a group of similar cell performing the specific function. You have mentioned all the two important points. It should be similar in structure or similar in nature and perform the specific function. So the cell is actually the main unit of the life. So now we can see how all the cells are actually arranged in our body. So I am showing one picture. Okay. So can you relate this picture with our body system organization? So here the brick, it is the picture of a brick. Okay. So when these bricks are joined to form the wall, and when four walls join together, it form a room. Room has a four wall and all the room comes under a single house. So the brick is actually the simplest and the unit of the house. So if there is no brick, then no house can be formed. So can you relate this picture with our body system organization? Can you tell or can you write on the chat? Bricks can be act as which unit in our body? Bricks can be resembled. You can unmute also. Yes, bricks are cell. Very good, Somudra. Bricks can be cell. Then which? Yes, wall is the tissue. Very good. And the room and the house is the entire organism. And room. Yes, very good. So the room can be the organ. So you are right. So the bricks is actually, room can be the organ or the organ system, and the room is ultimately, or the house is ultimately the entire organism. That is actually the similar kind of arrangement is also shown in our body. So the simplest, smallest unit of the organism is this living cell. Okay, so all these living cells join in a proper way joined in a particular arrangement and perform a particular function, then it form this tissue. And when the different group of tissue form a single organ that can perform a single function, if it is or if all the tissue joint and form a stomach, then stomach will help in the digestion of the food. Then these organ, the similar kind of organ, the stomach, the intestine, the liver, all are performing the similar group of function. That means helps in the digestive system. That's why it belongs to a single organ system. And ultimately, there are different group of organ system when joined and ultimately form the entire organism. So being a multicellular organism, all the cells, those cells are not present in a scattered way. They are always present in a very compact and in a very proper arrangement. Okay, Anish, you have joined now. So I think Anish, are you well? Because I think in last 2 weeks ago you were not well. So I hope you are well now. So we have done with our cell and we are studying the tissue. Okay. So what is the tissue? As Mihika and Samudra already said that the tissue is a group of cells that are performing the similar kind of function and they are similar in structure and they are located in a particular position. And if in a multicellular organism, all the cells are actually arranged in a not they are arranged in a scattered way. They have a proper orientation. All the cells, depending on their function, they are joined into a tissue. Then the different group of tissue with a particular function form a organ, and all the similar kind of organ comes under a particular organ system. And when the different organ systems are performing, then they will form a complete organism. Okay. Okay, everybody understood this? Mihika, Samudra and Anish? Okay. So now, let's see what is the tissue. So as I have already said, the group of cells with similar structure and function, they are known as the tissue, and they must be located in a particular position. The brain tissue should not be present in our blood vessel. The liver tissue should not be present in our brain. So all the tissue is very much location specific. The tissue is always present in a particular location and they have the similar structure. In general way, there are two types of tissue, plant tissue and the animal tissue. Okay, it is a very broad basic differentiation. Those group of tissue forming the plant body called the plant tissue, and those group of tissue only present in the animal cells is the animal tissue. And can you say the any one difference that what is the basic difference between the plant tissue and animal tissue? There is one fundamental basic difference. If you think about plant and animal, you can able to answer this question. Plant is they can able to move like us. So this is the cell wall. Okay, Samudra is talking about cell wall. That means you are talking about the cellular level. Okay, it can be happen. The cell wall is present in the plant cell. Okay, very good. And what is the purpose of having cell wall? What is the importance of having cell wall? কি help করছে সমুদ্র? সেল ওয়ালটার জন্য কি প্রোভাইড করছে প্লান্ট সেলকে যেটা অ্যানিমাল সেলকে প্রোভাইড করছে না? Yes, they can't move. Cell wall gives the rigidity. Very good. The cell wall also provides the protection, but the most important things, it provides the rigidity. That's why the plant can able to stick into a particular space without they can able to stick to a particular space due to the presence of this hard cell wall. But in case of animal, they are continuously moving. They are highly active and continuously moving and flexible. That's why they don't contain the cell wall. This is the one of the best or the one of the important difference, the presence of cell wall providing the rigidity. The number 2 is that in case of animal, there is the entire organism, the entire organism actually develops. They can actually grows in a equal manner. Okay, they can equal, if our hand is elonging, or if the growth of the animal is equal. But in case of plant, the some part of the plant body start to divide, but other part of the plant is not dividing. So this is another important part, is that the plant body doesn't shows the division in a proper way. Means some part of the plant can able to divide, but the other part of the plant unable to divide. But in case of animal, they are growing, they are developing, they are dividing in a uniform way. There is no such non-dividing part and the dividing parts. This kind of differentiation is not present in animal, but it is present in plant. This is another important. So do you have any doubt? Do you understand how plant tissue and the animal tissue are different? Number 1, the cell wall provides the rigidity, and the number 2, the division. The some group of cell is able to divide, but in case of animal, all the cells are uniformly divided. Okay, very good. So the plant tissue and this is the animal tissue. We will discover each and every type of animal tissue. There is mainly the connective tissue, epithelial tissue, muscle tissue, nervous tissue. This is present. So now we are talking about, today we are talking about two types of plant tissue. Number 1, the meristematic tissue, and the number 2, simple permanent tissue. Okay. Today we will discover the meristematic tissue and the simple permanent tissue. So what is plant tissue? It is a very general definition. The similar type of cell performing and the particular function within the plant. Okay, within the plant they are performing the particular function and helps in giving the structure of the leaf, root, stem. So the plant tissue is giving the structure of the leaves, flower, stem, root, and helps in performing the different types of function. They are called the plant tissue. So the what are the different types of the plant tissue? Meristematic tissue and the permanent tissue. These are the very broad difference, or the very broad types. Can you tell me which group of tissue is dividing in plant? Meristematic tissue or the permanent tissue? According to the name suggests. Yes, Somudra, meristematic tissue is actually the dividing tissue, because the permanent means they become permanent. So the division is completely stopped. They becomes permanent. That's why only the meristematic tissue is only shows the division, but the permanent tissue will not show it. Okay, and the meristematic tissue is again divided into apical meristem, lateral meristem, intercalary meristem, and the permanent tissue. Yes, very good, Anish. And the permanent tissue divided into two parts: simple and the complex. Simple part, why it is called simple? Because it is made up of similar type of cell. Similar type of cell. So the all parenchymal cell look similar, all the parenchymal cell look similar, all the sclerenchymal cell look similar. So they are made up of single type of tissue. But in case of in case of complex permanent tissue, more than one type of cell present. So the complex tissue, here the xylem and phloem, it is actually made up of 4 group of cells. That's why it is called complex. I will discuss each and every point, but it is a general division of the plant tissue. So the first part that today we will cover meristematic tissue and the simple permanent tissue. So as you have already said, the meristematic tissue is the only actively dividing tissue, or the actively made up of actively dividing cells. In other group of cells are unable to divide. Only these group of cells divide and produce a mass of cell and from that mass of cell, the ultimate or they are actually differentiated into other group of tissue. So meristematic tissue forming a mass of cell that will differentiate or mature in a different mature and giving the different structure. So this is the dividing cell, and it is present only within the, this is the root tip, and this is the shoot tip, or present surrounding the stem. So these actively growing cell কোথায় কোথায় পাওয়া যাচ্ছে? Present within the root tip, shoot tip means it shows the vertical growth in both the direction, in upper direction and the downward direction, and it shows the surrounding growth, or it shows the lateral growth. So it is present between the bark and the wood. The bark means outer protective layer, the outer dead protective layer of the stem, and the wood part is actually formed by the xylem. So this is, the wood is actually formed by the xylem. So in between the bark and the wood, this another the meristematic tissue is found. So what are the main, so where is actually located? Mainly in two parts: outer the tip of the root and shoot, and the lateral surface of the stem. So here we can find this meristematic tissue. As you have already mentioned, the main characteristics of the meristematic tissue, it is very important. You can, if you see this particular picture, you can able to remind all the essential characteristics of this meristematic tissue. What is that? Number one, the cells are small. You can, if you see this picture, you can able to understand they're so small under the microscope. If you can see, they're so small, so tiny, and they're compactly arranged. And in this higher magnification, you can see it is cuboidal in structure. It has a very large nucleus because it is continuously dividing. It is actively dividing. So due to the higher rate of cell division, the nucleus is very large, and it contains very small vacuole, or sometimes it doesn't contain the vacuole at all. And the cell wall is very thin. If the cell wall becomes rigid, if the cell wall becomes thick, it becomes dead cell. It becomes non-dividing one. So as it is a very dividing cell, that's why cell wall is very thin and they are compactly arranged. You can't, can you find any kind of intercellular space? Can you find any kind of intercellular space? No. These meristematic tissue are compactly arranged so much, they are tightly arranged so much, so that we can't find any kind of intercellular space. So do you have any doubt about these characteristics of the meristematic tissue? Okay, so these are the very small, very compact cell without any intercellular space. The nucleus is very large, and sometimes the very small vacuole is found. And the main function, the main feature is that the cell wall is very thin. But in other case, when the cell wall becomes much more thicker, it becomes dead. Okay. And now you have already mentioned the three type of this meristematic tissue. The apical meristem. According to the name, apical means it always present in the root tip and the shoot tip. So it is present just the pointed end of the root or the shoot. And the intercalary meristem. Do you know what is axillary bud? Do you have any idea? If you see this picture, this is the node and the internode. This is the node from which the leaf, the point from which the branch or the leaf are coming out from the stem. This part is called the node. So this nodal part or the leaf base and this internodal part actually contains this intercalary meristem. That means it increases the branching, the formation of much more branch, formation of much more leaves. It will form due to the presence of this intercalary meristem. And this lateral meristem, it increases the width, it increases the width of the or the diameter of the stem. So it increases the lateral surface of the of the plant stem. Okay. So do you understand? Do you have any doubt, Samudro, Mihika, Annesh, and Shukri? Do you understand what are the three main parts of the apical meristematic tissue? The apical meristem, intercalary meristem, and the lateral surface. According to the name, the apical meristem increases the vertical growth either in upward and downward direction. Intercalary meristem, this intercalary meristem present at the nodal part. Nodal part means that increases the branching, that helps in the formation of the new leaves. So this is the intercalary meristem, and this lateral meristem increases the lateral surface of the stem or the width of the plant. Okay. So we have done with the meristematic tissue. Now we will start the simple permanent tissue. So I think everybody understand, and you don't have any doubt in meristematic tissue part. Okay. Now start with the simple permanent tissue. So what happens? What I have already said, it is permanent tissue. That means its growth becomes permanent. Means it is now it is not able to divide further, and it doesn't shows the growth much. Its growth becomes static. So it is made up of non-dividing cell. Under this is the microscopical structure. Okay, and from this structure we can easily say which are the different types of this tissue. This outer layer, and under the microscope we can easily say, okay, this group of tissue is the parenchyma, this group of tissue is collenchyma, this is the protective tissue, because they, number one, their position is fixed, their position is permanent, their structure is permanent, and just seeing the microscopical picture we can easily say, okay, this is the parenchymal cell, okay, this is the outer protective layer or epidermis, this is the collenchymal cell, because they are permanent in position. They don't change their shape neither, and they don't change their position. Okay, they remain static in their structure and the function also. And the main function is that they actually providing the support of the plant and providing the structure of the plant. It forms the bulk of the plant body. Entire plant mass is actually formed by this permanent tissue. Okay, now can you everybody understand this slide? So at first the meristematic tissue will form. Okay, only the meristematic tissue is the rapidly dividing tissue. It starts to grow, it starts to divide in a very rapid way, and after that it starts to mature. It stops its division and it starts to mature, and it grow, and it's, so what happens here? At first the division of the meristematic tissues will occur, and it starts to form the new group of cell. Okay, all the meristematic tissue divides and starts to form a new group of cell. All this new group of cells starts to grow, starts to mature and differentiate into different permanent tissue. So one group of tissue becomes having the thin cell wall, then it forms the one group of tissue. One group of tissue have the intermediate cell wall, neither too thick neither too thin, so it forms the another group of tissue, and another group of tissue form the very thick cell wall, and it forms the another group of tissue. So the meristematic tissue, when starts to grow, it forms a new group of cell, and it mature and differentiate into different permanent tissue, and it performs the specific function. Okay, so do you have any doubt how from a meristematic tissue the permanent tissue will be formed. Just simply by the division forming a new mass of cell, and then this new mass of cell starts to grow, starts to differentiate, starts to mature, and it forms the specific group of permanent tissue. Okay, everybody understand how from a meristematic tissue the permanent tissue is formed. Okay, now let's see what is the different types of permanent tissue. There are mainly, as I have said, permanent tissue is mainly have two types: simple permanent tissue and the complex permanent tissue. What happens in simple permanent tissue? The simple permanent tissue is again two types: the supportive tissue and the protective tissue. The protective tissue means, can you tell me where the protective tissue should be present? It provides the protection. Then where it should be present in the plant or any organism? It provides the protection. It is a protective tissue. That's why where should be it is located? Yes, very good. It should be present outside of the body or peripheral side of the body. Very good. So always all the protective tissue should be present outer side of the body, the periphery of the body, because they are always, these protective tissue are always exposed to the surrounding environment, and that is not so much good for any kind of tissue. That's why all the protective tissue should be very much they can able to ওর এই প্রোটেক্টিভ টিস্যু গুলো যে কোনো এনভায়রনমেন্টাল ফ্লাকচুয়েশন, এনভায়রনমেন্টাল প্রেসার ক্যারি করতে পারে, বাট দ্য আদার গ্রুপ অফ টিস্যু দে আর নট এবল টু ডু সো। বাট ইন কেস অফ প্লান্ট, the protective tissue, that's why have very thick cell wall, so they can resist any kind of environmental hazard. And there is another group of tissue except protective tissue is the supporting tissue. So where it is the parenchyma, parenchyma and sclerenchyma. These three group of tissue actually form the entire body mass of the plant. Okay, and we will cover this complex permanent tissue in our next class. So as I have said, this is the simple permanent tissue. What is the main features of this simple permanent tissue? That is, it is made up of one type of cell. One type of cell means, if you consider it is a parenchyma, then all the parenchymal cells looks similar. If you consider it is a parenchyma, then all made up of a similar type of cell of parenchyma. If you consider the sclerenchyma, the similar thing happen. But in case of complex permanent tissue, there can be one group of cell of xylem vessel. There is another group of cell can be the xylem fiber. There is another group of cell called trachea. So there are four kind of cell forming a single tissue of xylem. But here the only a single one type of cell forming the entire parenchyma, parenchyma, and means forming the parenchymal tissue made up of only one group of cell. Similarly, parenchyma is made up of one group of cell, and this sclerenchyma made up of another group of cell. And from this picture, I am giving the hint. The parenchyma have the thinnest cell wall. সবচেয়ে পাতলা cell wall parenchyma. Parenchyma having the intermediate cell wall, and the sclerenchyma have the thickest cell wall. Then can you tell me which group of cell is completely dead and which group of cell is living cell in this simple permanent tissue? Which group of cell is the living and the which group of cell is the dead? The sclerenchyma, yes, sclerenchyma is the dead tissue because it has the thickest cell wall, and then rest are living. Yes, both the parenchyma and the parenchyma are living, but the parenchyma starts to become dead because it has the intermediate thickest cell wall. Okay, intermediate cell wall means it is neither too much thin, neither nor too much thick. It is intermediate in structure, but parenchyma is also living cell, but the parenchyma is fully living cell. So at first we will do the protective tissue. So there are two parts, supportive tissue and the protective tissue, and you have already said that it is the outermost layer of the cell. So Somudra already said this is the outermost single layer. So it is another important fact, that is the epidermis should be always, epidermis or the protective tissue, always single layer cell. This is the it is a plant epidermis in this picture. So as it is a plant, so it is the upper epidermis and it is the lower epidermis. So both the epidermis is made up of single layer cell, only the single layer forming this epidermis, and the cells are tightly packed. The cells are compactly arranged. You can't see any kind of intercellular space between these two cells because they are firmly attached with each other. Why? Because it gives the protection. So if there is any gap between these two epidermal cells, then any pathogen or any unnecessary component can easily enter into the cell and causing the harm in this cell, plant cell. But it should not be happen. That's why all the cells are highly compactly arranged. They are tightly arranged with each other, and having the another important thing, it has very thick cell wall, so that it cannot be affected by the any pathogen or any other harmful surrounding environment. So it is present on the outer surface of the leaf, root, leaves, and it have the very thick cell. Easily, it cannot be easily hazard or hampered by the surrounding environment. Okay. And another important features of this epidermal cell is that synthesis of the cutin and the synthesis of the suberin. Can you tell me what is the importance of this cutin and the suberin? It is present, it is secreted by the epidermal cell, that means the protective tissue. Then what is the importance of this cutin and the suberin? No, it is not related with the cell wall. No. It is, they are not actually the component or not helps in the formation of the cell wall. Rather, as it is a present on the leaf surface, or yes, it is actually the waterproof agent. Yes, Shukrit, very good. These layer, both the leaves have the stomata through which the transpiration process is done, so that these leaf cuticle, yes, this is actually the cutin is actually forming the leaf cuticle. These are actually termed as the leaf cuticle because the on the upper surface of the leaves there is the stomata. When it opens, through this the transpiration will occur. So if excess transpiration will occur, the plant will be suffer from dehydration. It is not good for the plant body. That's why this cutin layer actually inhibit the transpiration process. It acts as a waterproof agent, so it prevents the loss of water. This is number 1 point. And in case of the plant stem, that is the bark part is much more thicker. That's why it is made up of suberin. It is much more thicker than the cutin. This pink color layer, everybody can see this. This is the pink color layer. This pink color layer actually formed due to the staining of the plant cell. This is actually the cutin layer, or the cutin layer. Mainly this is the picture of the cutin layer that is secreted by the epidermal cell. So the cutin is the non-cellular layer, non-cellular protective layer, or the cellular protective layer. Cutin, it is a proteinaceous layer which is secreted by the epidermal cell. So it is cellular layer or the non-cellular layer, only the cutin part. Am I audible? Everybody understand the question? The cutin, only the cuticle layer, the cutin part, it is cellular or non-cellular? Yes, Mihika, no, Mihika, it is not a cellular, it is non-cellular because only these layer, only this pink colors layer, it is the non-cellular layer because the cellular part is the epidermal tissue. Okay, this is the epidermal tissue belongs to the cellular part, and these cells are secreting very thick cutin layer, and this thick cutaneous layer or the cutin layer is actually the non-cellular layer. It is only made up of protein. So it is not a cellular layer. Okay, very good. So it is in case of leaf, we find this cutin layer. So it not only prevents the transpiration process, but it also prevents the, it provides the mechanical strength so that lots of insects are present in the, they are actually feeding on the leaves of the plant. They actually, those insects actually feeds on the leaves of the leaves. So these thick cutin layer prevents them to eat the leaves because it becomes too much hard due to the presence of thick cell wall and this thick cutin layer. The insects are not properly digest the leaf. That's why it also provides the mechanical protection. And the parasitic fungus, as this cutin layer is not good for the growth of the fungus also. So that is the purpose of having cutin. And the xerophyte have very thick cutaneous layer because they prevents the water loss through it. Okay, and also uh, mangrove plant also have this cutaneous layer very thick. So mangrove plant is growing in a watery area, marshy watery area. Then what is the importance of having this thick cutin layer? যদি ম্যানগ্রোভ প্লান্টরা অনেক জলের মধ্যেই জন্মায় তাহলে ইম্পর্টেন্সটা কি? তো ওরা তো অনেক জল পাচ্ছে, তো ওয়াটার লস তো ওদের কোনো ফ্যাক্টর হওয়ার কথা নয়। As they are grown in a watery environment, so they have enough water. Then what is the importance of having thick cutin layer to resist the water loss? Very good, Somudra. It is actually the water, though it is lots of water is present, but those are salty water, and that is not good for their growth. That is the one reason they try to absorb very little amount of water, and whatever water they have actually absorbed, they tries to keep it in their body or in their plant body, and that's why it prevents the transpiration process by having thick cutin layer. Very good. To prevent the yes, to prevent the osmosis in the root hair cell, to prevent the absorption through the osmosis process in the root hair cell, because when they are absorbing the water, they also absorb the excess salt that is not good for their health. So for reducing the water loss, they contain the thick cutin layer. Very good. So everybody understand this protective tissue layer? Then we will start the parenchyma, collenchyma, and sclerenchyma. These are easy. Okay, very good. Now we will start the parenchyma. As already Somudra have said that the parenchymal cell is the living cell. Okay, so though they are non-dividing cell, but they are living cell because it contains very thin cell wall, and the thin cell wall always denotes that it is a living group of cell. And the what is the cell wall component? Is simply the cellulose. And the most important thing that it is very large cell. Always the parenchymal cells are very large. It can be circular in structure, it can be oval in structure, it doesn't have any specialized structure is not there. It is unspecialized in structure, but always it is very much large in shape, and it always present in the softer parts of the plant. Then what is the main features of the parenchyma? It is very important. The parenchymal cell having the are loosely packed. That means the intercellular space. You can see my cursor. This is the intercellular space. Means the space between the two cells is too large for their exchange of the respiratory gases. But in other group of cell, both in the epidermal cell, also in the collenchyma, sclerenchyma, even in the meristematic tissue, you can't find such a large intercellular space. Only the parenchyma contains the large intercellular space. Okay. Number 2, it contains the very large vacuole. You can see this transparent part is actually the vacuolar part, and due to the presence of this very large vacuole, the nucleus gets displaced at the periphery of the cell. You can see the nucleus, it is not present at the central position. It is getting displaced to the periphery of the cell, and the central position is contained by the large vacuole. And what is the importance of having such a large vacuole? What is the importance? Ki kore, what is the main purpose of the parenchymal cell? If any cell contains a very large vacuole, then what is the importance? Storage, yes, very good. It actually acts as the storage or acts as the reservoir. Very good, Somudra. It acts as the reservoir. And these vacuole actually contain the food molecules. Okay. So this, yes, very good, Mihika. It actually stores the food. Anish and Shukri, do you understand? Do you have any doubt? Somudra and Mihika continuously respond so that I can understand they are understood or বুঝতে পারছে আচ্ছা ঠিক আছে no problem. So if you have any doubt, you can ask me or write on the chat. Okay, I will repeat. So these large storage vacuoles actually contains the most of the food material. That's why the main function of the parenchyma is actually storaging and it providing the support or providing the structure, and it providing the stuff temporarily it provides the support. The main function is storaging. It stores all the food molecules, but the temporary function is providing the support. And in potato, the actually all the starch granules, these are all the starch granules. Okay, so these are starch granule is actually packed within this parenchymal cell. If you can see my cursor, you can understand. So this is not the parenchymal cell, this is the starch granule, and they are covered within this parenchymal cell. Okay, this is actually the small cells of the parenchyma that contains the starch granule, which is or the storing the starch molecule, and the mainly the potato that we have eat is actually made up of parenchymal cell. Besides this storaging function, it also performs other two functions. Parenchyma shows also other two functions. Number one is they contains large, as I have said, they contain very large intercellular space. Sometimes it contains very large air cavity. Okay, you can see this picture. It contains very large air cavity. Mostly it is found in the aquatic animal. Mostly these very large air cavity found in the aquatic plants. Sorry, I have I mean aquatic animal version. Now it is present in the aquatic plant, mainly in the leaf, in the stem of the aquatic plant. And what is the purpose of having such a large air cavity? It increases the buoyancy of the plant so that they can easily float on the surface. And this parenchyma that contains very large air cavity called the parenchyma. So those parenchyma having very large air cavity, this is the very large air cavity that helps in the floating of the plant. It provides the buoyancy of the plant, is called the parenchyma. Then another type of parenchyma is called the chlorenchyma. So can you tell me what is the main component of the chlorenchyma? So the parenchyma that contains, it is called as the chlorophyll. Very good. It contains the chlorophyll. If you see this picture, you can see this is the parenchymal cell with very thin cell wall, and it contains the chlorophyll. That's why it is greenish in color. So it is not only perform the food storaging purpose, but also helps in the photosynthesis process. It helps in the manufacture of the food. Okay, so most of the time parenchyma acts as the food storaging cell. But in case of chlorenchyma, those are mainly found in the leaf. Okay, in root we can't find the parenchyma. Sorry, we can't find these kind of chlorenchyma. In root, chlorenchyma is not found. In root, we can we can find the simple parenchyma that have the simple food storage purpose. But in this case of the leaf and the young stem, we can find this chlorenchyma that contains the chlorophyll, and through the photosynthesis process, it can manufacture the food, and it sometimes also acts as the storaging purpose. So this is done with the parenchyma. Okay, do you have any doubt? Then we will start to discuss about the pollenchyma. Do you have any doubt about this parenchyma? Okay, very good. So what happens in the pollenchyma? Pollenchyma is another supportive tissue which is made up of the living cells, and the cell wall is starting to be thick. It is not so much thin like the parenchymal cell. It is made up of long elongated cell, and it is a living cell, and the cell wall is thick, and there is no such intercellular space or very little intercellular space. In case of the parenchyma, those intercellular space was too large, but here the pollenchyma, the intercellular space is very little. Number 2, the cell wall is thick at the corner, and the in pollenchyma cell wall is thick at the corner. Yes, Mihika, you are right. I am just discussing about this. In this case, pollenchyma, the at the corner, you can see at the corner, the thick wall becomes much more thick and takes the black color. As it is staining, due to the staining, the cell wall is taken the black color. But in this case, the surrounding area is not so much thick, but the edge, but at the corner of the cell wall is much more thick. You can see this corner, the corner of the cell much more thick, and the main component of this cell wall is made up of cellulose and the pectin. In case of the parenchyma, it is made up of the only cellulose, but in case of the pollenchyma, it is made up of both the cellulose and the pectin, and the cell wall becomes thick at the corner of the cell. Number 3, we actually find, as I have said, they are permanent in their structure and they are permanent in their position. We can always find pollenchyma just beneath the epidermis. We can easily detect where the pollenchyma is located. If we see any microscopic picture, we can easily understand, okay, this is the epidermal layer. Just beneath this epidermal layer, this pollenchyma is found, and you can see that the cell wall is much more rigid, much more thick. But here, this is the large parenchyma, which is large, unspecialized, no such specific structure, and the cell wall is much more thick. You can see here the cell wall so much thick, but in parenchyma, the cell wall is much more thinner, and it is found in the veins and the petiole of the leaf. It is just the structural position where it is found beneath the epidermis. It is also found in the veins and the petioles of the leaf. And what is the main purpose of the pollenchyma? As parenchyma acts as the storaging function. The parenchyma helps to storage the food molecule, but the pollenchyma provides the support to the plant, and it provides the flexibility. That means if we try to bend the leaf, if we try to bend the twig, we can easily bend it, and still they are not broken. যদি আমরা কোনো লিফকে ধরে লিফের পাতাটা মোড়াই বা টুইগটায় চাপ দিই, তাহলে ওটা বেন্ড হচ্ছে, কিন্তু ওটা ব্রেক করছে না, ওটা ছিঁড়ে যাচ্ছে না বা ভেঙে যাচ্ছে না। দ্যাট ইজ ডিউ টু দ্য pollenchymal tissue, because this pollenchyma provide the rigidity plus also provide the flexibility. That's why it cannot be broken, but we can easily bend it. It is found within the leaf with the very weak stem. We can easily bend it. Okay, Everybody understand this parenchyma part? Okay. Now the last group of tissue, that is the sclerenchyma. And you have already said that it is a dead cell. That is, it is very hard group of cell, and we can easily we can't easily it is the most rigid part of the plant body, and it provides the maximum rigid structure. So what is sclerenchyma? Sclerenchyma is made up of dead cell, and it doesn't contain any intercellular space. You can see in parenchyma it has very large intercellular space. In collenchyma there is no such, the intercellular space becomes very little. But in case of sclerenchyma, neither intercellular space nor the intracellular space also decreasing due to this very thick cell wall. তো কি হচ্ছে, intercellular space তো totally absent, and also in some case the internal space of the cell এর ভিতরে যে স্পেসটা আছে, that is also packed due to this very thick cell wall. সেলের ভিতরের স্পেসটা is filled by this very rigid thick cell wall. And what is the main component? It is lignin. It contains the lignin. Due to the presence of the lignin, the cell wall of the sclerenchyma becomes much more thick, and it contains also cellulose, pectin also present, but the main factor is the lignin. Due to the presence of this lignin, there is internal space of the cell also decreased. Now the position, or where we can find the sclerenchyma, we can actually find the sclerenchyma in the stem, in the vascular bundle, or as I have said, the stem, the main structure is provided by this, the main rigid structure is provided by this sclerenchyma. It is present within the stem. And the vascular bundle, this vascular bundle is actually the xylem and the phloem tissue. So this xylem and phloem tissue is covered by this sclerenchymal tissue, and the veins of the leaves and the hard covering of the seeds and the nuts are also formed by this sclerenchyma. Those very hard part of the plant is actually formed by this sclerenchyma. It is dead tissue, and it provides the maximum rigidity and the support. This husk of the coconut, husk means this part, this husk of the coconut is actually made up of this husk of the coconut. This is the husk. Okay, this fibrous part is actually formed by this sclerenchymal tissue, because there are two types of sclerenchyma: fibrous sclerenchyma and the sclerite. Sclerite forming the stone cell, that is the maximum, the hard cell. In case of the hard walnut cell, you can see the walnut, those hard walnut cell is actually formed by this sclerite or the stone cell. Whereas this fibrous sclerenchyma, in fibrous sclerenchyma, this is it forms the ropes, the mats, all the fiber like structure is formed by this fibrous sclerenchyma. So here in this husk is also formed by this fibrous sclerenchyma. But the thick, very thick nut shell of the walnut, very thick walnut shell is actually formed by this stone cell or the sclerite. Okay. Somudra, I think you are disconnected. So I have just covered the what is the position of this sclerenchyma. So we can find this sclerenchyma in the vascular bundle. So this is the surrounding vascular bundle. We can find this sclerenchyma. Vascular bundle means the xylem and the vessels, and xylem and the phloem, and also found in the very hard cell of the nut, covering of the nut, and the covering of the seeds are actually formed of this sclerenchyma fiber. It provides the maximum support and rigidity. the husk of the coconut is actually formed by this fibrous sclerenchyma. It is a fiber-like structure. The ropes, mats, this can be formed due to this sclerenchyma. Whereas the very thick nut shell of the walnut is formed by the scleroid, which is the very, it is a stone-like heavy. It is a rigid like a stone. Okay. Now, so we have done with the all the two parts of the plant tissue, the mainly the meristematic tissue, that is the dividing group of cell. Only these group of cell can able to divide, and after the division it form a mass of cell that starts to mature and form the either simple permanent tissue, and from this simple permanent tissue it form the complex permanent tissue. So there are mainly the two types, protective and the supportive tissue. Protective tissue is epidermal, forming the outer layer of the plant, and the supportive tissue is the collenchyma, parenchyma, and the sclerenchyma. Among these, the sclerenchyma is the dead, but the remaining two is the living tissue. The parenchyma is providing the storaging function, but this collenchyma also provides supports, but the most important, it provides flexibility. But in case of sclerenchyma, it completely provides the rigidity and the most hard structure of the plant. Okay. So do you have any doubt? Then I will show the class piece. Do you understand? Do you have any doubt? Okay, very good, Mehika. And Anish and Samudro. Okay, now this is the class piece. Today you can give the answer on the app also, because today it is active. If you have finished, you can tell me, then I will change the question. Done. Anish, done? Okay. 4 and 5. Okay, Mihika, very good. Very good, Samudra. If you have completed the all 10 questions, you can submit on the app. Done, Anish? Okay, very good. Then I will start to explain the answer. Yes, question number 5, yes. Done? Everybody done? Very good. So do you have any doubt in this question? Do you get full marks? Doubt for 7. Question number 7. What are the types of supporting tissue? Supporting tissue means providing support. There are two types of permanent tissue. Supporting tissue. No. Two types of tissue, that is the supporting tissue and the protective tissue. If you can, the simple permanent tissue are mainly two types, supporting tissue and the protective tissue. Protective tissue forms this epidermis, but the supporting tissue mainly the parenchyma, florenchyma, sclerenchyma belongs to the supporting tissue, where the parenchyma major function is food storaging but provides temporary support. I have mentioned this. They provide the temporary support, but collenchyma it provides mechanical support as well as provide flexibility, and the sclerenchyma provides maximum support. Okay, Samudra. So all of these belongs to this supporting tissue. And Anish, do you have any doubt? Very good. Then I am explaining the answer. The group of cells with similar structure and function is the very simple tissue. And the types of plant tissue, mainly the two types, meristematic and the permanent tissue. So both of these, meristematic tissue where we can find both in the root and stem, tip of the stem, and also the lateral surface of the stem. So both of these tissue which are present in the growing part of the plant, mainly only the meristematic tissue. Growing part means dividing cells, so only found in the meristematic tissue. The tissues that are made up of non-dividing cells, so they are non-dividing cell, either permanently non-dividing or division temporarily stopped. So this is the permanent tissue. And which type of tissue found in leaf epidermis? Always all the epidermal cell should be protective tissue. That's why it is present on the outer surface. And then what are the supporting tissue? So all three, parenchyma, collenchyma, sclerenchyma, all are the supportive tissue. Which tissue is used for the food storage? Mainly the parenchyma. It only serves as the food storaging tissue. Then what are the components of the collenchyma? Both the pectin and cellulose, because cellulose is found only in the parenchyma. And what is true about this sclerenchyma? It is only the non-living tissue. It is only the dead tissue, because both the parenchyma, collenchyma, all are the living tissue. Okay, so do you have any doubt? Okay, Mihika, very good. And Anish, Somudro, do you understand the topic? Do you get the full marks? I think it is easy quite. In Okay, very good, Shomudra. You got the full marks. And in our next class, we will do both the plant tissue and the animal tissue. In case of plant tissue, we will cover the complex permanent tissue, mainly the xylem phloem, and the animal tissue. The first animal tissue, that is the epithelial tissue. Okay. Okay, thank you, class. We wait for the Moinak sir. Question solution files means class quiz part, or in weekly quiz there is question and solution is there, but in class quiz it will be shown on the during the class. That's why it is not shown on the app, I think. But if you have any doubt, you can take the screenshot also, then you can get the questions and the solution part. Okay. Moinaksh sir already has joined. Okay, okay. Thank you, class, and bye.
Clearly? So are you ready to start with? Can you remember what we have done in last class? In last class, I think we were dealing with graphs. What we were doing? Motion and graphs in last class. Yes, okay. Motion and right. I was also thinking about that. In the graphs, is there any questions or is there any problem that you want to ask or tell me anything before I start with the new part? Today we will be moving on to a new chapter. It's related to Newton's laws of motion and force. So before I start on, so anyone wants to tell anything about graph, slope, or anything, you can write or you can talk, whatever you want. Anything that you want to ask or share, or any difficulties that you face or you have faced in the answering, or anything from motion that you want to ask, anything from the nature of graph that you cannot understand or that I can show before we go on or move on? Okay. So Shukrit, Ornish, Meika, Lumira, Sumito, no questions, right? Okay. So I'm not getting any responses. That means there are no problems that I can assume now as far as this is concerned. So let's move on to the new part. So we will be moving on to this Newton's laws of motion. Of course, let me share my screen so that you can have a better view. So we will be going on to this. This is force laws of motion that we will be looking at. So this is the idea. So how do we actually go into the views of force and all that? The basic idea that at this level you develop is an external push or pull. But I want to describe it in a different way that is actually targeted from a larger aspect. Force is a push or pull. Obviously, push and pull is a kind of force. But how the forces are actually linked to several things. Force generally is linked with an interaction. Force is an interaction that can change the motion of an object, can cause an object to have a change in its shape, form, structure, state. Force can cause object with mass to change its velocity. That means force is the reason of acceleration. So that is the main idea how Newton started thinking some few centuries ago. When Newton started working on the idea of why the object changes its position and why actually we see the different views of the object changing its coordinate from one point to another point. So the prime idea came up with the change of position. There must be some reason. Whenever a particular position or whenever a particular object changes its position, there must be some reason when it changes. So when it changes its position, then comes the velocity part. With the change in position part in it, then comes velocity that we have studied in motion also. And whenever we see the change in velocity comes with time, we know now it's an acceleration. So the basic prime question of Newton's mechanics that we are dealing with is Newton's mechanics. Do you know there are several kinds of mechanics, and you are going on with only Newtonian mechanics? Anyone has any idea about this? Or you just know mechanics is only concerned with Newton's laws? What is your idea? All of you today in this class. 5 of you. Do you have any idea? Omnish, Mika, do you have anyone? Any idea about mechanics? Or non-Newtonian? Do you know anything like that? Do you even know that you are going to study Newtonian mechanics? Yes, Mika, I'm telling you, do you have, all of you, do you have any idea what type of mechanics you are entering? It's easy to answer. It's Newtonian mechanics. We will be studying onto the ideas of Newton's mechanics. Now, my question is there only Newtonian mechanics that we study on, or are there any different forms of mechanics? Do you know any other forms of mechanics or any other types of mechanics? Anyone? Someone says, I have no idea. Okay. And others, Mika, Ornish, you have got any idea about the other forms of mechanics also exist? We actually do have other forms and other variations and other types of mechanics. And this comes with the ideas like Lagrangian mechanics, one form, Hamiltonian mechanics, another form. You can have a mix of Lagrangian and Hamiltonian. We call it as kind of canonical system mechanics, Minkowski's form mechanics. So there are several forms. The prime of them are actually with classical mechanics. We come up with Newton's ideas, with Lagrange's ideas. What is the most advanced? Somebody is asking. The most advanced system is the Hamiltonian mechanics. It's from Hamilton. De-Alembert mechanics. There are three mechanics actually: Hamiltonian mechanics, De-Alembert principles comes up with Hamiltonian mechanics, and Lagrangian mechanics. So the Lagrange and the Hamiltonian mechanics is actually the most advanced form till now that we have. And the prime one is the Hamiltonian mechanics that we will not study in school level. We will be moving on to these parts of mechanics or the ideas of mechanics in collegiate courses. Either you go on to the BTech or you jump into the core ideas of the subjects then. Now these are actually forms of mechanics which deals with energy prime. Hamiltonian mechanics deals with total energy of a system. What we are going to talk about is about the ideas of force, not the energy right. So Newtonian mechanics and Hamiltonian mechanics and Lagrangian mechanics, they have a prime difference about. And we should understand why we should begin with the ideas of Newton's mechanics. Newton's mechanics is very easy to deal with, actually, and very hard to deal with also. So whenever it becomes a bit difficult to understand about the ideas like how do we go on or how do we feel on whenever we have many particle systems and whenever we have to calculate forces. So try to understand Newton's mechanics are very good enough when we have one particle, two particle, max to max three particle systems. But if you look at the natural designs, like you can consider the solar system, it's composed of, if you consider the sun and the planets, is composed of many particles, not three, it's more than three. In those situations, actually, Newton's mechanics becomes very hard. And we feel it's a hard way to solve equations for all the forces in the system. For example, you suppose try to find out the force of gravity for the sun and earth, it becomes easy. Now suppose try to find out the gravitational force between the sun and moon, sun and earth, sun and Mars, Mars and earth, Mars and moon, moon and sun, sun and Saturn, Saturn and Jupiter, Jupiter and Mars, Mars and Venus, Venus and earth. You understand the complexities? So it becomes very much complicated whenever we have large systems or systems having large number of particles. The Newtonian mechanics becomes very much complicated actually. So we need to understand the first part. That's why I shifted the idea. I have put a picture of that push and pull that you have learned from lower classes. But this is now a very new way of understanding force at this level, which is force is an interaction. We will always call force as an interaction. And remember, in case we are studying with the Newtonian mechanics, the interaction is concerned with the number of particles in the system actually. So how many particles do we have? If we have three particles, there will be three different force equations. If we have four particles, there will be four different force equations. So force equations actually come up with the number of particles we have. The number of force equations will be equal. If you have 10 particle system, it will be 10 number of equations that you have to solve. Do you have any idea, all of you, do you have any idea of simultaneous solving of linear equations? Mathematics? Simultaneous solving of linear equations. Can you, or have you gone through that idea of linear equations? Yes, Samudra is telling yes. Mika is telling yes. Yes, you should have done linear equations at this stage now. Now, tell me when it is easy to solve. If you have 10 linear equations to simultaneously solve or two linear equations to simultaneously solve? When it is easy. Two. Similar is the case for the Newtonian mechanics. Someone is telling you yes. Similar is the case for the Newtonian mechanics. When we have two particles, it's very easy. We have only two forces to deal with, or even one force to deal with. Only the action force, because the reaction becomes equal and opposite according to Newton's laws. So when we have a three particle system, we actually have three forces to deal with. When we have four particle systems, now the number of forces actually increase, and as they increase, now you just replace the ideas with the simultaneous linear solving, simultaneous equation solving idea. So you can have some 6 equations to solve, some 10 equations to solve, so with 5 particle systems. So these things actually come up with the ideas of getting hard, how the Newton's equations gets hard or mechanics gets hard. So then we jump on to the higher systems, which is much easy, to Lagrangian and Hamiltonian forms. Not really much easy, but a different form, because it doesn't deals with the idea of force. Now force has a problem because it's a vector quantity, so we must consider every time the direction element. Vector is a physical quantity description where we consider the direction and magnitude too. If we jump onto the energetic mechanics, we don't have to relate or concern or think about the direction. It becomes simply the value. So that makes us a bit easy. And these interaction studies becomes easier. But then again, question comes, so why should we study Newtonian mechanics at the school level? Because it is one of the most prime ideas of Newton, which actually kicked out everyone to think about different ideas of motion, dynamics, kinetics, kinematics, their reasons, the energies, and all these things. So the prime source is Newton. So we are going with the Newton's ideas. Next, you can see force can also be described intuitively as a push or pull. That is our part that we have studied. And the part next which comes is force has both magnitude and direction, making it a vector. Last two things you actually know, all of you. And the first one is actually a case which you don't know. Force is an interaction. Now to describe why or how it is interaction, let me choose. Let me choose a type of diagrams that I can make you. Suppose there are two particles. Sujita is there. Okay, good evening, Sujita. Can you listen to me? Okay. Sujita, am I audible? Can you follow the class? Can you see the slide? So let's see and move on to the idea of the interaction. Suppose there are two particles. Suppose there are two particles. These two particles will exert force on each other. They will exert force on each other. Can you see the annotations on the screen? I was having a network issue, Sujita. Yes, actually, Sujita, we haven't moved forward much. So you haven't missed really. What we were talking about is the idea of the force that you can see in the screen, the points. And we are just starting with this chapter, new one. And we were talking about what type of mechanics we should study in this chapter. It's Newtonian mechanics formed by the famous Newton, Isaac Newton, Sir Isaac Newton, has formed the ideas of force, the ideas of motion, acceleration, and all these things. And we were talking about there are other mechanics called Hamiltonian and Lagrangian mechanics, which we will not study at the school level, but it will come with the higher ideas like collegiate levels. What are the differences? We were talking about these points. What are the differences? Force or the Newtonian mechanics deals with the vector quantity, and other mechanics deals with energy or the scalar quantity. So that was the prime thing that we were discussing. And in case of Newtonian mechanics, we came up with a different idea from the push-pull that you can see. I have put the push-pull idea on the second point that you already know. The first point comes with the idea of interaction. All of you, I think you can see and follow my annotations on the screen. I hope annotations are visible. So interactions, we all are focusing at this level with the idea of interaction. What is actually interaction? So anything which can be thought of as an interaction can change the motion of an object, can cause an object with some mass to change its velocity and accelerate, and all these classes. So actually with these ideas, we can form many and many different ideas. So let me show you something. Like if you can see my annotations, the interaction between any two particles, suppose, is now drawn with a line. So what can you think of the number of interactions that can be possible with 4 particles that you can see on the screen and 5 particles that you can see on the screen? Just take out a copy and pen. Can you calculate the number of interactions? The number of interactions will be similar to the number of lines or the connections between the particles. So can anyone tell me the number of interactions in case of 3 particles, 4 particles, and 5 particles? So many of you are there. Anyone? Any idea about this? Can anyone tell? Mika is telling 3 particles are having 3 interactions. Yes. Now let's Mika go up with 4. You are right, with 3, 4 and 5. Can you tell me how many number of interactions? Interactions will be the number of lines. How many number of interactions can be present in 4 and 5 particle systems? Mika, Rumela is answering 4 is having 4, 5 is having 5. I think Rumela, Mika, you both need to have recheck now. 4 particles are not really having 4 interactions, more than 4, and 5 is having more than 5. Can you recheck again? All of you, Rumela, Mika, Shinjita, Ornesh, Somudru, Sukrit. Samudra is telling 4 is having 6. Very good, Samudra. 4 is having 6 interactions actually. Mika, Rumela, can you see there are 6 interactions in 4 particle system? Five is having 10, Samudra. Very good. 5 is having 10 number of interactions. All of us, Mika, Rumela, can you find it out? Okay, let me draw the number of interactions now. This is for the 3 particle system. Samudra is telling yes, Samudra. Very good. A series formula comes up with this idea. So Samudra, you had this idea of the series, or you just find it out right now? Just now found, or you had this idea? Formula for number of diamonds. Yes, it is actually. Okay, you had this idea. Fine, very good. So this is actually the way we can connect. My lines are getting crumpled. They should not be. They should be straight. I'm just drawing it out. So they're looking crumpled. Can you now count number 6, number 10, these ideas, all of you? Can you see 2 particle systems are having only a simple interaction? 3 particle with 3 particles. Now the interaction gets a bit different, and total number of lines are equivalent to number of interactions. If we see 4 particle and 5 particle, so suppose I think if you have some 100 number of particles, can you think where the thing is going? So is it very hard to deal with hundreds and thousands of number of particles through Newtonian mechanics? If I speak about the interaction idea, what do you see? Will that be very hard? Or will it be easy then? Very much easy. Which one? Which one you vote for? Easy or hard? With hundreds and thousands of numbers of particles. It's very difficult. So those 10. Yes, it is indeed very difficult to deal with hundreds and thousands of equations, because for each interaction we get one equation in Newton's mechanics. Now tell me, in natural systems like in materials where we have compounds, the number of molecules, the number of atoms, what do you think? How many atoms may be present? 1 or 2 atoms in a large compound system, or very large number of atoms? What do you say? In 1 gram of a substance, what can be the number of atoms? Just 1 or 2 or 3 atoms? Or it can be much more than that? What do you say? Do you have any idea, or have you ever heard of Avogadro's number in chemistry? Avogadro's number? Someone is telling yes. So, can you remember Avogadro's number? What was the number, Avogadro's number? So, Avogadro's number comes up 6 is immaterial actually. If anyone knows about the Avogadro's number, he or she knows that it comes with 10 to the power 23. 6.022 or 6.023 or 6.234 or whatever 6 point dot dot dot. That is immaterial. The main part is the 10 to the power 23. Can you have any idea of 10 to the power 23 number of particles? So if you have 10 to the power 23 number of particles, so do you understand 4 number of particles comes with 4 equations? Yes, so 1 mole of a substance gives with the Avogadro's idea. Others, Rumela, Srijita, do you all have others in the class? Do you have this idea of Avogadro's idea? In chemistry, have you heard of this idea? 1 mole of a substance comes with Avogadro's number of particles. Okay, Srijita is telling no, sir. Okay, so actually 1 mole of a substance, chemically, okay, Mika is telling not her, sir. Dubla is telling no, sir. Okay. So in chemistry, when you grow up, actually you will learn that 1 mole of a substance can always be compared. 1 mole means which gives you an idea of the weight of the substance or the mass of the substance. You can tell also, like 1 gram of a substance, generally say 12 grams of a substance, which are generally the measuring units that we generally have in our lifetime. Easy units. So if you want to suppose, if you want to find 1 gram of carbon dioxide gas, so how many number of particles will actually be there? Now these particles are like atoms and molecules. So the idea comes that whenever you want to convert the number of particle systems with the weight of the gram atomic weight and gram molecular weight, we call it in chemistry and physics also. So we try to convert the number of particles, and it comes with the Avogadro number of concept. So the Avogadro number concept comes and it tells that at least in 1 mole of a substance we can have some 6 point dot dot dot. I'm not going to the specific details, but the idea is 6.10 to the power 23. Can you believe 10 to the power 23? 10 to the power 23 is a very large number of collection of numbers. The number of particles are very large in that case. So now what to do with 10 to the power 23 number of particles and their equations? It will be very hard then by the Newton's laws that we can solve these molecules and molecular motions, atomic motions. So in the higher class, we actually shift on to the different forms of mechanics. But this has its own importance. Now, where actually the Newton's mechanics comes with the importance, let's move on to the idea of the next slide that I was going to. So these are the first view of the Newton's laws. This is the first law, second law, and the third law. The first law, you see, an object will maintain its state of rest or motion until and unless it is acted upon by an outside force. So suppose wherever an elephant is, it always remains there until and until it is acted upon some external force. This is known as the law of inertia. We will come into details. Second law is actually the net force idea. So net force is equal to the rate of change of this idea of position and acceleration and momentum. So net force comes with the ideas of momentum. You can tell momentum is actually the measure of mass content in a system. We will come to this. Momentum is actually expressed here as a small p notation. I think momentum. The momentum comes with the idea with a small p notation, and it is a vector quantity, and the vector idea is put on by the arrow overlay. So whenever we see an arrow over a quantity, that indicates is a vector. So small p vector, it indicates about the momentum, and it is mass into velocity. And what is actually momentum? Momentum is actually what we can tell about the momentum is actually the measure of you can tell measure of motion contained. Okay, it's measure of motion contained in a system. You can always tell this idea. So if you want to measure out the amount of motion present in a system, you have to measure the momentum, and momentum's formula is mass into velocity. So you have to find out the mass of the system. You need to find out the velocity of the system. Take a product of them, mass into velocity. It will become momentum. And the SI unit is actually from mass, which is kg, and from velocity, which is meter per second. So it gets on to kg meters per second. So that's the unit of momentum. So second law is all about momentum and force. What is that? Net force is equal to the rate of change of linear momentum and causes acceleration. Now, why the linear? Because momentum can be in terms of circular motion. It can be angular also. When something rotates, so it creates angular momentum. So thus, it's a straight part idea in this simple form. So it's a linear momentum. So causes acceleration. You need to know that momentum change in a system causes acceleration. Whenever there is a change in the motion content in a system, it produces or indicates about an acceleration. And the third law, the action force on an object creates an equal and opposite reaction, equal and opposite amount of reaction to the other object. So remember, for the third law, we just need two different objects. One object acts on other object. Like for example, in case of a third law, if you are trying to punch a wall with your hands, you can have a severe pain in your hands because of the action done by your hand to the wall gives you equal and opposite reaction of the same amount. So the much higher is the force of punch, the much higher is the chance of getting a high crack in your bones or your hand gets a damage. So that's the third law. So let's move on to the laws in details. Today we will not be looking onto the third law. We will be looking onto the first law in detail now. First law, the law of inertia. An object will maintain its state of rest or motion unless acted upon by an outside force, or the law of inertia. So what is actually inertia? Inertia is a physical property, and it indicates about the idea of measure of mass in a system. Measure of mass in a system. So if we can actually measure the mass of a system, that is actually the inertia of the system. That measure is the inertia. So more is the mass, more is the inertia. So higher is the mass, higher the mass, higher is the inertia. higher is the inertia. Now to understand this, let's take some funny examples like an elephant is having more inertia than a man who is having less inertia. Why? Inertia and mass are directly related. Like inertia is directly related to the mass of an object. An object like 75 grams, what we have here, 75, grams, not grams, really, sorry, 75 kg. So an object of 75 kg, possibly the average weight of a person, we can take 75 kg human, has much less inertia than an elephant, which approximately has this type of idea of 3500 kg. So it takes a lot of force actually to displace the elephant. This is the first law of inertia. The system which are having larger inertia, we will have to apply larger forces to them to displace. So things which are of light in weight and mass. I'm not pulling into weight, okay. Low in mass, they have low inertia, and thus we have a little amount of force which can displace it. So apply a small amount of force to a larger mass object or a larger object having more inertia, the force will not be able to displace. Like here, you can see a funny picture of a man trying to run across the elephant. So when the man hits the elephant, the man falls down. This is because simply the man is not able to create a force which can move the elephant, which is having a larger inertia. So the first law tells, now again, go back, an object will maintain its state of rest or motion unless and until acted upon some by external force. And this external force now is related to the inertia. More is the inertia, so more we need the force or the amount of force to create a motion in the system. This is Newton's first law of motion again in detail. Inertia is a physical property. Inertia is defined as the measure of mass contained in a system. It is an object's tendency, you can say, maintain its state of rest or motion, and this occurs unless acted upon by an outside force. So Newton's first law of motion always deals with the law of inertia. We call it the law of inertia, and inertia comes with a sense of physical property. Inertia is defined as the measure of mass contained in a system. It is an object's tendency actually to maintain its state of rest or motion. Like the elephant here, generally the man is not able to move the elephant with a push. Why? Because the elephant is having high inertia. It's not possible to quickly move the elephant, and this occurs unless acted upon by an outside force. So how much, for how much or how long the elephant tries to remain in its own state of motion or rest? The answer is until and unless it is acted upon by some external force. So any questions about this idea of first law and inertia? Anyone? Before we jump on to some different idea that you can see, I have given a clip. So any questions you want to ask anyone? You want to ask any questions regarding the law of inertia, the meaning of inertia, the ideas of force, idea of force now in a different sense, interaction, picture. So any idea or any questions that you want to ask? You have never got it, or you got a difficulty, whatever you think. বলো, কারোর কোনো সমস্যা আছে, কোনো প্রবলেম হচ্ছে বুঝতে, কোনো কিছুতে? You face any problem? Okay, Meena. Sita is also telling you. Right. So let's move on to a different idea. Okay, now this is very much new and this is interesting. So be concentrated and be focused. Let's move on to a different slide now. This is known as equilibrium, static and dynamic equilibrium. So equilibrium actually comes with different ideas, and equilibrium comes with different ideas. Means it actually goes with the ideas of dynamic and statics. So first of all, let's come with the thing that equilibrium. What actually equilibrium means? If we break down it into our Bengali term, আমাদের মাতৃভাষায় যদি আমরা কথা বলি তাহলে আমরা বলবো সমান অবস্থা, বা বাংলায় আরো ভালো কথা বলা হয় সাম্যাবস্থা, সমান অবস্থা। When we have similar states in two systems, that's an equilibrium. Like very easy idea of equilibrium is to understand about say you can think of thermal equilibrium. When two bodies, one hot and one cold, comes in contact to each other, we know heat starts flowing from the hot body to the cold body. Now, there will be a time when the two bodies will be at a similar temperature. The cold body will a bit rise in its temperature and the hot body will come down to a temperature. Suppose a 20-degree centigrade and a 40-degree centigrade. If we mix up these two objects, suppose there may be a point called 30 degrees Celsius temperature where both of the bodies now come and they keep or they remain there. So that's the idea of equilibrium. One more way to understand about the equilibrium is a simple idea about equilibrium. Suppose, have you seen something like an hemispherical bowl? Somebody is asking, sir, they have equal amount of heat energies. No, not really. Heat, when you are telling about heat, we consider potential and kinetic both. When we call about thermal equilibrium, it deals only with temperature, so only with kinetic energy of the heat. Heat means total, there are several forms of energies. So heat means a potential energy, it means a kinetic energy, both. But temperature only means kinetic energy. Thermal equilibrium deals only with the ideas of kinetic energy. So in sense of that, not the equal amount of heat energies. We can always refer to that. The heat energies are different in that situation. Sure. Just a minute. I'm trying to actually annotate. Can anyone see my annotations? Okay, let me check. Let me check. Yes, I'm trying to. Something is happening. Wait. No. No. Yes, now is it visible? Can you see a hemispherical bowl that I've drawn? Have you seen something like this? কি আমরা বাড়িতে অনেক সময় আমাদের কাছে বাটি থাকে না, এখানে আমরা অনেক কিছু খাই। So have you seen something of this shape? So try to place a ball at this point in this figure. Yes. So what happens if you release the ball here? The ball will start to flow from this point. It will try to swing actually about this ball. Okay, and if you keep it in this way, it will try to come down and settle down at a point like this. Yes, sir. Samudra is telling like a pendulum. Yes, it will act like a pendulum. So the ball will actually swing from one end to another end, and from that one end to another end, it will ultimately come down to a point where it stops. So where anything after a certain natural motion, anything stops automatically without an external event. So that is a situation of equilibrium, and an equilibrium situation always links with the idea of balance of the forces. So this is actually the idea of the equilibrium that you can see here. Now, there is another way to understand the idea of equilibrium here. Suppose I just now invert this bowl. So if I now invert this bowl in this way, just a minute. Just sorry, I got a miss part and a miss diagram. Don't worry for this. What I want you to understand is about, say, suppose I keep a particle like this. Now the bowl is inverted, okay? With the bowl inverted now, so what will happen? If you try to disturb the small ball from this position, what will happen? And if you try to disturb this small ball from this position after it comes to this, try to understand. In the first case, if you try to disturb the small ball from its position, maybe that it starts to oscillate and comes down again to that position. But in the second case, if you try to disturb the ball in any of the way, will the small ball come again to that position, or will it fall down? Will it fall down? What to say? Will it come back, or will it fall down in the second case? Any ideas? If you don't have any idea, take a bowl. বাড়িতে এরকম গোল বাটি আছে তো, সেই বাটির মধ্যে একটা কড়াইশুটির দানা নিয়ে উপরে ছেড়ে দিন, ছেড়ে দিয়ে ওটাকে একটু আস্তে ওটাকে একটু ডিস্টার্ব করুন, দেখি তো কি হয়। So what will happen? So it will fall down and it will never come back. So that shows another equilibrium position, but which is known as not stable. It's unstable. It's not stable. So equilibrium comes out with the ideas where the forces are actually get balanced. So equilibrium. So what we now call about the ideas of equilibrium is we can always have these ideas where to state for is to go with the ideas like equilibrium comes always with balanced forces. Balanced force ideas. So in case of any equilibrium, we can always have a balanced force. Whenever we see the equilibrium, we get a balanced force actually. So in case of static equilibrium now, in case of dynamic equilibrium now, there are two cases actually. One is static, one is dynamic. So in case of a static equilibrium, we see the picture here depicts the ideas of static equilibrium. You see, in case of static equilibrium, we see the state of rest. Static equilibrium is a state of being at rest with no net force. And in case of dynamic equilibrium, you see the picture, there are cars moving on the road, funny pictures of cars moving on the road. But you see, one car is behind the other car, and that in row behind the other. So now the cars are moving a constant motion, and they are not colliding with each other. So this can be an example of dynamic equilibrium. They are moving, but they are moving a constant difference between them. So you can see these things are means from one car to another car. If you observe, the person in the other car appears to be at rest. If you don't see the ground, if you don't see the background, so it appears like if you are moving in a car, anything or anyone who is moving beside you with another car, if that another car is under the dynamic equilibrium idea, so that person in the another car may appear to be static. You are moving in a car and another person drives side beside you, and now the two persons are means going with the same speed, or same acceleration or same velocity? Yes, Somodhu is telling yes. So that can be a situation of dynamic equilibrium, where we see the two persons are moving with same velocity or same acceleration, but if you don't see or don't look at into the backgrounds, they appear to be similar. They appear to be very much in state of rest with each other. You can't differentiate that we are actually moving or not. It appears that we are not moving. You have a feel like that. So that's the thing. So static and dynamic equilibrium, why we are introducing these two things, because they come up with the ideas of force and all these contents. So this is the first part that you can see also. We have a car and the inertia idea. If you are driving the car, your body and the car are in similar motion. So that's a dynamic equilibrium. So the velocity of the body and the velocity of the car components are equal. Now, if you suddenly try to stop the car, your head may hit the windshield or steering or any of the parts. Why this happens? Because with the car, your lower part of the body, the legs and thighs, they try to stop as the car tries to stop. But the head or the upper portion of the body tries to maintain the state of motion as it was going on. So this is a good example of inertia where we see we suddenly fall like this, or when the car starts, we go back. So that's a good example of inertia, which says that inertia can be related with state of rest and state of motion. So we can have inertia of rest, inertia of motion, both. Inertia of rest means when the object is at rest. Inertia of motion means when the object is at motion. From both the views, it is difficult to change the position and ideas of position. So now you can have an idea of this. No force is required to get an object to move if it is already moved. A force is required to change an object's state of motion only, or that can be a state of motion or rest. So now you see there are two situations where the inertia keeps a moving object moving in the first picture, in the top picture that you can see. The inertia keeps the object moving on the top, and on the bottom you see now the frictional force, which is not inertia, stops the motion. The body slows down. You can see clearly the difference. You can see clearly the difference. You see the body has reached into a point here. So the body was moving in this direction. It kept moving. But this body was also moving in a medium having friction. Now this body's position has now, see, it has gone far back. So this is not inertia. This is some external force. It is acting in opposite direction to the motion and keeping it slow. So that's friction. So any questions about this? Do you feel any difficulty about inertia and ideas? Okay, let's move on to then next ideas. This is actually the second law. This is pretty easy, and we just have a formula mathematically to calculate the net force in the system. Net means here the sum of the forces or the algebraic sum of forces, total forces in the system. That's simply F net equals to mass into acceleration. You know acceleration? How do we have learned acceleration to calculate? Acceleration always comes with the change in velocity, v minus u by t. This is v minus u, where v is the final velocity, u is the initial velocity. We can also call it delta v by delta t, where delta v implies the change in velocity and delta t comes as the change in time. So Newton's laws of motion always are related to the acceleration. And you see the net force on an object causes it to accelerate in the direction of the net force, always in the direction of the net force applied. Remember that force is a vector, so having a magnitude and direction, and so the acceleration becomes a vector now. So what can be the possible units of force? Generally, we bring mass with kg, acceleration with meter per second square. The force, which comes as 1 Newton, is actually the amount of force which produces an acceleration of 1 meter per second square in a body of 1 kg. So 1 Newton is the force required to accelerate a 1 kg object with the idea of 1 meter per second square. So kg meter per second square. So 1 Newton is simply 1 kg per meter. 1 Newton simply can be as 1 kg what is happening today is something. 1 kg meter per second square. Getting difficulties with my annotations today. So 1 Newton becomes 1 kg meter per second square. So this is the unit of force. This is simple. This is deriving a Newton. How to derive the Newton? This is the basic idea. This is Newton. This is the kg, 1 kg, the meter per second square. So this becomes the mass and this becomes the acceleration. So F becomes equals to ma in the second equation. The first and second equations can now be understood in terms of momentum. See, we can see there is a plane, aircraft, a flying aircraft. So a force is there. With this force, the aircraft is moving from right towards the left. So you can see the changes in position and velocities. Changes in position as x0, then it becomes x1. The velocities becomes v0 to v1, time becomes t0 to t1. So from going from right to left, the flight or the aircraft actually moves. Now the force is also expressed as a change in momentum with change in time. Means force, we can also express this as force is change in momentum by change in time. But now momentum we learned is change in mass into velocity divided by change in time. Now remember, mass in Newtonian mechanics never changes. According to Newton's ideas, mass remains constant of motion. Mass never changes when anything moves. When anything changes its position. So mass is not having the change. This small thing, sine delta, this small triangular sign is known as delta. Delta, this is known as delta. It's a Greek symbol and indicates a small change, a small change. So whenever we actually get a small change, we can physically write this symbol. So everyone will understand that this is a very small change. So we can actually write now m delta v. Why? Because the mass will not change. The mass will not change. And this is the part. This delta v by t, we got into the previous slide. Delta v by t, you see, is acceleration. So you can ultimately derive this into as mass into acceleration as the force. So anyone has a question? This same thing has been described. What I have written here is the you see in this idea of what you can see here is the change in momentum. So this is the final momentum. You can see m1 v1, and this is the initial momentum you can put as m0 v0. So m1 v1 minus m0 v0. So now is becoming t1 minus t0. Okay. So this is the change in momentum, and this is the change in velocity and change in time, which actually puts onto the acceleration and change in momentum. So force can always be expressed as change in momentum or mass into acceleration idea. That's the catch. So force now can always be expressed in terms of velocity, acceleration, momentum, all these ideas. So it's a quantity, vector quantity. Momentum is also a vector quantity. Now see, these are the diagrams actually what we actually relate. This is the body when a man tries to push a body. So this can be the forces. On the right side, the action force, the push force. On the downward is the FW, which is the weight of the body. On top of the body is actually called the Newton's reaction force or the normal reaction force. And there can be a resistance towards the motion, which is acting opposite to the applied force Fa, the black one. So this is the friction. Why I have chosen this diagram? Because you can always choose without the body. You can always choose the forces acting in the system like this. This is the picture you see. There is no body now, only the forces left with the directions. So these diagrams are easy to make and easy to solve in case of problems. We will be coming on to problems in the upcoming classes where these diagrams are necessary. So this is known as a force diagram and a free body diagram. You see, there is no body in this diagram. There can be no bodies even when there are much higher number of bodies, 2 or 3. So drawing only the forces and its directions without the body is known as the free body diagram. So this is a tip from this part we will always carry on. So weight is actually the force with which earth attracts any object towards its center, and weight is actually a force. Weight is m into g, mass into acceleration due to gravity. Acceleration due to gravity is the acceleration g, small g. We can always write w as mg, where g is acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity, and acceleration due to gravity then can become the value. We can take a value of 9.81 meter per second square, and approximately we can write it as 10 meter per second square generally. So this gives you the idea of the weight, another kind of force. This we will explore actually. I'm not going into the deeper aspect. So just remember the force diagram. Remember what we have done as F equal to ma, what we have done as F equals to del V del T, or change in momentum. The idea of inertia, static equilibrium will come into play. So this was our class today. So let's move on to some of the questions from this class today. Let me share you a screen of questions quickly. These are simple and easy questions. Let me stop this and let me go back to this side. Here, can you answer these questions? Acha. I have not put these questions right now there in app, so don't rush. You can always answer these questions in app whenever you get a time. You can take a screenshot of these questions, or you can try now. So whatever is means, I will always tell you, let me see what you are trying about. Can you tell me the first question? An astronaut with all her equipment has a mass of 95 kgs. So how much will be the weight on the moon where the acceleration due to gravity is this? So we know the weight is mg. So m is given and g is 1.67. So 1.67, you can quickly take a hint. 1.67 quickly take a hint. 1.67 becomes 5/3. Shabadu is telling approx. Okay, good, very good. So if you can now go to the next question. 1.67 for faster calculations, take 5/3. So you can now calculate g as 5/3 and 95 into 5/3. That can give you the idea. For the next question, you see the two forces are given. What is the resultant force? The resultant force means you just need to sum up. Like one force is going in this way, one force is going in this way. This is the 200, this is the 300. So how to calculate? You just take out the difference or the sum. So try to grab the idea that it is acting in the same direction. So remember, when the forces are acting in the same direction, yes, very good. When they are going in the same direction, they must be added. When they are going in the opposite direction, they must be subtracted. So if they are going in the same direction, they must be added. So here we get an addition in the same direction, and in the opposite we get a repulsion. Oh, sorry, subtraction. So it goes up now. Like in the third question, what will be the change in acceleration of a sliding brick if its mass is doubled while a constant force is acting on it? Acceleration will be, the brick is sliding along a road, suppose. Now the force is remaining constant, the mass is doubled, and the acceleration, very good. So the idea of this is F equals to ma. So it goes on to like F equals to ma, what we see in this. So F equals to ma becomes F constant. So if the mass is doubled, now suppose your new force is now F only because F is remaining same, but this is getting 2m already. So if you write 2ma, it will never come as ma. So you have to divide the acceleration by 2, then only it gets to ma. Have you got which one is the option? All of you. So we can always get on to 4 as a car of mass 1000 kg produces an acceleration of this is meter per second square. Huh? Okay. So m into a, very good, Samudra. So this is 1000 is mass, a is acceleration. So simply mass into acceleration becomes this one, option C. No other options are coming as 1000 into 8. So you can take simply 8 into 1 and all of the zeros are intact. Srijita, are you getting my questions? Honest, Shukrit, are you getting my questions? Are you all there and getting my questions here? So that you can answer this type of questions whenever you are free. You can answer these questions in app. Not right now. Just look into the questions. Are they okay with you? Shobodor, can you answer? And all of you, can you answer this 5, 6, 7, and all these things? I've got one answer again. Yes. Okay. Very good. In case of again number 5, we have mass as 4 kg, and find the force exerted on the ground due to acceleration due to gravity. This is 10 meter per second square. Okay, the squares are got distorted. So this is 40 actually. 6, 7, 8. You can come up with this. Yes, 6 is increase, right? Okay, this is option A, B, C, and D. Okay. This is option D. And what can be the possible answer for 8? A flying jet plane that we have seen a picture gets reaction from gravity, atmosphere, gravity and atmosphere, gases ejected from behind. What is Sita is 8A. A flying jet plane gets a reaction from, you're close enough, not really from gravity, but somewhere if it is in the atmosphere, it gets the reaction from the ejected gas. But when it goes to the outer space, it actually uses gravity. So ejected gas, this idea comes within the atmosphere. When the craft goes outside the atmosphere to the space, then it is actually the gravity. So in a way, Srijita is also correct. Yes, last 2 options. Okay, I'm just rolling up. Okay, so now again, the very easy question in 9 and 10, can you answer? Mass of 2 kg, which is getting accelerated, and a force, which is actually. So what can you answer about 9 and 10? Let me see. The mass of 2 kg is accelerated at 2 meter per second square. Again, Peter is telling yes. 10 is yes. 10 is C. Both push and pull. Very good. And a mass of 2 kg is accelerated in 2. So I think this is again a simple. It's mass into acceleration. In 9, force equals to mass into acceleration. So it becomes 2 kg into acceleration 2 meter per second square. So it goes on to 4 Newton. So I think this was not so hard. It was just a beginning. So it was just an idea of how numericals can come to us. We will see much more typical numericals. Okay. So now, do you have any class? Any more class right now? I'm stopping this here. Okay. Chemistry. Okay. Okay. So you take a break. Chemistry, ma'am will come, I think. Or sir will come. You take a break. You can go back and take a break of 5-6 minutes because I think from 50, then 7:50 it will say, oh, okay, already I've taken much time. Sorry, 7:47 already. Okay. So I'm leaving. Okay. We will meet in next class again.
Hello, can you hear me? Hello? Okay, okay. Okay, so we are going to talk about water. So as in the previous class, we already discussed about the some of the unique properties of the water itself. Like we talked about the anomalous expansion, we talked about the universal solvent nature of the water itself. So today we are also going to discuss about some of the reaction parameters in case of water. So firstly, I can say that water, when it is in pure state, like we can say about the rainwater, because rainwater is present in the pure form. So whenever we are talking about the pure form of the water, we can simply say that it is neutral to the litmus. So what is litmus paper? Litmus paper is going to find out the pH. Okay, so litmus paper is actually going to change its color according to the pH condition, according to the acidic or basic condition. So in case of here, in case of the pure water itself, the litmus paper is not going to change its color. So that is the first thing we can say. Okay, now in case of some of the reactions, water can also act as catalyst in the pure state. So whenever the water is present in the pure state, it can act as catalyst in case of hydrogen chloride formation. So simply the hydrogen and chlorine is going to be means they are going to combine with each other in the presence of moisture, and moisture is acting as the catalyst, and they are forming the, obviously they are forming HCl. Another, in case of the combustion of white phosphorus. So whenever we are used to put the fire, in case of the phosphorus itself, the phosphorus is going to make phosphorus pentoxide. So we can simply, again, the moisture over here is actually acting as the catalyst. So we can say that white phosphorus is going to convert into phosphorus pentoxide, and moisture is acting as a catalyst over there. So what is happening? The four means normally the phosphorus, that is P, is going to interact with oxygen, that is O2, and finally they're forming P2O5. That is phosphorus pentoxide, and obviously then we are going for the balancing of this particular reaction. So now after this, we are coming to this particular section, that is the reactions of metals with the water itself. So first we are having the magnesium over here. So in case of magnesium, what is happening? Obviously, the magnesium is going to sink in the water and it reacts in cold water. So it reacts with cold water and normally produce the hydrogen very slowly. So they are going to produce the hydrogen in a very slow manner. So that is the first thing. And obviously, if I am going to provide the solution of magnesium hydroxide, then this is going to formed with the help of obviously the reaction of magnesium and water. So simply the magnesium and water is going to interact with each other and they are forming the magnesium hydroxide. And obviously this reaction is vigorous. So after this, we can simply go for the potassium. So potassium normally floats on water. So that is the first thing. Obviously, it floats on water. And then we can say that obviously it is also going to react with cold water. Okay. And whenever we are putting the potassium in the cold water, normally it bursts into flame vigorously. And now what is happening? Obviously, the hydrogen gas is started to evolve. They are coming through the bubble form. And finally, a clear solution of potassium hydroxide has been obtained. So obviously K plus H2, that means we are going to obtain the KOH, that is the potassium hydroxide solution. After this, we are talking about iron. So iron obviously sinks in water and it normally going to react with steam. And whenever iron is going to react with steam, they again produce the hydrogen gas, or they used to evolve the hydrogen gas. Now, after this, now we are having the second part where we are also talking about some other particular metals. So here we are having calcium, copper, and sodium. Sodium we already talked about. So we are actually going to concentrate in case of this particular calcium and the sodium one. Sorry, copper one. So in case of calcium, we can say that what is happening, calcium also sinks in cold water. And they also used to produce the hydrogen gas, and they are forming the solution of calcium hydroxide. So obviously Ca plus H2O, then obviously CaOH whole 2 is going to be produced. So calcium hydroxide solution has been produced and hydrogen gas has been evolved. After this, if we are talking about the copper, then obviously copper sinks in the water. And copper normally does not react with water or steam. So in both the conditions, the copper is not going to interact with this particular water itself. Fine. Now, after this, we are going to the next part, and here we are having some of the metals. Like we are having potassium, sodium, calcium, magnesium, all. So this all we already talked about. Now, if I'm going to talk about aluminium, then aluminium, I can say this much to you in case of aluminium, that aluminium does not react with boiling water or cold water. Okay, so what is happening? They are not going to interact, and normally whenever the aluminium is going to interact with the particular water itself, a compact coating has been formed. And that coating is of aluminium oxide, that is Al2O3. Okay, so a particular compact coating of Al2O3 has been formed, and that is why this metal is going to rendered as inactive one. And if we want to break this particular coating, then this particular coating can be broken down at high temperature, and that is why the aluminium can react with steam. Because obviously steam is present at high temperature, so that is why that high temperature is going to break this particular coating, and then obviously the hydrogen has been liberated. So in steam condition, you can write that yes, aluminium is going to interact with water, that is Al plus H2O, and finally the aluminium oxide, that is Al2O3, has been formed. That is the first condition. Okay, so that is in the condition of the first one, and this Al2O3 compound is going to be broken down in the presence of high temperature. And at that state, obviously, they are going to interact, and the hydrogen gas has been liberated. So this is in case of aluminium. Now, if we are talking about the zinc and iron one, then in case of zinc one, what is happening? The zinc is also interact with steam. And the zinc should present in red hot state. So the zinc should be in red hot state and it will interact with the steam. And what it will form? It will form zinc oxide and liberating hydrogen. That means Zn plus H2O, then simply we are having ZNO, that is the zinc oxide and the hydrogen. Then finally we are coming to the iron. So if we are talking about the iron is also going to interact in red hot state. So in red hot state, normally the iron is going to interact with the steam. The same thing, the zinc and iron is actually working in a similar way. So here the particular iron Fe is going to interact with the water H2O, and finally they are forming Fe3O4. And finally, the hydrogen gas has been liberated. Fine. And this reaction is reversible. Whatever we have studied, whatever we have studied, all are basically unidirectional reaction. But this particular reaction is the reversible kind. Fine. Okay. So now after this, we can simply go to this particular part, that how this thing is happening. This is happening due to the reactivity series of metals. So how we are saying that obviously means, obviously we have already studied about the reactivity series when we are studying the particular type or pattern of reactions at that point of time. So in case of reactivity series of metals, we can say that obviously first we are having the potassium, then we are having sodium, calcium, magnesium, aluminium, like this we are having in case of the reactivity series. So that is why the potassium is doing the vigorous reaction, because that has been placed in the top position. Then we are having sodium, that is less vigorous. Then we are having calcium, which is giving mild reaction. Then we are having magnesium, which is giving reaction with heated state. Then we are having aluminium, zinc, iron, all are giving their reaction in heated state. So why this thing is happening? So this thing is happening due to the reactivity series of metals. So obviously, if we are going for the metals below the hydrogen, then obviously they will not give any reaction with the water itself. Right. So below the hydrogen, we are having copper, we are having gold, we are having silver. So these things are not going to interact with the water because they are already placed in the lower portion of the reactivity series and after hydrogen. So they are not having the capacity to show any kind of reaction. They are inert towards this particular water itself. Okay. So this is how the reaction pattern is going on in case of this particular metals with the cold water or with the normal water itself. Then after cold water, hot water, everything with steam, we already studied all the conditions. And finally, we are going to the next one. So here we are having the action of steam on a metal. So what is happening in case of action of steam in case of this particular iron one? So can you tell me what is actually going to happen? You can simply find out that the hydrogen gas is going to be evolved. If we are going to place the metal sample, and then we are putting the metal sample over here, and we are putting the glass wool also, which is soaked in water. So finally, in presence of moisture, obviously this metal sample is going to interact with them, and finally they are producing the gas. And if you are burning a particular that stick in this particular hydrogen gas, you can find out that it will burn with the bluish kind of flame. So it is giving the identification of the hydrogen gas itself. So whenever a metal is going to interact with a particular steam, they are basically evolving the hydrogen gas. So this has been proved with the help of this particular experiment. So finally, now after this, we are going for the next one, and we are having the next part. Here you can find out we are having the reactions of water with non-metal. So in case of your syllabus, you are mainly having two non-metals. One is carbon dioxide and one is obviously the chlorine one. So that is why I simply put this two. So in case of carbon, what is happening? Obviously what we are doing, we are simply passing the steam over the hot cake, or we can say the red hot cake. Hot cake means nothing but the coil. So we are just simply burning the coal or that cake in the red hot condition, and then we are passing the steam over it. And what will be happened? Obviously, whenever the carbon is going to interact with the water, it will form firstly the CO plus H2. That particular combination is known as water gas, because the coke is C and then we are having H2O. So C plus H2O, and that is going to give us the CO plus H2. That is the water gas. Fine. And if we are talking about the carbon dioxide and the water, then carbon dioxide and water, obviously, they simply going to interact with each other and they are forming the H2CO3, that is the carbonic acid. So this two condition you have to remember that obviously in exam they are asking about carbon dioxide or they are asking about the cake or the coal cake, that you have to find out. So obviously, if it is coal cake, then obviously the water gas has been formed, which is CO plus H2. But if carbon dioxide they are talking about, then obviously they are going to form the carbonic acid. So finally, after this, we are having the chlorine. So chlorine normally used to interact with water in presence of sunlight in a better way. And finally, they are producing the HCl, that is the hydrochloric acid. And they are also present the another compound, which is HOCl. Okay, and that is obviously the hypochlorous acid. And finally, whenever the hypochlorous acid has been formed, it is going to interact with the HCl. And finally, the decomposition reaction is occurring and we are having the nascent oxygen. So that part you can simply, means that part is not the basic interaction part in case of the chlorine and the water, but the basic interaction part is obviously the formation of the hydrochloric acid and the another one, that is hypochlorous acid. So these two products has been formed whenever the chlorine and water has been interacted. Fine. So after this non-metal part, finally we are going to talk about the non-metallic oxides. So first we are having the sulfur dioxide. So whenever the sulfur dioxide is going to interact with water, here I just put the sulfur dioxide with oxygen because it is giving us sulfur trioxide, and sulfur trioxide is going to interact with water and that is forming the particular sulfuric acid, right? That we already know. But in case of sulfur dioxide, when sulfur dioxide used to interact with water, it is forming what? It is forming sulfurous acid, H2SO3. And that particular H2SO3 is the sulfurous one, and then SO3 plus H2O is giving us the particular sulfuric acid. So in case of carbon dioxide, we already talked about carbon dioxide and the particular water is going to interact with each other and they are forming this particular carbonic acid that we already know in case of non-metallic oxides. And finally, we are having the nitrogen dioxide. So nitrogen dioxide is going to interact with the water and finally they are forming this particular nitric acid, which is obviously the HNO3 So the nitric oxide, the nitrogen dioxide and the water is going to interact and they are forming this particular nitric acid. They can also form this particular another product, which is nitrous acid, which is HNO2. Okay, so HNO2 and HNO3 both can be formed in case of this particular reaction, like the sulfurous acid and sulfuric acid for the sulfur dioxide and sulfur trioxide. Fine. So after this, now we are going to the next part, and here we are having the next one, that is this part. This is basically the metallic oxides. So now we are talking about the metallic oxide, and in case of metallic oxide, obviously we are having the potassium one first. So potassium hydroxide, and another one we are also having in case of calcium, that is calcium hydroxide. In case of sodium, we are having sodium hydroxide. In case of magnesium, we are having magnesium hydroxide. So whenever this particular water is going to interact with this particular metallic oxides, they are basically forming the hydroxide parts. So this is happening in case of this particular water reaction. So other than this, now we are going to the next one, and here we are having the other reactions. So in case of here, we are basically talking about the next one, and here we are having the copper sulfate, crystalline copper sulfate, which is going to have the water molecules attached with them. So finally, whenever we are putting the heat, obviously the moisture is going to be absorbed, and finally that is why we are having the CuSO4 or anhydrous copper sulfate, and we are having the water separately. Okay, so obviously whenever we are putting the water, whenever we are putting the heat, the water is going to be detached from that particular compound. So this is happening in case of this particular copper sulfate one. Copper sulfate going to be turned into the anhydrous compound. So other than this, if we are talking about simply the uses of water, then we can say that yes, it is going to be act as universal solvent. It is also a basic constituent part in case of the human body. It is going to retain the water cycle itself in a proper manner. And in case of industry, obviously it is helping, means no industry is there in case of the earth which is running without water. So obviously we need water for that. Fine. Okay. So another this particular hydrated and anhydrated product we are having over here. So we are having actually the anhydrous cobalt chloride. Whenever we are putting water, it is turned into the hydrated cobalt chloride form. So normally the anhydrous form is blue in color, but whenever we are putting it into the water, we can simply find that it is going to be the hydrated one. So the water part or water molecules are going to attach with them, and simply it is going to change its color from blue to pink. So simply we can determine the presence of water with the help of cobalt chloride. We also perform a test which is known as cobalt chloride test in case of the plants. We are simply sticking the cobalt chloride papers in the upper surface and the lower surface of the leaf, and we are actually able to find out that in which layer or in which surface the transpiration rate is more. Normally we used to find out that the lower surface is doing much more transpiration than the upper surface, because the lower cobalt chloride paper strip is going to be converted into the pink one. So this is how we are normally using this particular anhydrated and hydrated products. So here we are simply having the color change, that the blue is going to be changed into the pink one. So now after this, we are having the next part, which is known as the solution. So in case of solution, we simply know that solution is made up of two parts. One is solute, another one is solvent. So obviously solvent is the liquid part which allows the solute to dissolve. So that part is known as solvent, and obviously the substance which dissolved, that is known as solute. The substance which is dissolved or disappear in case of the solvent to form the solution, that is known as the solute. So finally, we are getting the solution that is a homogeneous mixture, right? So that is the homogeneous mixture basically we are getting in case of the solute and the solvent. Fine. So now after this, we are having some basic parameters of the particular solution. So first we are having the types of solutions. So first we are having the, first we are talking about the dilute and the concentrated. So I will come to this slide later on. So first we are having the dilute concentrated solution. So what is the meaning of dilute and what is the meaning of concentrated? So dilute means obviously a solution in which the amount of solute which has been dissolved is actually very small. Fine. So that is known as dilute solution, because obviously the amount of solvent is larger and amount of solute we are dissolving is very less. So that is why it is known as diluted solution. In case of concentrated solution, simply we can say that yes, the solution in which the amount of solute is comparatively larger than the solvent, then it is known as concentrated solution. So if we are looking towards this one, this particular picture, you can simply find out that in dilute solution, what is happening? Obviously, the solvent particles are more and the solute particles are less. But in case of the concentrated one, obviously, we are having more solute particles and less solvent particles. So that is going to be happened in case of concentrated and dilute solutions. So finally, now we are going to the next one. Here we are having another type of solutions, and here we are having true solution, the first one. True solution means it is having its own characteristics. That is the most important part. The solution is having its own characteristic. So firstly, if I am talking about the nature, simply we can say that yes, it should be clear, it should be transparent, and obviously it should be homogeneous. Next, we are going to the particle size. So in case of particle size, we can say that obviously it cannot be seen. That thing can be happened only under the microscope, it can be seen. Or if it is not going to be dissolved, then it is going to be settled down. Okay, so no particular solute is going to be dissolved. They are going to be settled down. Like in case of sand particles, obviously they are not going to be dissolved. They are simply settling down. And finally, the particles can pass. They can pass through the filter paper, because in case of filter paper, pores are there. So simply they can pass through the pores of the filter paper. That thing can also be happened. Next is, if we are talking about the separation process, then we can say that solutes can be recovered from the solvent, either by, obviously by the physical means and not by the chemical means. So that is a very important thing. So solute and solvent shouldn't interact chemically. They obviously present in normal physical interaction they are showing. They're not showing any kind of chemical interaction. So a true solution is basically what? Therefore, it is not, it can't be treated as a compound. It can be treated as a mixture. It is basically a mixture. It is not a compound. Okay, so that is why we can simply give the example of sugar, water, obviously. Okay, so sugar and water, we can simply give this particular example in case of true solutions. So after this solution one, next we are going to the different types of solution, and we can talk about the unsaturated and the saturated solution. Okay, so here we are having the true and the true solution, colloidal and suspension. So this part I am coming later. So next I am having the saturated and the unsaturated. So here we are having the saturated solution. So in case of saturated solution, we can't dissolve more of solutes. That is basically the characteristic feature of the saturated solution in case of a particular temperature. But in case of unsaturated solution, we can dissolve more amount of solute at a given temperature or at a particular temperature. So that is basically the unsaturated one. Okay, so we are having two parts, saturated and unsaturated. So now if we are talking about the saturated solution, so if we are doing the heating of this particular saturated solution, what is happening? They can dissolve more amount of solutes in higher temperature. Suppose I am adding sugar to a particular temperature in case of a glass of water. And after 10 particular spoons of sugar, they are not going to dissolve. So now what I can do, I can simply increase the temperature in case of the water, and we can easily observe that yes, now the sugars are going to be dissolved over there. So this thing can be happened. Or another thing you can simply do, that is you are putting more amount of water. So you are adding more amount of solvent. That thing you can simply do in case of this particular saturated solution. Then obviously, again, the solute particles are going to be solubilized over there. Another thing is also there, which is known as super saturated solution. So that part we are having. Just a second. Okay. So yes, here we are having the super saturated solution. So in case of super saturated solution, in case of this particular solution, how we can prepare this one? So a saturated solution we already know. Okay, and then we are increasing the temperature, and obviously more amount of solutes are going to be dissolved. Now, if this particular solution is going to be cooled out, then what is happening? Some precipitates we will observe, which is coming out from this hot saturated solution. So some precipitate is coming out. Okay, and this particular solution now is known as super saturated solution. Fine, because now what is happening? The hot solution is containing more of the solute, but it can't hold them because we are decreasing the temperature, and that is why some of the amount of this particular solute is going to be precipitated out. And that is why it is known as super saturated solution. Now, one thing is there is a certain exception. You can also found over here in this picture that crystals has been formed. So crystals are nothing but the precipitates of the solutes. Now, in case of certain substances, if we are talking about the Na2SO4, sodium sulfate. So Na2SO4 is basically, that is Na2SO4 10H2O, that is a hydrating substance. So normally with this particular substance, it is possible to cool a saturated solution without excess solute crystallizing over there. So in case of Na2SO4 10H2O, if you are making a saturated solution and then you are boiling, and again then you are obviously dissolving more amount of solute, and finally you are cooling that particular temperature and obviously the solution itself, but still you are not able to get the precipitate over there. Okay, so this is one exception we are having. So other than water, obviously in case of our earth, we are having many other solvents, like we are having this one, we are having benzene, we are having carbon disulfide, we are having petrol. So these are also particularly the other solvents which we are actually having. Fine, and we use this solvents also for dissolving many other materials. Like if we are talking about benzene, benzene is used to dissolve the rubber. If we are talking about petrol, petrol is used to dissolve the rubber, chlorophyll, those things. Okay, if we are talking about alcohol, alcohol is also going to dissolve naphthalene, iodine, etc. Okay, so other solvents are also present in case of our earth, and obviously they are dissolving other materials. So finally, now we are going to talk about the solubility. So finally, we are coming to the solubility part. And in case of solubility, solubility is the ability of the solute to dissolve in a particular solvent. That is known as solubility. Obviously, that should be, we should mention the temperature over there, because we already studied that temperature is an important parameter for the solubility itself. So now, if I'm going to calculate the solubility at a particular temperature, suppose T degree centigrade, then what we are going to do, we are just taking the weight of the solute divided by the weight of the solvent, and finally we are going to multiply it with 100. So that we can find out the particular solubility itself. So weight of the solute you can simply take in gram, weight of the solvent also we can take in gram, and finally we are multiplying it into 100. So this is how we are normally going to calculate the solubility itself. So now after this, if we are going to determine the solubility of a particular component itself, suppose in case of potassium chloride. Okay, so I'm going to find out the particular solubility in case of potassium chloride at room temperature. So what we will do, we will simply take first 100 ml of distilled water. Then obviously we are going to add the potassium chloride crystals, and then we will continue the stirring and the crystals will dissolve, and we will obviously repeat the process till obviously the crystals are not going to dissolve over there. Then we are pouring this saturated solution in a beaker or in a test tube itself. Finally, now after this, what we can do? We can simply take a clean glass dish, and then we are adding the super saturated, I should say saturated because no precipitation is there, so I can't say it as super saturated, the saturated solution over there. Obviously I will take the weight of that particular amount, whatever I'm putting in that particular watch glass, and I will also take the weight of the watch glass itself. Now after this, obviously I'm going to heat this particular solution, and I will wait till it's going to be dried up. Okay, and obviously some residue will be collected in case of this particular glass dish. So now I am again going to weigh this particular glass dish with the residue. And now I am noting the temperature of this particular saturated solution. Now what I'm going to do, I will take the solubility, or I will going to measure the solubility. So solubility is equal to weight of the solute by weight of the solvent. So what I will do, obviously I will take the weight of the solute. That means I will simply take the weight of the glass dish with the residue, and I will minus the weight of the glass dish from there. So I will get the weight of the solute over there. And finally, I am taking the weight of the solvent. So what will be the weight of the solvent? Again, the same thing, the amount of solvent I added. Okay, so that I will obviously going to minus from the residue one. Whenever the residue has been left out in the watch glass, I will take that weight and minus it from the first one. Then I will simply going to multiply it with 100 at the room temperature. So this is how we are going to calculate the solubility. Okay, so this is how normally we are performing the solubility calculation. So after this, finally, we can go for the next one. And here we are having the solubility curve. So in case of solubility curve, it is actually that x-axis is having the temperature and y-axis is having the solubility. So in case of solubility, we can simply find out that normally it increases with the rise in temperature. Whenever we are increasing the temperature, the solubility is also going to be increased. In case of normally NaCl, KCl, then in case of another, what we are having, calcium chloride, all are basically working like this. But the highest solubility is having in case of, we are having it in case of KNO3. Okay, so potassium nitrate is having the highest solubility at 100 degrees centigrade. So this solubility curve is basically giving us an idea about this particular solubility itself. So after the solubility, we are finally having the last one, that is the crystallization process. So in case of this particular crystallization process, we already discussed about it, that how we are making the crystals. But the process of crystallization is having the definition that the process by which we can separate the crystals or deposited the crystals from the hot saturated solution of a particular substance by cooling it slowly. That is known as crystallization. So simply the same process is actually followed up over here. We are having the impure solid that is dissolved in this particular solvent. Finally, after that, the solution is heated to evaporate most of the solvent. Finally, we are having the hot solution, and this is allowed to be cool. And now the solid is going to be precipitated as the pure crystal. So now the cold solution is poured off to obtain this particular crystals. So now we can dry the crystal and we can simply use them. So this is the basic concept towards the crystallization. So for today, we are having this much. And obviously next day we are going to continue with this particular crystallization, because in case of crystallization, we are going to have the hydrated substance, we are having the anhydrated substance, because in hydrated substance, what is happening? The number of fixed water molecules is actually going to attach with the particular component. Okay, so these water molecules are basically the water of crystallization. These water molecules are needed for the crystallization process. And that is why this particular substances are known as the hydrated substances. So we are having many, like we are having the washing soda, that is Na2CO3H2. We are also having gypsum, that is CaSO4 2H2. So different molecules or different components we are actually having like this. They are present in combined form with each other, the water molecule and the other component, and that is needed for the crystallization process. Other than this, obviously, we are also having anhydrous substances which do not require any kind of fixed number of molecules of water for their crystallization process. Like in case of potassium chloride, in case of another potassium nitrate, potassium chloride, they don't require any kind of water molecule for their making of their crystals. So these things we are having. We are also having another thing that is known as efflorescent crystals. We are also having deliquescent crystals. So deliquescent crystals are mainly the water soluble salts. Whenever we are exposing them into the atmosphere, they used to absorb the moisture from the atmosphere and they are changing into the liquid state. That is known as deliquescent crystals. The substances are known as deliquescent substances. We are having many calcium chloride, then sodium hydroxide, all jol lagle dekhbe, they are going to be transformed into the liquid one. So they are known as deliquescent crystals. In case of efflorescent crystals, they are normally the crystalline hydrated salts. Whenever they are going to exposed into the atmosphere, they lose their moisture. Deliquescent normally absorb the moisture. Efflorescent is going to lose their moisture. So they are completely losing their water of crystallization, completely or partially, both the way it is possible. And they are going to change their normal condition into the amorphous state. So whenever they are exposed to the particular environment, they are going to change themselves into the amorphous state. So these substances are known as efflorescent, and this particular phenomena is known as efflorescence. We are also having over here washing soda, Na2CO3H2. We are also having Glauber salts. Okay, so these are the examples of the efflorescent one. Okay, so this much we are having for today. So now just go to the class quiz and I'm just giving you the questions over here. The class quiz is 9 IC 9 IC3 CQ2. 9 IC3 CQ2. Okay, 9 IC3 CQ2. Nine IC3 CQ2. Okay, so I'm just starting. Okay, so the first question we are having that to enable water to conduct electricity, dash is added during electrolysis of water: ethanol, urea, glucose, dilute sulfuric acid. So tell me what will be the answer. You can unmute yourself and you can tell, because I can't receive the chat over here, because today I'm taking the class through mobile. So actually my laptop has been crashed out. So that is why I'm taking from here. So you just unmute yourself and you can tell the answer. To enable water to conduct electricity, dash is added during electrolysis of water. Okay, so the answer will be the dilute sulfuric acid. Okay, so dilute sulfuric acid has been added to enable the water to conduct the electricity, because whenever you are adding the dilute sulfuric acid, obviously the pH has been altered. The pH condition has been altered and the electrolysis will be goes on. Okay. So after this, we are having the next one, and here we are having the next question, that is sulfur is soluble in water, dilute hydrochloric acid, and carbon disulfide and kerosene. So sulfur is basically soluble in, it is not soluble in water. It is not soluble in dilute sulfuric acid, dilute hydrochloric acid. It is actually soluble in carbon disulfide. Okay, so the answer will be the C1, that is the carbon disulfide. Okay, so then we are having the next one, that which among the following is a mixture of two elements? We are having iron fillings and sulfur powder, sugar and common salt, water and milk and air. So I think you all can give the answer of this one. Which among the following is a mixture of two elements? Iron fillings and sulfur powder, sugar and common salt, water and milk, or air? You can unmute yourself and you can say. Okay, so the answer will be the iron fillings and sulfur powder. Okay, so that will be the first one. Okay, next we are having when non-metal oxide dissolve in water, the resulting solution will be. When non-metal oxide is dissolved in water, the resulting solution will be neutral, basic, acidic, cannot be classified. So it is actually going to be the acidic one. Okay, so the answer will be the acidic. Non-metal oxide reacts with water and they are forming the acidic solution. Okay, so after this we are having that who confirmed the formula of water is H2O. So the person is Davy, who confirmed that the formula of water is H2O. Fine. Okay. So the next question we are having, that heterogeneous mixture can be separated by hand picking, sieving and filtration, centrifugation, chemical method, ultracentrifugation. Heterogeneous mixture. So mixture means obviously they are not going to form the compound. They are simply the mixtures. So obviously we can separate them with the help of hand picking, sieving and filtration itself. So the answer will be A in case of this one. Okay, so next we are having next one, that is when potassium treated with water, dash and dash were formed. Potassium treated with water. So obviously what will be happen? Potassium K are H2O. Then what will be going to happen? Obviously caustic potash and this hydrogen. The first one, caustic potash and hydrogen is going to be formed. Okay. Okay, so next we are having suspension. Suspension is a homogeneous or heterogeneous? Suspension, তোমরা ওষুধে খাও suspension কি হয়? বাবা মা বলে না যে ওষুধের বোতলটা ঝাঁকিয়ে তারপর খাবে। সাসপেনশনে কি হয়? দেখতে পাবে পরিষ্কার যে নিচে অনেক পার্টিকেলস পড়ে গেছে আর উপরে লিকুইডটা পড়ে আছে। সো সাসপেনশন ইজ বেসিক্যালি হেটেরোজিনাস সলিউশন, যেখানে দুটো কম্পোনেন্টকে আলাদা করা যায়। ঠিক আছে, প্রেসিপিটেটেড হয়ে যায় একটা, আর একটা উপরে পড়ে থাকে, একটা প্রেসিপিটেটেড হয়। সো ইট ইজ বেসিক্যালি অ্যান হেটেরোজিনাস সলিউশন। Okay, so next we are having the next one, that is dash prepared water in the lab for the first time by combining 2 parts of hydrogen and 1 part of oxygen. So that actually done by Cavendish. Okay, so Cavendish prepared the water in the lab for the first time by combining 2 parts of hydrogen and 1 part of oxygen. Okay, so after this, finally, we are having the last one. The process of decomposing water into its constituent element is called ionization of water, atomization of water, electrolysis of water, none of this. So actually we all studied that whenever we are decomposing water into its constituent, it is known as what? Tell me. It is electrolysis of water. C, electrolysis of water. Okay, so this much we are having for today. Okay, So next day we will continue with the water pollution part. So water pollution has been left out. So that part we will continue in the next class and we will finish the water itself. Fine. Okay. Okay, so I'm going to end this particular lecture. Okay.